So good morning. My name is Jay Martin, and on behalf of the Ohio State University and Ohio Sea Grant, I want to thank you for attending the 4th annual State of the Science Understanding Algal Blooms Conference. First thing I want to do this morning is thank you all for coming. We have a total attendance today that's well over 300 individuals. I did go through some of the registrations. We have many different organizations here. I don't have time to acknowledge each one of them. But I do want to go through and highlight some of the groups that are represented here. This includes many governmental agencies from counties, cities, and states. Also at the federal level, we have USDA, NRCS, NOAA, and USGS. I want to give a special call out to some of the representation we have from elected officials. We have Luann Cook here from the Lieutenant Governor's Office. She's a Northwest liaison for Lieutenant Governor Husted. Greetings, thank you. Teresa Federer is a state senator, Ohio State Senator. So Teresa, if you want to stand and wave. We also have 2 Ohio representatives here. We have Jim Hoop. I saw Jim earlier today. Thank you, Jim. And we have Mike Sheehy, and I just saw Mike. Mike's in the back over here. From the federal level, we have David Wirt here, who is representing U.S. Representative Bob Latta. I believe David's here somewhere. And we also have Kayla Schriffer, who is representing Senator Bob Portman's office. Thank you, Kayla. We also know that there's other elected officials and representative of elected officials that pop in from time to time. If anyone's here that we haven't seen come in so far, we welcome you to stand up and introduce yourself right now, or approach us later and we can introduce you at the beginning of later sessions today. Okay, we also have many academic institutions here, including university and colleges, but I want to give a special recognition to students we have here today from the Toledo Public School System. I believe we have 3 groups of students here. First of all, we have Laura Kubiak, who's from the Aerospace and Natural Science Academy, and she has 6 students here with her, and I believe we're in the front row. And if these students and teachers want to stand up or wave, that'd be great. Thank you, Laura. We also have Luis Jimenez, who's here from Bowser High School. He has a couple students with him, and these students are unique, and they're working on an advanced electronics project focused on drones, and they're also working with NASA. So Lewis and those students, maybe they haven't arrived yet. And we also have 13 students from Scott High School, also part of Toledo Public Schools, who are brought here by the teacher Janine Blosser. So it's very encouraging to see the next generation taking an interest in these issues. Lastly, I want to acknowledge representation from many agricultural groups, business, industry, consulting firms, and NGOs. I think this is especially important that we have broad representation as we search for win-win solutions, such as those that improve water quality and maintain agricultural production. So again, thank you all for coming. It's great to see so many people here today. Next, I'd like to thank some of the people who made this event possible. First of all, I want to thank our speakers from today who come from as far away as Maryland. We have a great program for y'all, and thanks to those speakers. Some of the most important people to thank are the sponsors for this event. It's only with the sponsorship from the individuals, from the organizations I'm going to acknowledge in just a minute, that we're able to keep the registration costs very low. Some of you might not know, but the registration cost for students is a mere $10. And so we have good representation from graduate students, undergraduate students, as you saw some high school students as well. I'm gonna go ahead and read through the different sponsors that we have. We have the Joyce Foundation, Great Lakes Center for Freshwaters and Human Health at Bowling Green State University. There we go. the Herb Family Foundation, and I do want to mention that the Herb Family Foundation has brought several maps of the Great Lakes, and they're at a table behind me, and they have encouraged anyone who would like a nice map of the Great Lakes to take one of those. So thanks to the Herb Foundation for their sponsorship and also for the maps. Great Lakes Commission, Lake Erie Foundation, National Wildlife Federation, Ohio Farm Bureau, Ohio Corn and Wheat, Ohio Dairy Producers, Limnotech, Ohio Soybean Council, the Nature Conservancy. And I also want to acknowledge that two of our long-term and constant sponsors over the 4 years have been the College of Food, Agriculture, Environmental Sciences, and Ohio State University Extension. And during the last 2 years, since Kath Ann Kress has become the dean of this college, there's been an added focus on water quality. This morning, I'm very pleased to announce Heather Raymond has recently accepted the position of the Director of the Water Quality Initiative for the college. And I welcome Heather in this role, and I'm going to ask Heather to come up and give a few brief remarks this morning.
Thanks, Jay. And many of you here already know me from my former role as Ohio EPA HAB coordinator, and I really see this new position at OSU as being very similar in the sense that I will continue to work with academics, the researchers, and the state agencies, and also my local partners on the shared goal of water quality protection and restoration. I will be collaborating with the state agencies and trying to get a better sense for what their applied research needs are and where the priority watersheds we should be working in are located, and then also working with both researchers inside and outside of OSU on collaborative interdisciplinary research projects that are focused on addressing those agency needs and priorities. Then we have an exceptional translational staff at OSU that I'll be partnering with to try and make sure the information and the data we gather is able to be broadly disseminated in an easy and user-friendly format, so getting that more accessible information out there. OSU also has researchers in all 88 counties, and I'm excited to say we have partnered with NRCS to recently pull in some additional resources and educators that will be located in the Maumee Watershed, specifically focused on water quality and technology projects. We also have, of course, exceptional facilities at Stone Lab. So we're well equipped to help ensure that the valuable lessons we are learning are disseminated widely and that we can lead to broader support of implementation of effective BMPPs at the local level. I grew up in Lake Erie. I grew up in Sheffield Lake along the shores of Lake Erie. I spent a lot of time in Lake Erie swimming in it. And I'm really excited to be in this new role and to help working with all of you here on issues to help address these HAB impacts to Lake Erie and also our inland lakes and our shared water resource protection goals. So excited to be here. I don't want to cede any more time. I know that we have a very expansive program, and please reach out to me for future collaborations. Thank you so much.
Thank you, Heather. I'd also like to thank the other co-chairs who I work with to plan this meeting, and these include Dr. Kristen Fussell and Chris Winslow from Ohio Sea Grant, up here in the front. Dr. Kevin King is over here on this side. And Greg Labarge, who is just behind Kevin. Important thanks is directed to Jared Morrison and Shalise Simmons, who are probably at the registration booth right now. They are the event coordinators who make this whole event possible. So you can thank them for coordinating the registration, the lunch you're going to have later, the budget, name tags, venue, and probably lots of things that I forget about. Key support from other individuals at Ohio Sea Grant's also essential, including Aaron Monaco and Jill Gentes. And I want to give a special shout out to Joe, who's our AV person, who's the man behind this curtain right here that keeps all the screens running, keeps us on time, and is going to spin some great tunes as we move through the day. Bottom line is it takes a lot of people and groups to make this event happen, and it's really worthwhile when we see a crowd like this morning. Now I just want to spend a few minutes to talk about logistics for today. We're going to have constant beverages available in the back corner, and I see that most of you already found the coffee. We have 2 restrooms. Accessible restrooms are available just behind the beverages. There's also another set of restrooms up these stairs to my left. Today we're going to have 5 sessions. The first one of those is going to be focused on collaborations and partnerships that are critical for improving water quality. After this, 11:30, we're going to move into an hour-and-a-half lunch break. So lunch will be provided in the back of the room. Something new we're trying this year is we're having posters at the same time as lunch. In the past, the attendance has dropped off as we've had posters at the end of the day. So we think that having posters during lunch will increase the possibilities for you all to interact with the poster presenters, and you can see those are lined up on the wall to my left. So I really encourage you to visit with the students who have put together these posters and look at them. There's some great research there. After lunch, we have a special highlight today, and that's what we're calling the director panel. And this is going to include the directors of 4 state agencies that are guiding policy and programs to address harmful algal blooms within the state of Ohio. And I want to thank those of you who did submit questions. Those will be the questions that we ask the directors after they conclude their introductory remarks. The 4th session is going to focus on research that's happening from the watersheds to the lake, and the 5th and final session is going to focus on best management practices, results, adoption, and dollars. And I want to highlight that at the end of each of these sessions, we're going to have about 15 minutes for summary and questions and answers. And you can see that we do have microphones in the center of the room. So if you do ask a question during this time, I encourage you to go to the microphone so that the whole group can hear your question clearly. The last announcement I have is to encourage you to complete the post-conference survey, which you should receive in an email towards the end of the event. So we're trying to keep this event relevant, and we're also trying to respond to your needs and the topics that you want to hear of in future events. So please respond to that survey and let us know what you think about what we're doing so we can continue to make improvements in the future. So with that, I'm going to open our first session and introduce our plenary speaker. So it's my pleasure to introduce Rich Batiuk, who is our plenary speaker this morning. Rich was the Associate Director for Science Analysis and Implementation at the United States Environmental Protection Agency's Chesapeake Bay Program Office, which is located in Annapolis, Maryland. He served in this position for 33 years, and in this partnership, he led the integration of science into a multi-partner policy-making, collaborative decision-making entity. So when we're talking about collaborations, this is the guy we need right here. Now, since he's retired, Rich has teamed up with Holly Greening, a former director of the Tampa Bay Estuary Program, and they have co-founded the Coastwise Partners to apply their combined 70 years of experience to provide help with the development, implementation, and collaboration of watershed management strategies. It's really interesting. Rich is working with people, groups as far away as New Zealand. He's working across this country, East Coast and West Coast, so he has a real broad perspective to share with us this morning. One thing that's also interesting about Rich is he doesn't really get paid in this position, but he says that he works for good food. So when he goes to these different places, he does require that they provide him with ample food resources and hopefully high quality. Lastly, I'll mention that Rich got his BS in environmental science from the University of New Hampshire and his master's in environmental toxicology from American University in Washington, D.C. So, what's that? Go Eagles. All right. So welcome, Rich. Podium is yours.
Thanks, sir.
Thank you again.
So when you're on the North Island of New Zealand, they've got some darn good food down there. Some of it I didn't know what it was. Talking to the New Zealanders, I couldn't understand half the words they said. They were talking in English, but my gosh, so they have wonderful accents, but they're really cool down there. So, want to talk to you, folks, there's some good news, and that is you can have a watershed whose population has increased by 50% since 1950 and make a difference. You can have over 6 million acres of productive farmland working with 75,000 farmers, with soybean, with corn, with beef and dairy, and you can make a difference in local streams and rivers. You can work with over 470 significant wastewater treatment plants, over 3,000 smaller treatment plants, and make a difference out there as well. You can work with 1,650 local governments, and against that human tide and the challenges of global warming, et cetera, out there, you can make a difference. Why did I say that? Because we've done it in the Chesapeake. Are we there yet? Absolutely not. Have we made progress against it? When I started 34 years ago, we were 12 million people. We're now over 18 million people. I brought my family down there. Absolutely, I'm part of that. But you can make a difference in that particular system. And what I want to share with you is why? How can you do that? A key to it, we found, is pretty simple. It's a partnership. There's a complexity to that. I want to talk you through how we did that as well. But before that, I want to give you some images of the Chesapeake. I had an opportunity last night to do some circling around Lake Erie as we were waiting for thunderstorms to get out of Detroit. It's kind of neat up there at 12,000 feet, but after the 16th turnaround, it said, okay, guys, I didn't see any algal blooms, but I saw some clouds. But we can share that as well. But take a look. This was an interesting video done by one of our advocacy groups out there as well. But here's some images of the Chesapeake. That was actually put together by the Chesapeake Bay Foundation. They have over 100,000 members across the Chesapeake Bay watershed. Not advertising for you, but what they did is they got a team of photojournalists, gave them a day, sent them across the watershed, and give me images of what you think about the Chesapeake as well. This was done several years ago because you saw it, we were only at 17 million people. But it was also before we started to see the response of the system that in the last several years, the work that we're doing is paying off out there as well. I want to give you a quick rundown of what I would consider 6 key lessons that we've learned over the last 3 decades of working together. I want to simplify that. We can make my presentation available, but it's down to these 6 pieces. You need a management structure, and I'll show you that. That sounds a little business-like, et cetera, but that's true. You're restoring a watershed, an ecosystem. You need a lot of partners at the table, but you also need rules about how they work together, that they feel inclusive and listened to and acted upon. Second, you need a strong scientific foundation. You don't have that, we don't have restoration efforts in the Chesapeake because science indicates which direction we need to go, and I'll talk about that. One of the most important things we did for our public, and that is we got our governors, our mayors, our local elected officials to agree to numeric goals, where you're going to go. If you don't have an end goal, how the heck do you know how to get there? So that was critical. We had to have a very simple definition of clean water. My neighbors, folks that boat on the waters, folks that drink the waters, my farm community, my municipal authorities, they needed to understand it and buy into it as well. You need to monitor that system, report to the public, and then come back and reevaluate and repeat that cycle again. And then finally, the one thing that we haven't done very well in the Chesapeake, we set a system up for doing that, and that's hold each other accountable. That's one of the most difficult things that we need to do in order to be successful in the end, and I'll take you through that as well. I'm not going to walk you through this complex chart up here. Think of it as a large tent. Think of it a tent that has room under there for your farm bureaus, for your municipal authorities, for your elected officials, for your advocacy groups, for folks interested in fisheries and wildlife, folks that are conserving lands out there, people that are working on different issues that have connections with diversity and with urban farming and rural farming out there as well. That there's an opportunity for them to be at the table to ensure that they know that they have the ear of the governors, that they're elected officials, they have access to their scientific community, that the local voice is in there as well, that the business community is active at the table as well. That's what we've got in place in the Chesapeake Bay. Not only that, but when you think of a healthy tree out there, you think of a healthy root system. By golly, do we have roots in the Chesapeake, and that is, under these 6 boxes, these are our 6 goal areas that everybody's agreed to, what we want to do. Not just bring back clean water and fish, but stewardship, education, and how we work as a partnership are key to that. But underneath these green boxes are our work groups, where we bring literally hundreds of technical folks, programmatic folks, and here's where they have a seat at the table to deal with issues, whether it's catfish or climate change, diversity, whether it's how to capture different folks and bring them and educate them from K through 12 in there as well. So that partnership is a large tent, but you have to have rules to figure out how to do it, and you have to institutionalize that structure. But we also did, too, early in the stages, and that is involve the highest levels of leadership. I'm not just talking about governors of the 6 states and the mayor of the District of Columbia, the EPA administrator, the Secretary of Agriculture, that's important. But we also brought in our township supervisors, our county executives, our mayors out there. We brought in our administrators and leaders within our academic community, within our business community, within the advocacy community. They had opportunities to come to the table and lead their parts of the program. So even though I'm EPA, and EPA was a piece of the funding, it's not an EPA program. It's actually led by our states, quickly by our local governments, by our farming community, by our business community, municipalities. They all have seats at the table. They all have leadership responsibilities there. But trying to, and across all those different sectors, bringing in the highest leadership has been important. One of the things, too, and that is to how to keep such a partnership going, keep it effective, is to institutionalize some things. In other words, bind them together, and I'll show you in a minute, through high-level agreements. Everybody needs to have a roadmap, and where they fit on that roadmap. That's been critical. A governance structure, as I said, where there's a seat at the table. If you want to join and you want to contribute, there's a seat and an opportunity for you to be there. There's also a governance structure that allows you for your voice to be heard, but for all the other almost 1,000 voices under that management structure that we have in the Chesapeake Bay itself. How do you vote? How do you make decisions? How do you agree to consensus? How does that work up the system so that you can keep moving? One of the things we did uniquely, and took EPA's budget, which started out at $3 million when I started, and now it's at $78 million. That budget, those decisions are made collaboratively by the partnership. That was unheard of in my agency and elsewhere. That's how you bind people. It's a small piece compared to the hundreds of millions and billions that our state, federal, local business communities have invested, but it's a glue that holds us together there as well. We share information. In this particular age, unless you can get access to a couple million data points instantaneously, some of my younger colleagues sort of go, oh, come on, man, I got to get access to it. I had to tell them, you had to bring this mag tape over to put this on the system and run it back in the 80s, and they look at me like I'm crazy. And then their ringtone is this phone that I recognize from the 1970s. We'll figure that one out. Implementation actions, whether it's upgrading a treatment plant, putting in a bioinfiltration system below the streets, or putting a cover crop on an ag field, we're tracking it across the Chesapeake Bay Partnership. We've got almost a 30 to 40-year history of what's happened on the land. That's been a tough road to go, but it's been critical to the kind of work that we're doing out there. And then finally, as I'll show you in a minute, collaboration on shared decision tools, whether it's Modeling systems, how you measure data, how you say whether the system's impaired or not, how you count the number of catfish out there, and do you need to change your harvest rates out there. Having lots of fingerprints on those tools, and it's not a USGS one, an Ohio State, excuse me, the Ohio State, was that right, Chris? Yeah. It's not somebody's, it's the partnerships. When you go in the Chesapeake, when you talk to our partners, they don't say they talk about we. That's the difference when you know that you've made a difference out there. Science, it has got to good sound science, not this play word that's out there, but what your academic partners, your folks that are involved in research in the business community get involved in. We have had, since the early 1980s, an advisory board, what we call the Scientific and Technical Advisory Board, that the partners have turned to on issues from oysters to land conservancy to global climate change to this particular issue, and that is one of the last remaining dams on the Susquehanna, about 50% of the flow into the Chesapeake Bay. It was damming up pollutants for decades. And we found actually recently that it's no longer the best dam BMP. Oh, that's a joke, guys, you hydrologists out there. BAM, BMP, got it. A lot of controversy between two states, Pennsylvania and Maryland. There's this Mason-Dixon line, war of northern aggression between the two of them. You guys think you got issues with Canada. You know, come on. We had to go back to our scientists and say, pull out the facts, get the governors straightened out, let's figure out how to not point fingers, but how to deal with this new, quote, new source of pollutants out there. You've got to have that independence of that science in there. We do it not just for one university, but drawn from our community colleges, to our land grants, to our sea grants, to others out there as well. Take advantage of that. But go to them as the authorities to do that. Invest in good-looking gentlemen like that up there. For 25 years, part of my role, even though I was EPA, I worked for a partnership. If the governor of Virginia was heading up our executive council, I worked for him. If the Natural Resources Secretary for Pennsylvania was heading up one of our committees, I worked for her. If the Farm Bureau was leading our ag work group, I worked for him, or her, or them, depending on who was out there as well. You got to synthesize that information together and package it up for the right audience. Not for the news, but for that township supervisor, for that municipal authority, for that group that's out there, for that governor, that mayor, that congresswoman that you need to work with. And then on the right-hand side, you've got to bring your partners together. In this case, it was a University of Maryland-led effort that said about 5 years ago, what's working, what's not. It was fascinating when you gathered the information and say, that's working in ag, but in stormwater, it's not. The community then recognized the good work over here and where we need to turn attention. Not pointing fingers, but where you need to put your attention out there as well. Models, you know, that can be a little confusing. Weather models, et cetera, out there. In the Chesapeake, we've used models because we've got 64,000 square miles, 18 million people, 75,000 farms out there. We've got septic systems in the millions out there we needed to track and understand. And we've got about 10,000 miles of shoreline and 10,000 miles of streams coming into the Chesapeake. Each one of these suite of models are partnership-based. They're not a U.S. Geological Survey model. They're not a Virginia Tech model. They're not an EPA or NOAA model. They are actually partners working together. Our Watershed model has information from our soybean councils. Each one of our about 400 counties actually looked at our land cover, land use data and was able to mark it up to then say, that's not a cornfield, that's a Walmart, guys. We need to figure that out. They bought into that. So these models had literally input from hundreds and hundreds of not scientists, but others across the watershed that needed to give us accurate information on weather conditions, how many menhaden we had out there because they're filtering the water in that particular system, and changes in land use from 1950s, and then we projected out to the 2040 time period as well. Models don't give you the answer, but there's support. They can provide information at that detailed scale, and we moved them down to the sub-county scale because our local governments were saying, I don't care about the Chesapeake, but I care about my local stream, my river, my source of water out there, and eventually I know I've got to help my downstream neighbors. So modeling was just one way of combining a tremendous amount of science, but each of these models are the partnerships models. They're signed off. Would you imagine your cabinet level secretaries signing off and looking at model calibration data? We put them through it. Not a lot, but enough, because we wanted their fingerprints from all 6 states in the District of Columbia and their federal counterparts to buy into the science that's underneath there as well. Not that they bought into every scenario, but it was their tool to be used for the decision making individually and then most importantly collectively. Blue crabs. I know you guys don't have crab. Well, okay, don't have crabs up here in that. Crabs are one of our holy species. We have rockfish, crabs, and oysters. We fought wars over them, oyster wars, etc. But the important piece is here is to set a numerical goal that in this case the fishery scientists bought into, but our politicians also did. Why? Because the two thresholds you have here, one, the threshold down on the bottom, below that, you're going to lose the crabbing industry. That means recreationally, commercially, and actually socially. Crabs are not social. It's when you steam them up, put them on a table and bring friends around the table. It takes at least 3 or 4 hours to sit there and pick them, eat them and stuff, and you're still hungry afterwards, you keep eating and stuff. But the conversation is great, particularly on your third alcoholic beverage. Below that threshold, you lose that industry. Above that target, have at it. Take as many crabs as you want. We were about to lose one of our last commercial and recreational industries in 2002. We got together, and look what happened. If you have a goal, you can actually manage a fishery between two states differently. Each year, we count the number of females. Sorry, you males out there, you're only good for one thing. Females are important to us. We watch the females. If they go down, the states actually change their management for the next year. That means recreationally, commercially, how you do it, what the harvest levels are, et cetera, out there. Having numeric goals allows you to manage the system, and my neighbors who crab out there are watching these numbers because that means what their season is going to be out there. And it also means the price of crabs out there as well. Numeric goals are important, but you have to have the science and the backing of in this case, the management community and the policies, and what we call our commercial fishermen, watermen. Pretty simple. You guys know what an A, a B, a C, a D are. I can ask your students over here. We know what grades are. Well, look at that. We actually have a university, University of Maryland, Center for Environmental Science, every year puts together a Chesapeake Bay report card. Why a university? Because universities are seen as unbiased. Well, until football season, but before that, it's okay. But they brought together the science, and every year they put out a report card on behalf of the partnership of saying, how do we do? I tell you, mayors are looking at this, governors are looking at this, watershed organizations are looking at, did my grade go up? And there's a lot of local papers saying, aha, or others trying to explain, how did I get a D- this year? It's the trend that's in there. The partnership puts out the Bay Barometer that talks about other issues out there. But I tell you, having reporting to the public in simple terms that say, what's happening out there? And how's that river system doing? They're actually taking this report card and actually going out of the tidal waters and going up the streams. So folks are setting up their own report cards. It's an easy way of describing progress and what actually needs to happen out there as well. You've got to report to the public. We call it our interested public. We're not going to get the attention of all 18 million people, but you're going to get interested people in particular issues to them. They may not like crabs, but they want to understand that the water's safe for their kids. They want to have recreation out there. They want to have their economy, their real estate prices reflecting clean water. This is a listing of all the different agreements that we've had and evaluations in the Chesapeake Bay watershed itself. So since I came in right after the first Bay agreement, and notice how many you have a second agreement, you have amendments, you have an evaluation, a third agreement, evaluation, this thing called the TMDL. This is our Bay pollution diet for the 18 million people in the watershed. A fourth agreement, and then a deadline to get clean water out there as well. A good, healthy partnership will go back and say, hey, I've got new science, I've got new understanding, I've got more people in the watershed. Do I need to do something different? There are trends in the farming community. We've got new tools in stormwater. What the heck are you going to do with the change in temperature out there and the flashiness of these storms? And how many 100-year storms do I have to live through? I'm not that old, but I've seen a heck of a lot of them out there. It's changing. Well, the partnership actually does what governors and elected officials don't like change, but they want the best information in there. So we do something. We've compromised. About every 5 to 7 years, we step back, bring in new information, update our pieces. That goes into perhaps a new agreement, new policies. Our governors, our mayor, our elected officials agree to it. That becomes our mandate. But our scientific community then continues to work and bring that back. So our scientists know there's an opportunity to build it into the policy. Our policy folks know they're going to have stability. And at the same time, they're going to have the latest science built in there as well. So you're not questioning yourself continuously. There are opportunities to bring that in there. And those agreements are important because they describe, between administrations, local, regional, state, and federal, here's the game plan of how we want to proceed from here. Here's how we want to work across hundreds of agencies, across over 600 different watershed organizations and nonprofits out there in the Chesapeake Bay watershed. What's their piece of the pie? Well, that agreement lays that out for them as well. It may sound simple, and that is to define clean water simply, but it was one of the most important things we did in the Chesapeake, because up to then you were in court deciding of whether that stream or that river was impaired or not. We did it even more simply. I knew I had to, not that I have dumb neighbors, they're good. They're sailors, good. Motorboaters, but we'll talk about that later. We like fresh air down in the Chesapeake. Even simpler, you need oxygen, light, and good food. My neighbors could understand that. Kids hold their breath when they want to do something, but you know they're going to eventually open their mouth and get more oxygen. Fish, crabs, oysters, things in the aquatic system need oxygen. Light. You know, a lot of us have houseplants. If you put them in the closet when you go on vacation, you come back, they're going to be dead. Seagrasses are critically important to the Chesapeake itself. Even algae, good algae. Good fish, good food, we call that good food is good algae that then works its way in there. We have harmful algal blooms as well. Thank you very much, Lake Erie. I think you imported it into us. You know, this HAB thing, my gosh, Chris, come on, buddy. This is, you know, but simply, you can define that. What you don't see is the carbon cycle. What you don't see is the nitrogen fixation cycle. What you don't see is PFOS, WSFOS, dissolved phos. Not a single one up there. People can understand that. I had to have New Yorkers convince New Yorkers to do something. It's pretty tough. They're 450 miles upstream. They don't have a Chesapeake Bay benefit, but they bought into our definition of it. Why? Because we're asking their farmers, their cities and municipalities to do something for their own clean water, but for their neighbors downstream. We got these bought into state water quality standards. We did something unique, and that is at the same time we got 4 different states to adopt regulations consistently across the board. One of the first things we did is we went and developed a planning and zoning map for the Chesapeake. We took away these definitions that humans put on there since around 1607, and that was Virginia, Maryland, Delaware, and Washington, D.C. We pulled those away and asked Mother Nature and the fishery scientists, what do you need where? In the shallows, we need light. Underwater grasses need to come back for crabs, rockfish, oysters, Spanish mackerel, a whole bunch of species that some of us enjoy eating or catching or just knowing that you have clear water out there. In the midsections of the river, things like spot and croaker, these are bottom-feeding fish. Oysters down deep where we have no oxygen right now. We actually need crab food for those hungry crabs I showed you earlier. In that open Lake Blue area, you know, those are commercially and recreationally harvested species out there as well. In the bottom part, that's what we talked about in regulation. In the top, we always talked about the species and what we're trying to get done. So this was our planning and zoning map. In Clean Water Act parlance, it was our designated uses. We want to try to bring back. Then we also talked to our scientists out there and said, hey, if you're a spawning mother rockfish, before 2004, you're coming into the Atlantic Ocean down in Norfolk. You have one level of dissolved oxygen that Virginia gives you. You have a different level in Maryland, and then at D.C. you have a third level. Folks, she's pretty pregnant. She's got about 3 million eggs in there. If you talk to a pregnant rockfish, you do not want to piss her off. You want to give her good oxygen, and when she lays her eggs, her kids, all 3 million of them, not only going to survive, need to have good oxygen. It was state by state by state. Didn't make sense from the natural critters. So we looked at the science, said, mother rockfish, she actually needs higher standards than the states currently have. We adopted it. But if you're a spot or croaker or worms down the bottom, naturally, evolutionary-wise, you don't need that much oxygen. But right now you have no oxygen. You can't survive. So we used that science, got all 6 states of the district, and our industry, our municipality, our farm bureau groups, our stormwater groups, all agreed to this common definition of clean water: oxygen, light, and good food. Built into the standards, there's not been one lawsuit in the last 20 years of this, not one disagreement about clean water is. A lot of disagreements about how you get there, but we know what the end goal has been out there. And that allows you to do what we do here, and that is buy what we call our different habitats. Simply, it said if it's green, you're there. If you're blue, you're close. If you're red, like you are in the deep area, you're still a long ways there. This combines about 106 different segments of the Chesapeake that have different needs because of different salinities and habitats, but in simple maps, we can tell us, are we making progress or not? This is a water quality standard. It's done the same way across 4 different states. So somebody in Albany and somebody in Norfolk would take the same data and come up with the same answer. That's how you prevent lawsuits. That's how you ensure that the focus is on not what is clean water, but how to achieve it. And finally, monitoring. Not the sexiest topic out there, but critical. Understanding what the rivers and the streams and the critters out there, how they're doing. Here's our 2 monitoring systems. One on your right-hand side that's about 160 stations in the tidal waters. We're now coming into our 4th decade of doing it collaboratively across universities, state partners, and others. On the right-hand side, we built that about 15 years ago. That's our free-flowing streams and rivers, about 120 stations. We send folks out, men and women out there, in storm events, in hot weather, and they're collecting samples. Why during storms? Because 80% of our pollutants come in when it's raining out there. And they capture it, they're sitting on that river system until it does that. That's a lot of work. But I can take any station of those 2 from one decade to another and ensure the quality of those 2 data sets are there. Why? Because our partnership makes partnership decisions and oversees the quality of that collective data. It may be somebody's individual program, but it's part of a network. That's the difference between being a program and being a partnership. Every decision to change a station, to lose something, et cetera, is made by the partnerships, not the funding agency. There's about 20 different agencies and organizations that do that. We make collective decisions on individual parameters or whether we're going to lose a particular stream flow station or not. Why? Because that station can tell us about flooding, drinking water, as well as quality of that water out there as well. You have to work in that, and that's got to institutionalize it. But when you do that, you're talking about tens of millions of data points generated every year and then reported to the public within months thereafterwards. That's a partnership that's working. But it also can change. Here you can see where the arrow stops or starts. We've made modifications. As our policymakers and program managers said, I need more information here, that piece is not working for us. It's not like it's a God-given right to have a monitoring station in a place and don't touch it. Or bridge changes somewhere, et cetera. That in fact, what we sample out there changed and evolved over years, but by decision by the partners. We've actually gone to our cabinet level secretaries every time and said, we're making this switch. Are you comfortable from a policy perspective? They don't often talk about monitoring systems. They do in the Chesapeake. Public accountability, one of the toughest things to do, to finish up here, and that is, it was actually Tim Kaine, before he was Hillary Clinton's vice president nominee. He actually, as a governor in 2008, told his other governors, I'm in office for 4 years, I'm out, somebody needs to be held accountable beyond just my term. They set up an accountability system we can talk about offline here, using 2-year milestones, feds, states, locals. But they also said, we need to highlight, particularly our states, if they're not doing what they've been accounted for, the public needs to understand it. So if you're in Pennsylvania, you have 2, not black eyes, you have 2 red eyes. That's public information out there. If you're in West Virginia, you're doing good. You're doing something different. We allow folks to do whatever path they want to get there, but publicly to say, are you on track to what the public agreed to? The yellow, if you're in Maryland, the Maryland governor did not like that at all. But we said, held steady, you're not doing well on your stormwater program. You got to improve it. He's working on doing that right now because of that public piece. And then finally, Pennsylvania, I want to poke at him for a second. They should be 34 million pounds down. This is our modeling scheme out there. They've only reduced 15 million pounds of nitrogen to date. We had a challenge to all 6 states in the district to get 60% of the way by 2017, and the remaining 40% of the way they're done afterwards. They've done the reverse. We're not saying that they're bad or whatever. We're saying you need to put, they've got thousands of miles of impaired waters. They can forget about the Chesapeake. They need to clean up their own waters, but we need to hold them accountable, and here's how we go about doing that. So, before I switch and finish out with how's it working out there, I've got another video for you, quick one to keep you awake. Here's what it means to be a partnership.
What does it take to restore and protect the Chesapeake Bay?
It takes science and technology, collecting scientific data and water samples from across the bay and its tributaries.
And then analyzing those samples here in the lab to help monitor pollution and determine its effects.
Constructing living shorelines that provide habitat for native plants and animals and help protect human property from storms and erosion.
Using advanced sonar technology to map the seafloor and find the best places to rebuild oyster reefs.
And putting billions of baby oysters into the bay so that they can reproduce, create new habitat, and help filter the water around them.
Conducting population surveys to help monitor and protect the bay's iconic fisheries and the underwater grasses that many species rely on for survival.
Studying environmental impacts on fish and wildlife throughout the Chesapeake watershed. and building unprecedented partnerships to conserve a network of healthy habitat for their benefit and ours.
It takes teamwork and collaboration, developing new ways to visualize and share information through a connected community of scientists, organizations, and government agencies.
Cleaning up trash from our rivers and streams and helping connect people with their communities and waterways.
Restoring damaged streams to improve local water quality and reducing the flow of sediments and pollutants that threaten underwater life in the bay.
Creating environmentally sound solutions for the businesses that drive our economy and conserving the natural resources we farmers rely on to grow our crops and feed the nation.
It takes action in our communities, from updating our local wastewater treatment facilities to reduce our environmental impact,
to adopting green technology that captures and holds stormwater before it can pollute our rivers and streams.
Conserving forests and wetlands that filter our water, clean our air, and provide a wealth of benefits to the people and animals that live in the watershed.
Improving public access to the bay and local waterways.
And conserving headwater streams to provide healthy habitat and clean water for fish and fishermen.
And it takes our commitment to success, from creating conservation jobs that put young people to work improving their neighborhoods, to connecting local communities with resources they need to heal the land and water. Because it's not just about restoring the Chesapeake Bay. It's about making the entire watershed a safe and healthy place for all of us to live.
Learn more by visiting ChesapeakeBay.net and join us in partnership to restore and protect the Chesapeake Bay.
So you just heard about 20 voices out of about 1,000 that are part of the partnership. You heard one of my favorite farmers. You heard somebody from Ducks Unlimited, somebody from Trout Unlimited. You heard a pastor from one of our churches in Frederick, Maryland. You know, look at all the diversity of voices out there. They were showing what they're doing and their piece of it as well. That's how a partnership works out there. So it's working. In my last couple minutes here, let me go through and say, why am I optimistic about getting there even when that next million people are coming in? The Clean Air Act is working. We've seen, our scientists have measured in our first order streams, nutrients, particularly nitrogen, are going down because we're getting cleaner air in the system out there. Whether it's from China, from you all out here in the Midwest, our airshed, not a watershed, but our airshed, where 75% of our pollutants in that yellow area. You guys are in Ohio, you know, we got you covered, literally. So thank you. We did something with wastewater that doesn't happen in government. Feds, states, municipal authorities work together to not only achieve a goal, they achieved it early, they achieved it with lower cost. And not only that, they're actually going below the goal there, and they're going to trade it with other systems out there. That's working. Clean air, clean water is occurring out there. There were some extremely smart fiscal folks, some extremely brilliant engineers, from small treatment plants to ones that are serving Washington, D.C. That is truly amazing to see that happen. Consistently, not one lawsuit, with a lot of flexibility, here's what you get. Imagine you started out as a diet with 18 million people, and you lost 50% of your nitrogen going into your system. 50% change in nitrogen levels. Look what the farm community did, look what the municipal authorities did out there as well. You're talking about pulling out a lot of phosphorus, and we can talk about the different fractions and stuff. That's a pollution diet in action out there. A lot of tough work out there, a lot of people working their farms and local systems. It's working. Nitrogen, a little bit tougher out there. Here our farming community actually has done even a much larger share out there. Our wastewater's done that. We've got to get more out of stormwater, but we've taken out 82 million pounds. We got about another 50 to go as well. We're learning how difficult it is to change behavior of my neighbors, what they put on their backyards, how we work in our city streets, etc. But folks, it's working. This one is an interesting chart. This is the line at the top. That's river flow. The bars themselves are our best monitored and modeled measure of pollutants. Look around 2005. What happens? There's a split between every time it rains, the pollution doesn't go up the same amount. That happened for the first 15 years or so. What our U.S. geological scientists and our land-grant universities have seen, there's a split. It rains, not as much pollutants come into the Chesapeake Bay. We have a 100-year storm, oh yeah, it's going to blow it out. But we're separating the two. We're finally breaking that rain habit. That means our farmers are keeping good nutrients on their soils, in their farm fields. Our cities are figuring out how to have a nice bar out on a sidewalk, and below it is a 100,000-gallon infiltration system that's delivering clean water to our urban systems out there. Mother Nature is showing we're splitting the two. We still have some ways to go, but it's happening. I would have never thought in my career I would have seen these charts. On your left-hand side, if you got a purple arrow pointing down, that means the loads in that river going down the system are going down. Most of those stations are heading the right direction. In the Chesapeake Bay itself, you know how big of a body of water that is? You have to take a lot of nitrogen in order to see a statistically significant difference. In 30 years, almost every single station in Maryland, Virginia, DC, and Delaware is heading down. This is not me. This is our statisticians, double counted by or double approved by our scientific community of how we look at that monitoring data out there. Folks, that's a system coming back. It's not there yet, but you go into the deepest part. We're going into a coal mine. You're going down, 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 and you're bringing your canary with you. Our canary is our dead zone. In other words, it was the last thing we thought we'd start to see a response. Our scientists have indicated the size of that dead zone is actually shrinking, and it's when it comes into play and doesn't as well. Our watermen are seeing that. Others have. We've seen last year we had a lot of rainfall that popped up, but statistically over the last 3 decades, against increasing flow because of changes in climate out there, the system is coming back in there. Our scientists say the actual ecosystem and the biochemistry is changing out there. Mother Nature is starting to figure out, hey, you're relieving me of some of those nutrient pollutions, I'm going to come back. They didn't think it was possible. And they're actually got about 10, 15 years more knowledge on I do, that they never thought they'd see it in their career, much less their lifetime. We got to keep pushing it because that next million people are coming in the watershed. And then finally, underwater grasses. You see that picture over on the side there? That's what we call the Susquehanna Flats. It's almost 13,000 acres inside. You can see it from space. Imagine seeing, not a harmful algal bloom, imagine seeing a good lush grass bed in there. You go up there, the water is crystal clear. You feel like you're in the Virgin Islands out there. This is the Chesapeake Bay. We have a state senator that he measures how deep he can see his white sneakers. And I figured that once he's up to about here, we've got a clean Chesapeake Bay. It's down a little bit above his waist right now, and unfortunately we lost him last year. But Bernie's sneaker index never went up to the Susquehanna Flats because it was too good. He went into his home territory. Water's getting clearer, but we've got increasing temperatures in that system that are coming through as well. Here's my contact information. I even put you in my home phone number, so if you call and you hear a female-sounding voice, tell them who you are. That's my wife, Susan. Introduce yourself and tell her to get the guy that's retired out there as well. Feel free to email me, call me, and would be pleased during our Q's and A's or during lunch to talk further. I'm here to tell you it's working. A partnership's working. 18 million people in a system can actually get there. We're not there yet, but there are promising signs. My neighbors see, my farmers see it, my municipal authorities, my elected officials. Folks know that we're heading in the right direction. You can do it here as well. Thank you.
Thank you very much, Rich. As I mentioned before, we're going to have questions at the end of this panel, and we'll invite all the speakers to come up. So if you do have questions for Rich, please hold on to those and remember them, and there'll be an opportunity and a little bit more time to ask those questions of Rich. So the next speaker today needs no introduction, as it is myself. I'm back. So this morning, I'm going to describe collaborations that enable us to direct resources to maximize the impact on water quality and get a bigger bang for the buck. Most of the time this morning, I'm going to describe a project that I'm leading where we have formed a public-private partnership focused on elevated phosphorus fields in the Maumee watershed. Then I'm going to close by extrapolating a bit from this project to advocate for a pilot watershed project and continued collaboration so that we can move the needle on water quality. So since this is the first talk focused on Lake Erie, I wanted to go over some kind of basic facts that provided the foundation for the public-private partnership public-private partnership project I'm going to talk about. I always have trouble with all those P's. So first of all, the bloom size in Lake Erie, it's driven by phosphorus. The Maumee River, which discharges in Toledo, is the dominant source of the phosphorus to Lake Erie. Oops. The majority of the phosphorus coming out of the Maumee comes from Nonpoint or agricultural resources. So if we want to have a bigger bang for the buck, we want to focus on agricultural areas. And we're also aware of the need to reduce this phosphorus, the binational agreement, which asks for a 40% reduction by 2025. Knowing this, I think most of us are aware that there's been a lot of work that's happened in the Maumee watershed. There's been adoption of management practices, a lot of ongoing programs from federal and state agencies. But despite that, we haven't really seen a strong signature at the end of the Maumee like Rich showed us in Chesapeake Bay. Why is this? Well, one of the areas for concern focuses on what's widely known as legacy phosphorus fields and what in this project we referred to as elevated phosphorus fields. The concerns for these areas include that we know they exist, but where are they? How can we find them? How high are the phosphorus concentrations on these fields? And how much runoff comes from these fields? And lastly, how can we better manage these fields to reduce that runoff? So those are the questions that we seek to answer with this project. When we first started considering this project and writing the grant that garnered the funding to support it, we needed to define what we meant by elevated phosphorus fields. And so we came up with a numerical definition that was 2.5 times greater than the agronomic recommendation of 40 milligrams kilogram phosphorus. And this was 100 milligrams per kilogram of phosphorus in the soil. Another thing we found when we first started looking in this project was we reviewed some of the results from soil test labs from the Maumee watershed. And what we found was that about 5% of the measurements that these labs were analyzing were above this threshold that we established. So again, we know that these sites are out there. And you can see from this map here that some counties have greater or lower percentages of these sites within them. And I want to make the case that it's hard to draw trends at a county level. That's just where we got the data from. What we've really found is that you really need to go field by field. So you can have drastically different soil test phosphorus values from one field to the next. Let me get this figured out here. The other thing we learned early on, and we use this as a rationale to support the funding for this, is that greater soil test phosphorus levels lead to greater phosphorus runoff. And we found evidence for this in the Western Lake Erie Basin, and that's shown here in data from Kevin King. That's on the left-hand side of the screen. You can see that as the soil test phosphorus increases on the bottom of that graph, we have greater phosphorus loads coming off of those fields. On the right-hand side, you can see that this trend also holds true across the United States and also in the United Kingdom. So this is a general truth, that the more soil test phosphorus, the more soil we have the more phosphorus we have in the soils, the greater phosphorus runoff we're going to have coming off of that field. So to review the project rationale, we know that these elevated phosphorus fields exist, but where are they and how can we find them? So the way we address these questions with this project is by forming a public-private partnership that included researchers, farmers, and crop consultants. The next questions we were interested in is, do these fields disproportionately contribute to phosphorus loads as we think they will, or how much phosphorus comes off these fields? And then secondly, how effective can best management practices be in addressing or reducing these loads? And we're addressing those questions in objective one of this project by installing and monitoring best management practices on these elevated phosphorus fields. The last question that we're trying to answer is, how effective can this approach be in reducing harmful algal blooms in Lake Erie? Or how effective can this approach be in reducing the amount of phosphorus that's coming out of the mouth of the Maumee? And the way we're going to do that is by scaling up our study with watershed models. Objective 3 involves outreach, so we want to take the results from this project, get them out to the community to encourage greater adoption of best management programs, best management plans and programs on elevated phosphorus fields. So what I'd like to do next is delve into some of these methods a little bit more and look at some of the initial results that we're getting from this project. Before I do that, I'll just mention that overall, we now have a 5-year study that's funded with $5 million from the United States Department of Agriculture, and it began last year and it's going to end in 2023. So because this session's focused on collaborations and partnerships, I wanted to highlight how we were able to form the group of organizations and individuals we're working with to make this project happen. So after we initially formed the research group, which includes folks from the Nature Conservancy, USDA ARS, and Ohio State University, one of the first things we did is we reached out to agricultural organizations to get their support and tell them about the project. We knew that in order to get farmers to be participants in this project, we had to have the support of the agricultural organizations. So very thankful to letters of support we received from these organizations. Some of the most important support that we got for this project was from the Ohio Agribusiness Association and from the 4R Nutrient Stewardship Certification. Chris Henney and Andrew Altman from these groups reached out to crop consultants to describe the project to them and see if they wanted to participate in it, if they were interested in it. They identified 4 crop consultants that we then approached, told about the project, and we found ways to collaborate with them to identify 14 farmers and fields. So it was really important how that came together. The crop consultants are really the kingpin of this project, so I'd like to talk a little bit more about how we worked with them to identify field sites. So initially, each one of the 4 crop consultants shared de-identified data on fields with measurements that exceeded our threshold of 100 milligrams per kilogram soil test phosphorus. From this data, we selected 25 fields from each one of the crop consultants to initially investigate. And we looked for fields that had multiple zones above 100 milligram per kilogram, so fields that had a stronger signature of elevated phosphorus, if you will. The next step was to work with Robyn Wilson at Ohio State University to develop a survey, and the crop consultants then administered the survey to each one of their clients to gauge their interest. The very first, and I would say the most important question of that survey was, how interested are you in being part of this study? Okay? So for those farmers that said, yes, I'm interested in being part of the study, then we were able to look into their fields more to gain more information and see if their field had the physical characteristics that would support the study. Then we could meet with the farmers, describe the project to them. They could agree to participate in the project, or they could not agree to participate in the project. It was their choice. Lastly, I want to mention that we are compensating crop consultants and farmers for being involved in this study. They are contributing a lot of effort and time to this, so we feel it's fair to compensate them for their efforts. The map on the right-hand side, this is simply identification of zip codes that had potential field sites, just to give you an idea of where some of the initial fields were coming from. A little bit on the initial results. So when we talk about legacy phosphorus fields, it's really not fields, it's zones. Okay, so when you look at this graph here and the distribution of zones within fields, you can see that most of our fields, less than 25% of the zones actually have elevated phosphorus areas. So when you look at a whole field, that whole field is not elevated, it's really a quarter of that field, more or less. One interesting thing, when we started looking at some of the data, we saw a number of fields that had 100% of the zones above 100 milligram per kilogram. You can see the tall bar at the right-hand side of your screen. And by working with the crop consultants and by looking at some of the names of these fields, some of the names would be Jane's Garden or Jim's Garden. It was pretty clear to us that these were actually home gardens, which were small plots that had probably been maybe received more fertilizer over time to grow better tomatoes or better green beans. So we were able to exclude those from the studies. We really wanted to focus on larger fields that typify what we're after here. The next slide gives you an idea what some of these fields look like. On the left-hand side is a typical field where we have one zone that's above 100 milligram per kilogram, and you can see this is the yellow or gold zone in the middle of that field. And also typical is that zone is surrounding the barn. Okay, in the past there's probably livestock in that barn and the manure was applied close to the barn. On the right-hand side of this screen is a unique field that we did not see too many of in this study, and this is unique because all the zones are above 100 milligram per kilogram. Okay, very dark colors here. And these were fields that we prioritized. We would like to get these in the study if they had the right hydrology and if the farmer was interested in participating with us. Most of the fields were like the one you see on the left-hand side. One of the key things for us is finding the right hydrology in these sites. It's critical that we find hydrologically isolated sites that we can monitor. So we want to get the runoff from the elevated phosphorus field that we're studying. We don't want to get the runoff from the field to the north or south or east or west. And that makes it really challenging to find field sites. You can ask Kevin King about this as well. It's really hard to find fields where you only get the runoff from that field and not from an adjacent area. So we used a program called PC Swim to delineate these sites, and this next click here gives you an idea of what one of those sites looks like. So you can see that within that black line there, all of those soil test phosphorus values are above 100. The surface flow all goes to the right-hand side of the screen, and the tile goes to the top of that screen. So in this project, we're going to be monitoring both the tile at the top and the surface on the right-hand side of your screen. So this is a field that worked for us. A lot of the fields didn't, and we actually lost about half of the potential fields just because they weren't able to be monitored. You might be wondering, what types of BMPs are we planning to use at these sites to reduce phosphorus loads? I'll start by saying that when your goal is to reduce, especially dissolved reactive phosphorus at the edge of field, your number of BMPs that are going to be effective shrinks pretty quickly. So the ones we've identified for this project are phosphorus filters, constructed wetlands, and drainage water management systems. How do we pick which one of those for the different sites? This is based on physical characteristics and based on farmer preferences and seeing what will fit into that farmer's schedule. In the end, we want to try to find the best solution for each field, and we have been using the Best Management Practice Handbook that's been developed by Ohio State Extension to move forward with this. I want to spend a little bit of time talking about phosphorus filters because that is the majority of the best management practices we're going to be using on these sites. These devices are some of the best options when you have high concentrations of phosphorus coming off a site like an elevated phosphorus field. The way these devices work is you have a tank, it looks like a septic tank. You can fill that tank full of media. You connect that tank to your drainage tile lines, water runs into that tank, the water percolates through that media, the media absorbs the phosphorus, and then the water comes out of the bottom of that tank and goes into a stream or agricultural ditch. Some of the most exciting things about this technology, if you want to get excited about phosphorus filters, are advancements that's happening with the filter media. For about the last decade, it's been very common to use steel slag inside these systems, and steel slag is very cheap, but it doesn't absorb much phosphorus, so you're going to have to recharge it, and it's not going to absorb much phosphorus over time. So we're moving to using iron shavings mixed with sand, and some engineered materials such as Alcan. These do cost a little bit more, but they're going to remove a lot more phosphorus over time than steel slag. So we're making some big advancements into what type of material we can use within these filters. I want to give a special thanks to Chad Penn, who's from the USDA ARS in West Lafayette, Indiana. He's collaborating with us on this project, and he is the national expert on phosphorus filters. So he's the one that's testing these different media to see how effective they're going to be within this project. And he's also working with us on the designs of these systems, and we're thankful to that. So important questions that we'll ask and answer about phosphorus filters is how long do they last? Does the economic investment make sense when you look at the amount of phosphorus that's removed? And do they clog is another important question that we want to answer. To continue to talk about collaborations with USDA ARS, we're also thankful to be working with Kevin King's group in Columbus. For the edge of field instrumentation at the edge of our sites, we're replicating the methods that Kevin and his group have perfected over time. So instead of reinventing the wheel, we're essentially copying Kevin's setup, and we're really thankful to their ongoing support for that. We're also thankful that Kevin has agreed to share 2 of his sites which have elevated phosphorus fields. So 14 of our sites are actually pre-existing sites that Kevin's been working on for a little while. As I mentioned, we want to expand beyond the field analysis to expand the scope and the impact of this study, and we're going to do that with socioeconomic analyses and watershed modeling. For the socioeconomic analysis, we're going to do surveys of participating and non-participating farmers and also focus groups with the crop consultants. Two of the points of information we want to gather from this are to identify barriers to adoption and how to overcome those barriers. So what are things that hold farmers back from adopting best management plans on elevated phosphorus fields? Is it an economic issue? Do we need more cost shares? Is it that farmers don't want to be labeled as having a legacy phosphorus field and we need to look at ways to protect their identity? Do we need to better communicate the efficacy of different best management practices such as phosphorus filters or constructed wetlands to address these issues? With watershed modeling, the main question we want to try to answer is, does managing elevated phosphorus fields achieve better results at the watershed level? Okay, so if we can expand from this project and have more best management practices on elevated phosphorus fields across the Maumee watershed, can we see an impact at the bottom of that watershed? And we think the answer is going to be yes. Instead of randomly placing these management practices, if we can focus them on elevated phosphorus fields, well, we'll get a bigger bang for the buck. We should see an increased impact over time. So in the next few years, I look forward to talking more about results from this project. We're just starting it right now. So while we're focused on the watershed, I'd like to just take my last minute here and advocate for a pilot watershed approach. So for this approach, what we would do is invest heavily in a Huck 12 watershed, probably 10 or 15 square miles. This investment would allow us to increase the adoption of best management practices within this watershed to maybe 80% of adoption levels. And we would couple this with an intensive monitoring effort as well. Putting all this together, it would be the acid test to determine how best management practice adoption can move the needle at a watershed level, and we can see improvement at the outlet of the watershed, just like Rich has seen in the Chesapeake Bay. Benefits from this approach include demonstrating how the right practices at the sufficient scale can improve water quality at the watershed level. We can optimize efforts in the future as we demonstrate successful impact on water quality, and this will also allow us to develop economic estimates of resources needed as we extrapolate or move on from a pilot watershed. I'm going to close by noting that this is yet another project where collaboration and full support from all stakeholders will be essential for success. Thank you very much. Okay, I'm going to put on my MC hat here and invite our next speaker. Okay. Our next speaker is Dr. Jessica D'Ambrosia. She's coming to us from the Nature Conservancy. Jessica joined the Nature Conservancy in 2016 and now serves as the Ohio Agriculture Director in that group. I've known Jessica for quite a while. I think going back to the early 2000s, we shared an office suite at OSU. Since that time, Jessica's completed her MS and PhD at the Ag Engineering Department at Ohio State University. She's also served as a program manager for OSU Extension for the management of stormwater and surface runoff, both in urban and agricultural watersheds. She's also spent some time as a faculty member at Antioch College, focused on cooperative extension. So the knowledge and perspective that Jessica has from these roles is not only in interdisciplinary science, but she also very effectively works with individuals and organizations collaboratively. So with the theme of collaboration, I'm very delighted to have Jessica give the next presentation. Thank you, Jessica.
Good morning. Thank you, Jay. That's loud. Jay always gives me a much better bio than I submit to him to read, so I appreciate that. Thank you to the Planning Committee for the invitation to speak today. So I am going to talk a lot about some projects that we're working on that I think are really cool that you should know about. It's not by any means the only projects that we work on and the only collaborations that we have, but these are the ones that we're focused on right now and heading into over the next couple of years. So, but first, a little bit about who we are, if you're not sure. The Nature Conservancy is the largest conservation organization in the world. We're in more than 70 countries worldwide in all 50 states. We were established around the 1960s, and we are a 501c3 nonprofit, but we can accept public and private money, memberships, and donations to do our work. We started out and probably are most well known for buying up and preserving unique habitats around the world, and since then, our mission has really evolved to encompass protecting the land and waters upon which all life depends. And so as an organization, we have a global strategy and meeting a global challenge of providing food and water sustainably. And so that's where my work comes in leading our ag strategy in the Western Basin and the state of Ohio. We have been in the Great Lakes region more locally for about 20 years or so. We got our start in Northeast Ohio, Northeast Indiana, and when we needed to ask help from local farmers to protect an endangered mussel species. And it was then that we realized that farmers were a key partner and a key collaborator, and personally, they gave really good hugs. So they were really important to work with, and so we've since then expanded from a small watershed in Northeast Indiana to the Western Basin to now working with the ag community closely on water quality issues across the state. So our approach is a collaborative approach, and that's how we approach all of our partnerships and work, especially when it comes to water quality issues and agriculture. And this serves as my outline for my talk today and how I'm going to present the case studies. But we like to put practices on the ground, work with folks to do that, to interrupt the nutrient sources and the delivery pathways for how nutrients get to waterways. We like to be the boots on the ground and amplify and support our partners who are the boots on the ground to help build capacity and knowledge in the watershed across a range of stakeholders. And then we like to amplify messages and work with folks like Extension in the area to deliver and transfer the science-based information that we need to make valuable decisions. So the first case study that I'm going to bring up today is located in Fulton County. It's the Solder Village Historical Museum. A few years ago, we're going to hear about this a little bit later, but we've had a lot of rainfall in the area lately, and a few years ago, some of those large rains impacted Solder Village, and they flooded their museum and lost some important artifacts. And that financial loss and that personal loss was enough for them to say, we need to do something about managing water on our landscape and on our property. So they, working through their master plan, Fulton County Soil and Water District brought us to the table. Working through their master plan, we decided we could come up with some solutions about where water was coming onto their property and how to manage it. But once we started talking, we realized they had an education mission, a recreation mission, and they had an important role to play in reducing nutrients in the Lake Erie watershed. So they were all in. So we decided to write a Great Lakes Commission grant, and this is part of the way that TNC helps build capacity as we help partners write public grants to do projects that they want to do. So Solder Village, Fulton Soil and Water District, ourselves, Department of Natural Resources, Division of Wildlife did the design for us. And what we came up with was Solder Village opted to give 30 acres of their property over to natural wetland and restore wetland habitat. And what that did for them was that was able to manage a large volume of water that was coming onto the property during large rain events, so they would reduce the flooding impact into their main area of the historic village. 15 acre-feet of storage volume, 11 acres of actual ponded wetland type habitat, 5 acres of native grasses and wildflowers, another 3 acres of oak savanna habitat, which is a unique habitat to that area, and 9 additional acres of natural cover. And that also afforded them to create a 1 mile additional walking trail for the 300,000 visitors that they get every year. So this is a picture, an aerial photo of that project in development right now. I encourage you to go visit it. It's in process. A second project is one that's getting ready to wrap up now. It's been a 5-year project. It's a Great Lakes Restoration Initiative, Ohio Environmental Protection Agency Sediment Reduction Grant. And trying to reduce sediment and nutrients in the Maumee River watershed. So our solution was to get a team of partners together. You'll notice in these slides I try to highlight the partners in blue. So if I'm not mentioning you directly, you're in blue, and of course whatever happens when you list partners in a public presentation, you usually forget one. So if you're in the room and I've forgotten you, raise your hand. I apologize. But so we decided to implement a suite of BMP practices, best management agriculture practices, that science has told us will reduce sediment and nutrients and improve water quality. Part of our partnership installs the practices, works with the landowners. Part of our partnership monitors the efficacy of those practices and reports that out. And part of our partnerships does the outreach and education to teach others about those practices. And some of the products, we've seen this on Jay's presentation, we were able to collaborate and develop a BMP handbook that's an online and printed resource that was actually distributed to all counties in the state. We've done quite a bit of outreach, and we estimate that we were able to engage 750 stakeholders directly and more than 20,000 indirectly through our outreach efforts, signage, field days, case study reports that we put out. And of course the BMPs that were installed. So we estimate, and again this is an estimated load, we are monitoring a few of those practices, not every single practice, but an estimated load is pretty impressive, and we're able to get quite a few practices on the ground and put informational materials out there about what those practices are. Another set of projects that are ongoing right now are funded by Ohio EPA 319 program. And again, we're trying to solve the problem of harmful algal blooms and reduce nutrients to Lake Erie. So the solution or suite of solutions is more practices on the ground to manage water and nutrients. And so this is in progress right now, and I'm pretty excited about it, and I'm pretty nervous about it because it's got to all be wrapped up by December, so please don't rain anymore up here. Aaron, let me know if it's going to rain up here. So we are planning, and under construction right now is 3,100 linear feet of a cascading waterway, which is a grassed waterway retrofitted with retention cells to help capture and store water a little more efficiently and treat it. A 14-acre wetland that will be going in the beginning of October in Hancock County with the commissioners, and a phosphorus demonstration farm that Seneca County wants to establish for the public and for education and outreach with a suite of practices. And I know for sure that Blanchard River Watershed Partners is not on this list, and they are part of this project in Hancock County, and they're helping us plant trees and do outreach. Okay, a few things that are new in 2019 for TNC, and a different set of partners that we don't always talk about are working with our agriculture supply chain partners. So this is a key strategy for the Nature Conservancy across the country and across the world. It's something that's now touching down in the Western Basin that really hasn't to some degree. We had strong partnerships with John Deere Company in doing outreach, but now we're engaging other companies. And so now we're working with Kellogg's Company, the cereal, and Syngenta, and we are working on partnerships that will support U.S. farmers and what Syngenta and TNC are calling Innovation for Nature collaborations. And that's bringing dollars to the Western Basin to help support U.S. farmers and help support environmental tracking of those practices we put on the ground. And so what we'll do as part of that, starting this year, and that will run into 2021, is we'll develop a series of learning and training programs for farmers and ag retailers together. We'll implement actual practices on the ground, and we'll be tracking those outcomes and trying to report back on what some of those are after implementation. Pretty excited about this one. And then coming in 2020, we will be developing a farmer-led soil health learning program pilot. So we hear that we need more technical assistance out on the landscape. We hear that farmers need to learn from other farmers and learn best that way. So we want to work with a wide range of collaborative partners who are working in the basin, basically everybody, to develop learning and training programs specifically for farmers and hosted and held by farmers. Train those folks to be the next leaders and the community leaders to go out and train other farmers and teach other farmers about what's worked for them. We want to have coordinated and multiple touch points for that effort. And we're assembling a steering committee right now. If you're interested, please contact me or Stephanie Singer in our Defiance office. Again, it's a range of a lot of different partners that we want to try to engage. Okay, another thing that's coming that's soon that we're pretty excited about, there's a whole range of tools and decision support technology out there. We presented maps that look like the one on the left in 2017 when I spoke at this conference. And it really, at that time, was really to help TNC decide where we're going to focus our work and our resources. But we've evolved and we're sharing those maps a little bit more as just saying, okay, where are potential opportunities out there to do work? How can we prioritize places to do work? And now we have other tools coming online. We have a really strong SWOT modeling team in the Western Basin. I think we'll hear about that a little bit later. And we have an agricultural conservation planning framework toolbox coming online. So how do we start combining a bunch of different tools we have at our fingertips to make decisions, better decisions about where the right practices are in the right place, working with our university researchers, our partners on the ground, and doing a lot more decision support with the technology we have. So we're just trying to feel out that partnership and that collaboration and see what might be possible. So I thank you for your time. I thank you for the opportunity, and I'll take questions afterwards.
Thanks, Jessica. I'm very encouraged to see the project with Souter Village, that you're protecting that establishment because they have very good pies there. I have tried the pies there, yes. Our next speaker today is Rick Wilson. Rick is an environmental specialist at the Ohio Environmental Protection Agency in the Division of Water Quality. He's also been involved in the Nonpoint Source 319 program over the years. Rick's been with OEPA for more than 25 years. Before that, he graduated from the Civil Engineering Department at Ohio State. Very recently, Rick has been working with Ag BMPs, and he's also been focused on 9-element plans. And today, Rick's going to focus on the 9-element plans and the collaboration that's necessary to make those work. Thank you, Rick.
Thank you, Jay. So, and this is the, all right, nice. Okay, so 9-element plans came around a long time ago through a US EPA programmatic non-point source updates to the program, to where we want to take a strong emphasis on watershed-based plans. I'm going to talk about the 9 elements very briefly. Moreover, the 9 elements are a part of project setting and prioritization of projects in a watershed-based plan. So I'm going to mention the 9 elements quickly and then talk about implementation. But long story short is, in 2013, the US EPA came out and said we needed to take a stronger emphasis on watershed-based approaches. What's impaired in the watershed, what needs to be done and what can be done, and are we there yet? And if not, how much farther do we have to go? So here's the 9 elements quickly. Causes a source of impairment, determine load reductions needed, what are the management measures designed to address those load reductions, or in Ohio's case, we have biological impairment as well that determines our water quality status. What are the technical and financial assistance that are needed to implement those priority practices? And then beyond that, you have things that are more project specific, information and education, what's your schedule for implementation, milestones and measures of progress, and then a monitoring component that's always wrapped into a project. So getting past the 9 elements, and let's get directly into what is in an implementation strategy in Ohio. These have been Ohio's 9-element plans started gaining traction about 3 years ago. And since then, we've given a lot of presentations on what a 9-element plan is in Ohio and why we've been implementing those. And initially, it was to dedicate federal funds, but we learned in those 3 years that the 9-element plans could be a lot more than that. Keeping it simple, and I tried to keep it simple all these years, but a plan summarizes what's in your watershed, a 12-digit watershed. It lists out what we know are the causes and sources of impairment. It describes the critical areas that you want to focus on to address those causes and sources of impairment. And then you get into strategic goals to implement projects. The outreach and collaboration part of that is the biggest part and the hardest part, and the thing that has to be sustained and keep rolling. You want to establish strategic objectives, and you'll hear me talk about objectives a lot, and develop projects. And in our world, in EPA's world, in our office, our whole goal is find projects, develop projects, and fund the projects, whether it be through federal funds, state funds, local funds, or a combination of all those. One of the main things that we've learned over the 3 years is the 9-element planning process is critical. It's critical to have your stakeholders in the room, or in the room a number of different times during the process. It needs to be locally facilitated. This isn't the state facilitating anything. We're trying to get the locals to reach their stakeholders, whether they be industry, agricultural co-ops, local land conservancies like TNC, otherwise landowners, township leaders, health department. We have a lot of different reasons our watersheds are impaired, and all these folks play a part at the table. But generally, we have one local leader that's kind of driving the car on developing the 9-element plan. A lot of times they'll use a consultant to help them with some of the mapping or some of the structuring of the document. But when it comes to putting the rubber to the road, it's goal setting, objective setting, and projects. I'm going to get into more projects. So the other part, when you're first lining up a watershed plan, is to summarize the available data that you have. A lot of it's available through technical support documents at Ohio EPA, TMDLs, other data that's available through local monitoring through the years, or universities, or even national studies. But what we want to do in the watershed assessment is to document what are the biological trends, biology sets, lets us know whether or not a 12-digit huck is in attainment of its aquatic life use. We have a loading assessment. A lot of times locally you have loads that cause impairment, or also far field. So we look at the causes and sources of those impairments, both near field and far field, and I'm going to get into what near field and far field mean, but it's been pretty important in the way we've progressed through this 9-element planning process. Initially, we stuck with near field impairment being the localized impairment in your watershed and your watershed's streams. But beyond aquatic life use impairment, we have recreational use impairment, and public drinking water use impairment. So near field is where we do biological assessments in the local community, and where those watersheds do not meet those aquatic thresholds, we can list those watersheds as impaired. In the non-point source world, that's usually due to land use or hydrology, channelization, absence of riparian habitat, and sedimentation. Also locally, you might have a pollutant coming from an industry or municipality that's causing the impairment, and in those cases, we deal with those point source causes of impairment through our permitting program. Far field impairment is impairment that's downstream from where you live. Usually involves a prominent water resource. We're here most likely because of Lake Erie, but we also have issues with hypoxia in the Gulf of Mexico and other issues in our inland lakes and reservoirs in Ohio. So what we do locally in our watersheds and the loading from those watersheds can cause impairment downstream. And in this case, that exists in Ohio and a lot of other places, Chesapeake Bay, for instance. So in our plans, we want to establish goals. That's one of those 9 elements. we have goals in our projects as well, but the idea is to reach those aquatic thresholds. For instance, fish scores, macroinvertebrate scores, habitat scores. We want to elevate those already measured metrics up to where they meet water quality standards. Or otherwise, we want to attain public drinking water supply standards or recreational use designation standards. And in a lot of those cases, it's load reduction or bacterial reduction that's needed to achieve those goals. And so load reduction, obviously in this case, far field, is a key player. So I'm going to talk a little bit more toward the load reduction side moving forward here. 9-element plans, this is where the public meetings really come into place. You really need the stakeholders in the room. It was mentioned earlier that they have to want to participate. They have to understand the problem and be ready and willing to try new things and identify what they're already doing, quite frankly. So what are the technical solutions? What are the activities, conservation practices, and administrative measures that can be accomplished in your watershed by the stakeholders? And how many of each of those conservation practices or activity can be actually be accomplished in the near term? We know we can't get everything all at once in all the watersheds. It's a noble effort to try to do that in one, so we can demonstrate after a long time of implementing practices, we know we'll get there. So these 9-element plans are living documents, so you're installing what could be happening now, but you can always come back with new practices or new people or more people who want to participate and adjust those objectives accordingly. As far as load reductions go, the state is working to provide guidance to planners, especially soil and water conservation districts, on what some suggested BMPs might be or suggested goals for BMPs, such as nutrient management, erosion management, water retention. Some examples of objectives for agriculture, and then I'll have some for urban and suburban as well, but develop and implement nutrient management and conservation planning for crop producers on an additional 8,000 acres of row crop. Install or restore at least 5,000 linear feet of grassed waterways. Install drainage water controls and implement drainage water management on at least 500 acres of subsurface drainage. And install practices that impound or retain surface drainage from at least 500 acres. So you'll notice I put numbers on all of those because part of the 9-element planning process is you are putting out a strategy and you're listing a means or a diet or a recipe to try and improve your watershed or improve downstream issues. But you want to be able to track incremental progress on those same goals and objectives. So as you implement practices and measure results, whether or not be edge of field or far field downstream monitoring locations, you're able to try to tie in the progress that's been made with implementation with actual results in the field. Some examples of urban and suburban objectives. Again, these 9-element plans can address issues from all land uses. They could address home sewage treatment system, septic tank clusters. You're addressing different issues with different critical areas within the plan. So we have some 9-element plans that have critical areas for the ag land use, some critical areas specific to the municipality. All of them have some role in the loads that we have. So some examples from urban, restoring severely eroded stream banks, daylighting culverted streams, restoring channelized streams using natural channel design, restoring access to floodplains, managing stormwater with LID practices to address impermeable pavement in the acres, conservation easements along riparian corridors, and planning of wooded riparian corridors. All examples of things that could be listed in plans. After the objectives are set, you hope that you set your objectives in a way that you're providing a list that you can go with outreach now to your landowners in your watershed. In today's day and age, these were initially created to be eligible for federal funding, But having a prioritized list of practices that are ready to go, where there's willing and able partners at the table once funding becomes available, is a big deal. So part of our non-element strategy is to have a project overview. You're building a bookshelf of potential projects that once funding becomes available, either through an RFP or state funding cycles, that you are setting yourself up. So this is an example from one I took out, talks about potential funding sources, including Northeast Ohio Regional Sewer District, Ohio EPA's 319 funds, Great Lakes Restoration Initiative funds, and others to be determined. They're medium and longer term projects. But I took this one extra step, especially we're now involved with a lot of plans that are under development right now in the Maumee Watershed, focusing on addressing far-field load reduction issues. And so the suggestion there is these can be plans not just for funds coming out of the state environmental agency, but you can help prioritize the types of practices that your county or your watershed wants to use USDA funds for. We still have Senate Bill 299 funds. Still 319 and GLRI funds are available on an annual basis. The Great Lakes Commission has some grant funds available. Trading organizations are still a viable resource of funding. But the big one, obviously, everyone is waiting on to hear strategies on and implementation type notions is the H2 Ohio funds that will be available this year, next year, and beyond perhaps. So this is a way to strategize. Once those funds become available, here are the projects we have queued up and ready to go and could almost guarantee implementation directly right away. So again, the projects, I was going to bring a specific project sheet with me. The project sheet is where those 9 elements all come to fruition. You're talking about, you describe the project, why it's happening, what are the expected load reductions, those are your milestones. What type of outreach and education is going to happen because of it? What type of monitoring is going to be done? That's where the 9 elements come together. It's in a project summary. But basically, it's a short list that says, this project's ready to go. We know who can fund it. We know how much in general it's going to cost. So the project basically becomes the book on the bookshelf for a short-term, shovel-ready project. Every project that's in a 9-element plan that's approved by the state, and the state does approve the 9-element plans, both the Division of Soil and Water Conservation at ODA and our office in the 319 program do co-reviews and on those plans. But once it's approved, for federal purposes, it's required for funding, but for state purposes, it's a really nice bookshelf for the state to look at and say, okay, where can we do projects with available funds as they become available? It can be filled and emptied over time. These are living documents. You should keep up with your stakeholders and constantly improve those plans so you're making stepwise progress toward their load reduction targets. I already mentioned this. You might say, well, I've never seen a 9-element plan. Every one of the 9-element plans we've ever approved is now available on an interactive website at the state, in the state's interactive websites. You click on, you can go to our Division of Surface Water and click on interactive maps, or go to our Nonpoint source pollution, or call me and I'll get you there. Here's what that looks like when you click on it. You'll see we have the goldish colored watershed. Those are all where 9-element plans have been approved. We have acid mine drainage management plans that are approved as equivalent to 9-element for acid mine drainage projects. And we also have some equivalent plans that came from Indiana without projects. So on those, if projects are needed, they'll need to be added to those plans. Here's where we have plans in progress. You'll see the watersheds south of the Toledo area. All of those, except for the gray ones, are watersheds where we have 9-element far-field plans under development right now. Those should all be done by the end of this year. Summarizing, alignment plans are an effective integrative approach to address the diverse realities and the needs of each watershed. They're a vehicle to establish strategic priorities for project implementation. They're a tool to aid for funding prioritization with the state and funding eligibility for the feds. And it's a living, updatable bookshelf of projects. So with that, I think I'm done, and we'll go to the questions. Thank you very much.
Okay, thank you, Rick. I'm going to invite Jessica and Rich to join us on the stage, and now we'll take questions from the audience for the next few minutes before lunch. And I'll remind you that if you do have a question, please move towards the microphones at the center of the room so that everyone here can hear your question, including those of us up front here.
Okay, Rich, what was the most effective tool that you found to bring the people together and unite? I've reviewed a lot of documents from the 50s and 60s that I've been able to access, and there was a lot of things that happened that that were good things, but nothing ever came of them. What was the uniting tool that brought the people together, the most effective one?
Free federal dollars and chocolate donuts. Seriously, actually in the Chesapeake, what happened is one of our Maryland senators actually grabbed the governors of Maryland and Virginia and the mayor of D.C. and took them out in the Chesapeake when it was crashing on the bottom in the 1970s and said, we got to work together. He actually did bring federal dollars, around $26 million, that started a 5-year study that said, here's what the issues are, and actually set up the partnerships organization. So I hate to say it, but there's nothing like a damn good crisis to bring people together. And unfortunately, that's been one of the drivers that we've had out there. Human nature is good, but a crisis drives state, local, other folks to come to the table, and then they can weather storms, and when it's good and bad, they'll stay together.
Can we move to the second mic, and we'll come back to the front?
Hi, my name is John Cunningham from Niagara Falls. I got a question in regards to the biosolids being distributed in a very, very high quantity along the Maui. It's probably the highest concentration of biosolids being installed into our farmlands. And Quasar, in particular, promotes the fact that it's nutrient. Oh my God, all these nutrients. That's the positive thing that they're talking about. They're not talking about all the pollution that comes from the biosolids, which is raw sewer sludge. It's untreated. And is this being looked into as one of the problems? Also, hydrofracking wastewater. Blue-green algae loves hydrofracking wastewater. They're growing it in Utah, and they're using it as a biodiesel over in Europe. And Ohio has over 200 high-pressure injection wells. When you inject it down at thousands of PSI, when it hits the end of the pipe, it comes up into the watershed. Is that being considered?
Thank you for that question. So I'll answer the one about fracking first of all. Most of us here focus more on Great Lakes watersheds. In Ohio, I think that touches a little bit of the Great Lakes watershed. So while that isn't something that those of us here are working on, I know other people within Ohio are focused on the impacts of fracking. I'm not sure of exact relationships between harmful algal blooms, but I know there's a lot of research focused on that. Going back to biosolids, there is some impacts of biosolids in the Lake Erie Basin. I know that some of the fields that we're looking at in the elevated phosphorus study I mentioned earlier are similar to the site you described before, where we've had a historical application of sewage sludge, biosolids, and things like that. So the important way to move forward on that is to soil test that field, find out what the value is. If it's above an agronomic rate, to stop the application. But the problem is there's a legacy impact from that over-application, and then we have to identify those sites, get management to them, like I described before, to try to limit that phosphorus runoff. And we're finding ways to do that and starting to move forward on that. We surely can't find them all right now, but we're starting to find ways to do that and identify some of the practices that will be successful there.
Well, they used to take sewer sludge and dump it in the ocean, and it caused dead zones. And Ronald Reagan said we couldn't have that anymore, so in 1992, the 503 with the EPA said, we're going to find a beneficial use. Let's feed it to the people. Let them eat sludge. Okay.
Well, yeah, that's what you can do. If you can apply it to fields, you can use it as a good source of nutrients, but you just need to make sure it's at the right level.
With all the contaminants in it, the pharmaceuticals, everything. I mean, I could go through 1,000. I've been studying biosolids for 15 years, and I've been studying hydrofracking for 20.
Yeah, we definitely got to be mindful of the other constituents that come with biosolids as well. So I'm going to thank you for your question, and I want to get the other gentleman's question in as well. Thank you.
You improved the Chesapeake Bay, the way you showed the charts. Could you tell us the difference between the retention time of the water in the Chesapeake Bay compared to the Lake Erie? I think Lake Erie turns over about every 2.5 years. And
yeah, in the Chesapeake Bay, we have, in terms of tidally, you're talking probably on the order of 3 to 6 months, depending if you're up at the head of tide. So yeah, we're fortunate, the flushing capacity, but we also have nutrients that have gathered into our bottom sediments, and they have a retention of probably 2 to 3 years. So there were decades in which we were thinking that even if we stop the pollution coming in the system, the response might take decades from there. What our scientists are indicating was within a year or two, the system can come back. But you have to shut that off and keep it shut down. So your question's a good one. You all certainly have more retention up there. It's a longer retention in there. We do have groundwater, which we're talking about in the order of a year or 2 to 50 years when it's going to come in. So on our lands, we've got this seeping effect of nitrates from, in my community and other farming communities, other agricultural and suburban areas. It's going to take years to decades to do, absolutely. That needs to be considered in there, but it shouldn't stop you from doing that work. But it needs to be considered and put so that folks put, when can I see a response out there? Working with Delaware farmers, they're doing all the right things, but their streams are not coming back. I spent a good several days working with them on a set of farm days. I went back and we looked at the groundwater, and the groundwater is actually starting to respond back. I told them another 5 years, be patient, you'll start to see it in your system. So you're right, there's that legacy in there, but you've got to put in the context of, have I been doing the right things on the land? And through our monitoring system, I could tell Delaware farmers, keep at it, you got to do this, but if you stop, it's going to go back in that other direction as well. So that retention is an important piece. You need to put it in there so people's expectations are correct, but you got to be upfront with them about that as well.
Please.
Yeah, I was wondering, I went to the government center and spoke to Toledo, and I see the mayor gets on the TV and says 98% farmer feed off, 2% us. I asked the question, and they said that the EPA allows 25% of our storm sewers to be hooked to our sanitary sewers. That's a high volume to only have 2%. And not only that, once the pipes, which sanitary is 8 foot in the ground, storm sewers are 4 foot in the ground. Once them pipes start filling up, what is the actual percentage? And this is what we have got to deal with in Toledo here. First of all, honesty. You know, we bite our tongues and we're not going to be completely honest with the folks on exactly what it is that's out there in that lake, and that you got to you've got to add chemicals to make it drinkable, what have you. Hold up a clear glass of water to get out of the tap one time. Thank you.
Thank you. I think you're asking questions about the source of phosphorus coming into Lake Erie or coming from the Maumee River watershed. There have been a couple good studies done which kind of apportion or distribute that source. You mentioned stormwater, municipal sources. That is a smaller source that's coming in, but definitely one of the contributing sources. I think as time goes on, we're making improvements to storm sewers, eliminating combined stormwater overflows and things like that, getting better treatment of stormwater. The one thing that's been clear from both of those studies is that the majority of phosphorus that's coming into Lake Erie is from agricultural sources. But there are other sources as well we need to be mindful of. So I hope that answers your question a little bit. Do we have a question in front from a student? You were thinking about it. You want to go to a microphone?
Yeah, I just had a question. How would you say that the average person, like middle class or whoever, how would you say that the average person will be able to help with this whole algae bloom and water quality situation we have?
I'm outside the watershed, I can tell you. So if you own a house, your downspouts, actually put them into the ground so that they don't go overland and they actually infiltrate down into there. When you think about putting fertilizer because you want a nice green lawn, first think about it. Do you actually need fertilizer? 2, in the Chesapeake Bay region, our fertilizer no longer includes phosphorus, but only includes nitrogen. And if you actually want to fertilize your lawn, they recommend doing it in the fall, not in the spring. We have over 3 million turf farmers in the Chesapeake Bay watershed. They're homeowners, so you can start there. If you're in an apartment and stuff like that, what car do you drive? Do you use public transportation? Are you advocating for stormwater programs that make sense for your local streams and rivers? Have you made your voice then? Have you joined a club out there? Have you recycled? There's a whole host of stuff we can do, because you add those up, 18 million people, that's a big effect in the system. So it ain't just the farmers, it ain't just the treatment plants out there, it's every single one of us.
Thank you.
We'll move to the back, thanks.
Yeah, hi. My question is, when you were talking about phosphorus and labeling high levels of phosphorus at 100 parts per million or billion, there is a push, well, for animal feeding operations, they're saying it's good to apply, or you can apply up to 150 parts per million. And there's also a push for other areas to be applied at 150. Is that justifiable when you're labeling 100 parts high?
I'll say that the labeling for 100 parts high is something that we did in this project. We had to draw a line in the sand to define elevated phosphorus and to identify field sites. Is it justifiable to have that limit at 150 parts per million? I don't know what the answers to that. I think we will get answers to that through this project by looking at what type of runoff we get with that threshold. Do we get a different type of runoff from fields above 150 versus below 150? I think that's an important question that's being asked right now about that 150-point threshold, and I think we're gathering more data about that. Thanks. Let me see what time it is here. Let's have one more question, and then I'm sorry, but we're going to have to cut it off. Those of you who are in line, we welcome you to engage with us during lunch, but I want to keep the program on schedule so we have time to look at posters. So one final question, please.
Thank you, and thanks for this morning's session. It's been very informative and very interesting. My question is about climate change, and specifically regarding the BMPs and how they're designed. If you could share more about, what are they designed for? Does it take into consideration the rain events that we are experiencing in this region? I would love to learn more about that. Thank you.
In the Chesapeake, we actually use what we call a series of BMP expert panels. We probably hosted around 60 or 70 so far. So if you look on the partnership's website, there's a list of around 450 practices for forestry, agriculture, stream restoration. Even we were talking at breakfast, ditch ditch management. So each of those practices were actually built on science in the last several years, the last 40 or 50 years. Unfortunately, majority of those practices and what we call a pollution reduction efficiency, how much nitrogen, phosphorus, and sediment they would reduce, is really built on our sense of climate over the last 30 or 40 years. So no, at this particular point, a lot of our practices are not set up. They're set up for 1, 2, 3, 4-year storms. We're talking about 50, 100-year. Ellicott City, a city near us, in 3 years they had 2,000-year storms that actually caused loss of life in that particular area. I can't even imagine what a 1,000-year storm is. So at this particular point, the partnership has recognized that. One of the things we're starting to go back and said, we've got to relook at our horizons, whether it's cover crops, bioinfiltration systems, riparian forest buffers, the whole set need to be rethought about it. It's not just in terms of the amount of rain. We've seen more and more the intensity of the rain is really what gets us, that overpowers even what we're thinking about it. I have to give credit to Washington, D.C. They've actually been starting to base it on a 10 to 100-year storm. That's because they're putting buildings in place, and those buildings have lifespans of 40, 50, 60 years. So they've actually been looking at around the 2040 to 2050 time period to do that. Other parts in the Chesapeake are trying to catch up to that. Your question is an excellent one, and we are at this point, our science is not caught up from a practice perspective to what we're seeing right now in terms of our rainfall, the intensity, as well as droughts, and actually the change in the seasonality of our cropping systems, our natural system out there as well. So we've got some catching up to do. But I would encourage you all to take a look at the 30, 40 years worth of history of looking at practices and trying to give credit, good science-based credit to a whole range of practices out there, and then evolve it over time as we get better understanding, particularly of something like climate.
I completely agree with that answer, and I'll just add locally. So the phosphorus filters, for example, are designed based on the size and amount of material is based on the amount of phosphorus coming to that location and the amount of flow coming to that location. So flow is a key component of that we have to consider. Waterways and those sorts of things are designed based on the amount of flow that they can capture and convey, more importantly, convey. And I think we're going to hear a little bit later more about climate issues, but we do know that we have rainfall patterns that are different over the last 15 years than they have been over the last 40 years. And as Rich was saying, many of our models and many of our designs are based on climate models and rainfall from 30, 40, 50 years total. So I think it is an important question, and I think it's an important consideration we have to keep in mind moving forward as designers and implementers.
Thank you for your questions, and I do apologize for not being able to respond to all the questions this morning. A couple announcements before we move on to lunch. We have just been joined by Teresa Feder, who's an Ohio Senator from District 11, and she's sitting here in the front. And Teresa invites you to come talk to her during the lunch break, which will start now. I have a couple announcements first. We do have an hour and a half for lunch, so I hope that's enough time for you to enjoy your lunch, but I also want to encourage you to visit the posters and encourage those who brought the posters to stand next to those during the lunch and hopefully find time to eat somewhere too. So please do that, and we will reconvene at 1 o'clock. So enjoy your lunch. We'll see you back at 1 o'clock. Thank you.
All right, we're going to get started here. I must admit that my 4-year-old and 6-year-olds listen to me better than some of you guys. That's impressive. Kevin King gave me a thumbs up in the back of the room. No, this is great. I mean, I joke in that it's fantastic that we have this kind of folks around the room. There's truly some great collaborations and partnerships and friendships. So sorry to cut your discussion short. But this is what we like to see. We like to see that for an hour and a half, people aren't just back at their tables waiting for the next thing, but that we're out engaging our peers and our colleagues and our friends. So thank you for that interaction. Now we've got cheering in the front of the room. Well, so my name's Chris Winslow. I'm the director of the Ohio Sea Grant Program, a NOAA-funded program. I'm also director of Ohio State University's Stone Laboratory. And I'm absolutely honored to be able to moderate the next 2 sessions, actually. But first up, we have what we're calling our directors panel. And so we're very appreciative as a planning team to get the phenomenal response that we got from our 4 agencies to come and engage with this audience about issues and some of the tasks ahead of us related to harmful algal blooms and nutrient loading. And so what we've done, and all of you are aware of this because you've been harassed by emails from the Sea Grant Office, is that we asked for you to submit questions that we could ask this esteemed panel at the front of the stage here. And so we're going to do that, but what we've asked them to do also is pull together a PowerPoint. And in true collaborative fashion, there's one PowerPoint that all 4 of the folks on the stage are going to run through. So each one of them are going to, in turn, step up to the podium here and take us through the PowerPoint presentation that they have provided for us today. And at the conclusion of that, they will remain in their seats, and I'm going to basically moderate a session based on the questions that were submitted. We clearly, as you can imagine, got more questions than likely the time will allow. So based on their presentation and my dialogue with folks today across the room, we probably won't get to all of those, so I'll apologize in advance if your question isn't read. But we're really just trying to make this as productive of a session as possible and to keep us on target. And so it's my pleasure again to introduce, so we'll start from the left and move towards your left, right? So on the far left, we have Executive Director Joy Mullenix of the Lake Erie Commission joining us today. Unfortunately, Director Polanda could not make it today of an illness, but we do have the Assistant Chief of Soil and Water, Matt Lane, with us today. Next to Matt, we have the Director of Ohio Department of Natural Resources, Director Mary Mertz. And then on the end closest to me from the Ohio EPA, Director Lori Stevenson. And so I believe Joy is going to start us off today. So again, we're going to follow them through their presentation, and at the conclusion of that, then we'll introduce some questions that we received from folks around the table here. So please, Director Mullenix.
Thank you, Chris, and thank you, everyone, for joining us here today. Is the PowerPoint up?
Yep,
okay.
Joe's frantically working on it.
There's always one small glitch, right? So on behalf of Governor Mike DeWine and Lieutenant Governor John Husted, we appreciate everyone's enthusiasm around H2 Ohio. It has been one of the more interesting public policy exercises for us to recognize the widespread support around investing in water, not just here in Northwest Ohio, but throughout the rest of the state. And if you hear our boss, Governor DeWine, start, he often will reference how this started as a campaign promise. And he had been talking with probably some of you in this room about algal blooms and the challenges. And he made a campaign promise around a water bond concept. And once he got into office, he recognized that there was enough money in the state's surplus so that he could front-load funding and save the state about $500 million in bonding costs. So what started off as a water bond concept that some of you are familiar with turned into available funding today in the form of H2 Ohio. Let's see. So best laid plans and all. On our first slide, I listed everyone who is supposed to be here, and you will notice that Director Polenda is not with us, but we are fortunate to have some great technical expertise here with Matt Lane. But the four directors for agencies, we have been in regular communication on a weekly, sometimes many times during a week, talking about H2 Ohio and water investments, the Algal Bloom Challenge here. So without a doubt, this has been a very coordinated discussion as we're moving ahead on a very complex problem. So water. I like to quote one of our colleagues, Crystal Davis from the Alliance with the Great Lakes, who talks about water being the great unifier, because really no matter where you are in Ohio, in the United States, and around the world, you can't live without it. And for some of us, it's our livelihood. Some of us, it's our weekend recreation. And obviously we're drinking it every day, as evidenced by the bottles and cups sitting on the table in front of you. So for Governor DeWine, it was a pretty easy policy decision, recognizing that Ohio needs to invest more in our water infrastructure. So picking up on the early discussions that many of your organizations had on the water bond concept, we did design the H2 Ohio program to be similar. So it is a statewide initiative. We want to be very clear. This is a room full of Lake Erie advocates, and so roughly half of the H2 Ohio funds will be spent in dealing with algal blooms, and the rest will be spent on water challenges on a statewide basis. This is also designed to have a long lifespan, much like the bond concept. We're looking at 10 years of funding. And we are extremely pleased that the General Assembly heard from the governor and all of you about the need to invest in water. And it was interesting to have such a warm reception from the General Assembly in investing in Lake Erie water challenges and statewide water challenges. So I think we have a member from the General Assembly here, and I just want to say thank you for all of the support that you all lent in advocating for H2 Ohio. So we are pleased that we received $172 million in this biennium budget, and it's being distributed amongst the three agencies represented on this panel. The Lake Erie Commission, if you look at our statute, we are a coordinating entity, and we have a pretty long history of working with these agencies, but we have a staff of 3.25 people, as I like to tell everyone. So in terms of our engagement in H2 Ohio, we will continue our coordination role. However, if you are looking for rolling out best management practices and looking at investing in water infrastructure on a community level, you're going to need to talk to these other agencies here, because the Lake Erie Commission is just not large enough to deal with that. If you are one of those folks who follow the budget, you will be familiar with these numbers. Ohio EPA received a little over $8 million for the next year. Department of Ag received a little over $30 million, and the Department of Natural Resources received about $46 million of that. We are still working on spending plans, and we are still working on the second year of the budget package, but as we move forward, I will turn it over to my colleagues here so that we can dive a little bit deeper into how initial planning has gone in spending our H2 Ohio funds.
Well, good afternoon, everyone. Again, I'm Matt Lane. I extend the apologies. The director planned us. She was ill today and couldn't make it. I know she would have liked to be here at this event. But I'm the Assistant Chief of the Division of Soil and Water Conservation, and one of my main roles is to be involved in our water quality efforts at the Ohio Department of Agriculture. And with H2 Ohio, the Department of Agriculture has $30.3 million in this fiscal year to support best management practices statewide to address water quality. It's interesting at the Department of Agriculture, we also have additional funding for harmful algal blooms or to address water quality issues in the Western Lake Erie Basin. In addition to H2 Ohio, last year, Senate Bill 299 passed, and that gave additional funding to soil and water conservation districts. That was $20 million to fund practices through soil and water conservation districts. So at the Department of Agriculture, we have H2 Ohio for this fiscal year to fund water quality efforts statewide, and we also have Senate Bill 299, which is specific to water quality in the Western Lake Erie Basin. But primarily at the Soil and Water Conservation, Division of Soil and Water Conservation, we work through soil and water conservation districts. There's a soil and water conservation district in each county, and it's a political sub-entity of the state of Ohio. They have an elected board there that leads conservation at a local level. So all our conservation efforts have a local leadership and can address the problems, the water quality issues that are present in that particular county. Up here in Western Lake Erie Basin, we have a pretty defined water quality problem, a pretty defined water quality goal to address harmful algal blooms in the Western Lake Erie Basin. And with that, we have several best management practices, things we can do out at agricultural operations to try to reduce the amount of phosphorus that leaves the farms and can end up fueling the algal bloom. So we conceptually kind of break our nutrient management practices, our best management practices, up into 3 bins. These are the shapes up there. We have practices that are nutrient management, soil management, and water management. All these are types of best management practices we can put out on the land to reduce the amount of phosphorus, and these are the types of best management practices we'll be looking to fund through soil and water conservation districts out in the Western Lake Erie Basin to reduce the amount of phosphorus. And just to give you an example of these types of practices, if we're talking best management practices that are nutrient management, those are over on the left side of the slide. We're looking at things like nutrient management planning, making sure that nutrient management plans are adhering to the 4R principles, putting out the right amount of fertilizer in the right place, the right time, in the right form. And with that, subsurface placement looks to be one of the most promising best management practices we can put out for nutrient management. We're going to be looking to incentivize this, try to increase the adoption of subsurface placement and timely placement of fertilizer to get that fertilizer in contact with the soil so phosphorus is held into place in the field where it needs to be for crops to grow and doesn't end up leaving the field, less risk of it leaving the field and ending up in the lake. And we're looking at incentivizing in-season application too, putting the phosphorus in the field at the time when the plant can utilize it, so there's less time period for that phosphorus to be lost. We also have soil management, best management practices. So nutrient management is all about how and when fertilizer goes on. Soil management practices, these are our more traditional preventing erosion. going back to reducing the amount of soil that leaves the field. A lot of the phosphorus that leaves the field is still attached to soil. If we can reduce the amount of soil leaving the field, we can reduce the total phosphorus leaving the field. And so we have a lot of best management practices centered around reducing erosion. These include the classical conservation tillage, no-till, reducing the amount of tillage and keeping the soil in place, putting in cover crops to reduce the amount of erosion again through the wintertime, and a small grain rotation. This is changing up the rotation where we're not looking at corn and soybeans year after year, but putting possibly a small grain in the rotation like wheat, something that'll overwinter, have a growing crop in the field through the winter, much like a cover crop. But a small grain rotation also can give us a time for a fertilizer application afterwards. If we harvest wheat in the middle of summer, we can apply nutrients after that at a time where they may be less susceptible to loss. And our third kind of overall bin of best management practices would be water management. I think if we look at how much load ends up in the lake, it's linked to how much water is being delivered every year, right? A lot of the load, a lot of the loss is triggered by large movements of water. If we put in efforts where we can hold water back on the landscape, we have drainage water management. That's the structure pictured up at the top. Something like that, you put that at the end of a drainage pipe leaving a field. In the wintertime, you can put a dam there basically at the end of the pipe, hold water back in the field, hopefully lessen the pulse of water leaving the field during rain events or melts, and lessen the pulse of nutrients leaving the field. And we also have other water retention type practices, much like that, with irrigation ponds where you can hold water in a pond or a wetland, or we put in conservation buffers where we're trying to slow the water leaving the field. So those are our three big kind of conceptual bins that we have for best management practices. And again, we're looking to put together programs at the state level to put out to soil and water conservation districts up here in the Western Lake Erie Basin that would incentivize producers, farmers to adopt these practices. And the exciting thing about H2 Ohio and Senate Bill 299 is this is a large funding source for these type of practices that we've never had before in the state. In the past, cost share for agricultural pollution at the state level has peaked at maybe $1 million a year. In the past few years, our cost share levels at the state level have been under about $150,000 a year of state cost share to address agricultural pollution statewide. So to have an investment like this from the state level, from this administration to come in and say, not only have the $20 million in 299 money, but an additional $30 million statewide to address agricultural pollution. And in addition to that, there was additional funding put into soil and water conservation districts this year. They received an additional $4 million plus of state cost share going into their into soil and water conservation districts. So to see that level of investment coming from the state into our efforts is what's new about this. A lot of these best management practices that I'm talking about, these aren't new or things that we haven't been doing in the past. But what's new about this is just the level of investment, the tens of millions of dollars that are going to come behind this and be sustained year after year to incentivize these types of practices is what is going to be new and coming out of the Ohio Department of Agriculture with H2 Ohio. Thank you.
Good afternoon. So my name is Mary Mertz, and I'm the director of the Ohio Department of Natural Resources, and I am really excited to be here with you this afternoon. I care about Lake Erie, and I bet every person in this room does as well. So I am really excited about what H2 Ohio is going to let us do, and want to talk a little bit about what ODNR's role in that effort will be. And I see one of our team members out there too, sitting in the audience, so glad you're here too. So we're going to focus on wetlands, right? We all remember the Great Black Swamp, not personally. I'm sure no one in this room personally remembers the Great Black Swamp, but the notion, the concept, the idea. So I'd like to say we're going to bring it back. We're not. But something like it, right? So common sense and the weight of the academic literature tells us that on balance, wetlands will be a great assist in reducing the phosphorus flowing into Lake Erie. So we know this is true. Now, how we do it is going to make a big difference. And I've got quite a team of scientists at the Department of Natural Resources to rely on to help us with that. But where we put those wetlands, the soil conditions of those locations, the vegetation we use within those wetlands, how long we expect them to provide returns. There's a lot, the flow through, the catchment areas. So there's probably 20 different criteria we need to look at with respect to each of these projects to make sure that we're investing these dollars really wisely. So I'm really excited about what we're going to be able to do. I mean, we're doing this leading with nutrient reduction and water quality, but we all know the side benefits, right? They're going to be wildlife habitat and lots of other opportunities with these wetlands. So that's what makes this sort of a win-win-win situation. So we have roughly categorized 3 different groups. Let's see. There we go. Okay, so we've put our plans roughly into 3 different groups. So coastal wetlands, inland Lake Erie wetlands. When I say that, what I'm referring to is kind of that 24, 27, 28 county area, the Western Lake Erie Basin, where we might position wetlands to be most effective. And then this is a statewide program, and there are harmful algal blooms other places than Lake Erie. And so we'll be doing some work statewide as well. But those are our rough categories, how we're looking at where we need to spend the money to make the biggest difference. And so you can see that $46 million was set aside for ODNR. And let me just take a minute to say, I think these funding categories don't read too much in the first year of it. This wasn't an assessment of what's most important or where we will spend the most money at the end of the day, but really it's a reflection of where we were ready to go. So, and I'll explain a little bit more of that as I go. So this is a picture that I look at often just to remind myself how critical and how urgent this is. So I went swimming there 4th of July. It did not look like that. So on 4th of July, because I was there over the holiday, it was beautiful and my family had a great time, and in just a short time later, that's what we've got. But for me, this is a constant reminder, because remember, part of my job is being in charge of all the state park beaches all over the state. And it's not a very fun job when I'm getting constant complaints about not being able to enjoy the beaches and our waterways and all those recreational opportunities. That's not what I want for the future of our state. So this is just my little reminder. So coastal wetland projects. So we had a head start there. So through federal Great Lakes Restoration Initiative funding, some of that has been used in previous years to assess certain areas, to do some basic conceptual work, to even do some engineering and design. So a lot of the projects that we're planning along Lake Erie are kind of teed up and ready to go, and they were just waiting for funding. So we're rolling on those. We're working on contracts. We're going to get these things constructed. We have a lot of great minds looking at them. You'll see some dots in the Sandusky Bay. That's part of the Sandusky Bay Initiative, something we've been working on for a long time. We're really committed to. You'll see some dots up in the Maumee Bay. These are areas we've also been committed to for a while. I think Representative Hoops, who was one of our great supporters with the H2 Ohio program and is a great partner, accompanied us up to see some of those sites where we can put wetlands in along the coast. And if any of you know Scudder Mackey, he's kind of our team lead to make these projects successful. So he's a guy, I think he knows what he's doing, and we're looking forward to some great success up here and measurable success. Each of these projects will include, intensive monitoring efforts, because we know we're not going to do it perfect, and we're going to need to course correct along the way and be nimble enough to do that. The other thing we mentioned up there is reconnecting diked wetlands. So, there's a lot of beautiful, particularly recreational wetlands along the coast. And they're kind of lined up right along the Lake Erie coast, and then in between them are these beautiful drainage ditches, which take everything from the agricultural fields or from anywhere upstream and go right out into Lake Erie, right between these beautiful wetlands. And so we want to work with our partners on how do we pump them through? How do we filter those through existing wetlands? So we'll not only build or restore wetlands, we'll also use some existing ones more effectively. So that's the gist of the coastal plan, and I think you're going to see some progress, I'm hoping real soon. So, so the Inland Western Lake Erie Basin Wetland Projects. So this is really about looking across the entire area and figuring out where are these best situated. And so our internal team has come up with several dozen ideas that we are working with scientists and higher education institutions across Ohio to look at, to analyze, narrow it down to a group where we have wetlands situated where we think they're going to make the biggest difference. But we're kind of working through that right now. And so statewide wetlands projects. You see the names of some state parks up there, and this is where people go when they want to go swimming and they want to enjoy it, and they're very frustrated right now that they can't do so. So that's sort of my leading list of where we need to focus some wetlands efforts in the year to come, but there's a lot of other places as well. So this isn't it. Buckeye Lake breaks my heart a little bit. You know, the state just spent $100 million on a new dam to make it a beautiful recreational lake again, but we had to put up red signs to warn people away. So we don't want to waste that investment. It's a great place. But all of these are, and we're looking forward to making a difference there. So that, in a nutshell, is where the Department of Natural Resources will really be focusing its efforts in the upcoming years to try to make a difference with the phosphorus loading and the algae blooms on Lake Erie. All right?
Well, great. I'm also excited to be here. I am cognizant that this is a missed opportunity. This is the first time I've been to this event, so I want to give kudos to all of the organizers. It's a big event, and what's exciting to me, so this is just a side note, I'm off script already, but the diversity of experience in this room. So I recognize some faces. You've got very experienced, seasoned professionals who have been involved in the water quality world forever. And then we have the student section over here, right? How many of you are students in attendance today? That's awesome. Oh, it's a group in the back, group in the front. Well, welcome to our world. I think, one of the things that is, it's our collective challenge and opportunity to work together, right? So we recognize the sense of urgency. We recognize the fact that there is, although work has been done, there's a lot of work yet to be done to spring to action, put in place measures that will yield results that are positive and impactful and sustainable. So in some respects, we will be passing along these challenges and opportunities to this generation coming up. And we met earlier with a group, and there were some students in there, and it's very exciting to hear your perspective, your areas of interest, your energy. You're up for the challenge. We welcome you. You're an important part of this equation moving forward, so recognize that. Be ready for it. But don't be afraid to share your perspective, your thoughts, your ideas, because they are important. So it's great to see such a diverse group here. I'm with Ohio EPA. I am kind of new to the water world, although I've been in the environmental world for quite some time. For students as well, just so that you know, I started my journey as a field inspector within Ohio EPA, and I stand here today. So my second message is never underestimate your potential, right? You can make a difference, and think big, take on leadership responsibilities, and make your voice heard, because you don't know where it's going to take you. So I'm excited to be here. I'm humbled to be here. I feel it's a privilege for me to be here. So I'm just going to share kind of my perspective, and I'm going to set the stage a bit. So far we've talked about the excitement of H2 Ohio. And as Joy said, I mean, kind of a recap of where we're at. And when we get the question of, well, what distinguishes this from everything else that's been done? So what's going to be done differently today moving forward? And I think hopefully you're getting the clear message that one of the things that is different is a strong level of collaboration and partnership between state agencies. So that is our message to you, and the expectation from the governor that we are going to work together and we are going to commit our full resources from leadership down to this initiative. So I think that is one thing that does set us apart moving forward from maybe what's been done in the past. And so, you know, in the H2 Ohio world, like we are all in with respect to water quality, improving water quality. We have a division of surface water, division of drinking and groundwater. We have staff who work day in and day out to improve water quality. So we are all in, all hands on deck related to that. But I'm going to shift gears a little bit, talk about some other focus areas under H2 Ohio that are also important. So if you hear the governor talk about what his vision is, with respect to H2 Ohio, it's very broad-based. I mean, he talks about clean water for all in Ohio, statewide. So it really doesn't get any more ambitious or broader than that. So I tell people the story of, you know, we've all met with many, many stakeholders, and some of the groups that I have met, and people might not be aware, but part of EPA's role, we have a long-standing role in helping communities with drinking water and wastewater infrastructure. So some people may not be aware of that, but we've worked for years and years and years with communities across Ohio to help them not only maintain the infrastructure that they have, but to improve upon that or to develop it where it doesn't exist. And surprisingly today, we have communities in Ohio where people do not have access to water, clean water, they don't have access to sewer systems. Or they have a septic system, and you know, not to be too graphic, but you flush your toilet and your septic system ends up in your backyard. Those conditions exist in Ohio today, in many areas of Ohio. So what we're hopeful to do under, you know, the governor's vision is get out to these disadvantaged communities to help them develop infrastructure where we desperately need that. So part of our avenue, and it's a little bit of a different turn, but we want to use some of our H2 Ohio resources to improve conditions for people outside of the Lake Erie Basin and other parts of the state who need help. So we would like to devote some of our resources to helping communities run water lines, to run sewer lines. We'd also like to help disadvantaged homeowners who can't afford to repair or replace septic systems to get those back up and running or to get them replaced. You know, a septic system is really a small piece of infrastructure. So that's really where we're hoping to some degree to make some headway in utilizing our money to address some of the infrastructure challenges that we have in the state. To improve not only water quality, but quite frankly, public health and the quality of life for people who need and deserve access to water. So the other thing that we want to do, and again, this is not just, it's an infrastructure need, but it's also a public health need. So a lot of you are aware that, you know, one potential exposure pathway for lead is through drinking water. So again, with a broad vision in mind, the governor has talked about his interest in addressing lead challenges in the state. So part of what we want to do is to try and focus in on potential areas where we may have exposures to susceptible populations in schools and daycares. So we were fortunate, along with Ohio Department of Health, to receive some federal grant money that we would like to use in combination with some H2 Ohio funding to pilot some lead assessment, removal and repair programs in urbanized areas of the state. So we are hopeful to work with Cincinnati and Cleveland potentially to jumpstart things, to figure out if we can get into some schools and daycares and figure out first, do we have a problem? Is it related to old drinking water fixtures or lead pipes? And can we fund and replace and remove those and reduce that potential exposure in those areas? So that's one of our other focus areas, again, working in partnership with a couple of other agencies as well. So finally, we talked a little bit about, our interest in water quality, and I think collectively across the board, all agencies are interested in, what does the future hold? So some of you are probably out there representing companies or organizations that may have ideas on how we approach this also from a treatment technology standpoint. So if we're not asking the question of what's out there, what's emerging, what may work, what do we need to incubate and support and develop within Ohio from a technology standpoint, we want to create some space under the H2 Ohio program to allow these companies and organizations to come and talk with us about their ideas, to support those ideas, to support the development, to help them with research and development, and maybe launching some of the future solutions that we don't yet know about because we're not asking the questions. So we've created a placeholder for some research and development incubation that is kind of a work in progress, but that's the intention there, is to create some space for innovation. What does the future hold? And that's really it for the EPA piece of the H2 Ohio initiative. So I'm going to turn it back to Joy, who's going to kind of wrap up and let everyone know next steps related to our planning.
So we have, excuse me, certainly been hard at work in thinking through how agencies will spend their money in the next year. If you have ever heard Governor DeWine talk about this issue, he has been very open in saying that we are figuring things out as we go along. And since I think I'm talking to a room of a lot of scientists, you also know there are things we know and there are things that we don't know when it comes to Lake Erie. And I guess the analogy is, it's riding a bike and building a bike while you're riding it. So we are investing in things that we know works. The research shows certain practices will take phosphorus out of the system. They will keep it from entering the system in the first place. So let's invest in those practices. And we're certainly looking at that technology and innovation piece to see if there's something new that we don't know about that can help advance the cause. We want to involve that. And we also definitely recognize that this is an adaptive management process. So I know that's a term that gets used when you're talking about restoration work these days, but we definitely want to keep that feedback loop going. So we're working with a lot of the institutions represented here on collecting the data, collecting the right science, getting that and putting that into the decision-making loop so that we're making decisions with the best available data on hand. So that as we look at year 2, hopefully year 3 and 4, we will have new information leading us down the pathway of what's going to fix our algal bloom challenge. And we also had a good meeting with Sandy Bin and Alicia Smith, and so they also brought forth the fact that it's not just a scientific puzzle, that it's also very much a human health issue. This impacts the people living in Northwest Ohio, and so we recognize that people are dealing with this on a daily basis, and we're mindful of that, but we also recognize that the problem took several years to create, and unfortunately it will not go away overnight no matter what we're investing in. And so we are definitely interested in continuing the conversations with all of you to make sure that we're getting the right information, we're collecting it, one of your institutions is collecting it so that we're making the best decisions we can at the time. So we're certainly looking forward to future meetings with all of you on H2 Ohio as we move forward. So.
Great, thank you for that. That was fantastic. I have no questions. You've answered everything that was submitted online, and so, just kidding. So we're going to ask the panel to stay up here, actually just in their seats, and from the podium here, I'll ask questions. They are all mic'd up like the rock stars that they are, and so we'll go into that. But the first question was, how are you working collaboratively to achieve the 40% reduction? I know that's been talked about throughout this presentation. Perhaps I can add and say, how are you working collaboratively with maybe some of our federal partners that are out there? Like, how do these things align with GLRI, or even in the wetland space? Director Mertz, we know there's a lot with the Fish and Wildlife doing wetland work of their own. So can you talk perhaps a little bit about how collaboration is happening, not just across these agencies, but to our federal partners? And please, anyone, feel free to jump in.
Well, since you mentioned GLRI, is this working? Is that okay? Since you mentioned GLRI, so I mentioned a lot of what we're doing along the coast. This was teed up by GLRI, right? So the early work was done through this federal funding, and when we started making lists of what projects we wanted to fully fund for construction, as they've been funded through federal funds, we just check them off, right? So we put them in order of what's most important to make a difference. And if it gets taken care of on the federal level, we just keep moving down the list. We've spent time with NRCS, and they have a lot of interest in the field. And so we gave all of our projects to them to vet them, all the few dozen inland projects for them to look at. And what we're hoping is we can interest them in funding some additional ones as well, right? You know, so that's two levels of interest. One, I respect their scientific expertise, but two, I'd like to queue up their interest to pay for a few as well. And you know, we have some great federal legislators too that I think want to be helpful and want to be part of this as well. So on our end, those are a lot of the contacts we're making.
Absolutely, and we know we have representation from Lotta's office, Portman's office, Senator Brown's office, so it's great to see that involvement in the room. Anyone else want to add?
Well, I might just add in a little bit. I mean, I think our first priority was to get our agencies in alignment. So really right out of the starting gate, and Director Mertz said this, the first week on the job and every week after that, the four directors have been meeting to talk about where have we been, where are we going, what are our respective roles, where are our lanes, and how can we work together to come up with a broad portfolio of ideas that we feel will be impactful. So that was our first run, is to get ourselves organized and together. But you know, I guess I'll speak a little bit to the future. With respect to the nexus at the federal level, you know, and we have been actively talking, we at OhioEB have been actively talking with US EPA, and they're very interested in what we're doing as a state and the progress that we're making, and they have an interest in getting engaged and also working in partnership. They are coming to the table in the spirit of partnership. So I see some real potential there, but I think from our perspective, as we look at what our future needs are going to be and how we solicit ideas and feedback on the infrastructure pieces, we are going to need help, and we are going to need input, and we're going to need partnership with communities to help us identify where are those areas of need and how do we reach out to communities and bring them through the door with their projects and ideas. So I think there's a lot of future potential for partnerships beyond, you know, the folks on this stage.
Good, we'll move on. So there has been some discussion about possibly supporting a pilot watershed where BMP adoption rates could be greatly increased. I know Jay Martin had mentioned this at the end of his talk. If possible, could you speak about this plan, and if there is a plan, how are discussions about how that watershed might be identified?
I think that's you.
I think that's me. So, yes, I think one of the concepts on the table is to put together a targeted watershed, or a watershed where we could focus a lot of efforts, take some of the cost share money that we have available for agricultural practices and try to concentrate them in a HUC 12 area, an area about 15,000 acres that has water quality monitoring associated with that. So we could really see if we're able to really saturate this area with agricultural best management practices. If we can do everything we can do, will we see the impact we expect on water quality monitoring and the phosphorus leaving that watershed? So that's one of the concepts we're talking about. I think the second part of your question is, can I talk about where are we thinking about doing that? Not yet. I think, because of one of the things that we'd like to have a conversation with people in that watershed first. I mean, this is going to be a major undertaking, and we're going to probably rely on voluntary conservation in order to get this done. So a lot of hand-to-hand kitchen table work will need to be done to get that saturation of agricultural best management practices in a watershed. So we're thinking about it, trying to figure out where a good place to work for us is, where we have the monitoring, but I think more details of that will come out in the future.
Great, thanks. And I know when I've heard about this, people are really treading softly about that word targeted, because sometimes that has a negative connotation to it. And so I hear a lot of people talking about piloted because it's an opportunity. It's really not a kind of a punishment kind of thing. And so I think that's a real positive step, and just how we message some of these initiatives is really, really great. Director Stevenson, you mentioned a little bit about this on your last slide about the monitoring and the emerging technology. There's a question being asked here, how is progress going to be monitored or benchmarked in regards to the amount of nutrients being delivered? So is it new monitoring stations or looking at the current ones differently? Can you give us a little insight to that if possible?
I'll kick it off, and then I'm going to turn it over to everybody else. I think, again, what sets us apart from things that may have been tried in the past, we have a keen interest and focus on figuring out what are the measurements and the outcomes, what are the outputs and the outcomes, right? Distinguishing between those. So we do want to tether quantifiable measurements with all of these action items. So that will be part of our overall strategy, whether it's nutrient reduction measurement, whether it's, acreage under BMPs, whether it's, how many homes did we take off of failing septic systems? What were the water quality and public health benefits? How many people were impacted in a positive way by some of the work we're going to do? So there's probably a broad spectrum of different measurements that will go into this plan, but it is our goal to make sure that we are measuring everything along the way. So from a water quality perspective, I mean, we gather a lot of data. So I don't want to be misunderstood, but I think the question becomes, are there more monitoring stations, or are there more points of measurement that we need to help us tell the story of, are we making progress? Do we need to course correct? Are we on target? So I guess that's where I see us going in terms of assessing what are our data needs with an eye on being able to talk about success.
Anyone else?
So I will also add, the Lake Erie Commission is actually responsible for providing a report on how we spent the H2 Ohio money, and so we've heard a lot about accountability. You can't actually have a meeting in Columbus without the phrase coming up, how are you going to show accountability with this? And it's a lot of money, and absolutely we need to be accountable for it. And so, part of what I envision is being able to take the achievements from these agencies and converting that into a public website so that everyone's able to see on a regular basis exactly what's happening. So that obviously isn't happening yet today, but absolutely I want everyone to be able to see exactly what is being achieved on the state level.
I'll just throw in from on the wetland piece of it, right? So we have Old Woman's Creek and a bunch of scientists there who have done a lot of great work on how to monitor the nutrient reduction and the efficacy of the wetlands there. And there's a team of folks there who are gathering and bringing in a lot of outside higher education institution folks to put together a monitoring team for the wetlands. Me not being a scientist say, what's the problem? Measure the water where it comes in, measure the water where it goes out, we're done. What do we need the team for? They all have PhDs and explained to me that I'm very wrong, and it's way more complicated than that, and I have a tremendous amount of respect for them, but there is an active team on how on the, on the wetland piece of it, which I'm focused on, how we really measure the results, what they mean, what they contribute to the overall phosphorus reduction in the lake, and they're hard at work at that. And it's a good thing I'm not on that team. I will simply appreciate their results.
That's great. And I know that Dr. Laura Kearns and Dr. Christy Arndt are here today, so if, where are they sitting?
All right.
Or Janice Kearns, I'm sorry, not Laura Kearns,
Okay.
Janice Kearns.
There's the team, right?
There's the team back there, so
You
please.
know I appreciate you.
Another question is, are there plans being considered to support the management of manure, methods to transport manure a bit further to where it can be better utilized, or methods to remove phosphorus from manure before it's applied?
One of the programs that we introduced this past year through Senate Bill 299 was an incentive to try and kind of change the way manure is managed in the Western Lake Erie Basin. And it was an incentive to farmers to do several things, including changing their manure management. But it put together 3 of our best management practices. One was to plant wheat, plant something that would overwinter and kind of act as a cover crop and get harvested early. It would get harvested in July or August, and then follow that up with manure application. So one of the challenges with manure application is usually it's applied in the spring, or it's sandwiched into the fall after harvest, and it can be a wet or challenging time to put manure out. So with this program, we were trying to get wheat out there and get the manure applied in the summertime when the ground's dry, the rain may not be as much of a challenge, and get that nutrient into the soil when it's less susceptible to loss. And then the third best management practice behind that was followed up with a cover crop. So to immediately plant a cover crop into the manure to hopefully take up some of that nutrient and hold the nutrient in the field through the winter for the next crop that would be planted the following spring. So we do have some programs in place right now where we are trying to incentivize different manure management, get it applied at different times a year. And with that program, what we also saw is people enrolled in that program who hadn't applied manure in the past. These weren't, they were willing to plant the wheat and have manure applied to their field as a nutrient source, and that helps us kind of spread the manure across the landscape, which helps reduce the risk of phosphorus loss from those sites.
Great. Another question we have here, are there plans to use H2 Ohio funds to support research projects in addition to the implementation of projects?
I don't know if that's covered in the, we talked about the placeholder that we have for kind of incubating technology ideas. So I don't know if that really covers the question, but I think, that's still a work in progress. We're still talking through that. I mean, we are specifically focused on what are the emerging technology ideas out there and research around that. So we definitely plan to try and support some space for that. I'm not sure if that answers the question or if someone had something different in mind when they posed that question.
I think they're alluding to the research as far as the innovation, but even some of the research on maybe the wetlands, like are some more effective at drawing down nutrients than others, or more creative ways to measure contributions from the streams relative to edge of field. So just kind of more, I guess it falls in line with that monitoring question and how we're benchmarking, and so that kind of space for research.
So we know the Sea Grant program has a robust research opportunity. And we are very hopeful that that group will be really interested in H2O and be supporting research projects. You know, I think we don't know the answer to that. I'm going to be honest. I mean, I haven't in my mind said, oh, I need to set aside 1% for research projects, right? Because I'm a huge believer in research, right? But you know, we've had a lot of planning over the years, right? Over the last 10 years. Lots of planning, lots of research. You can never have enough planning. You can never have enough research. And so some of the focus now is, let's do some things. Let's do some things, and then we can research the new things, and let's do some things that are going to make a difference out in the lake. But I don't want that to be interpreted as, I don't believe in research and nothing will ever be spent on that. I can just say, at the moment, we're really focused on how do we get in the field, get our hands in the dirt, get our hands in the water, and see a difference. And as we begin to do that, I mean, it's inevitable. We want to understand what we're doing and how to either replicate it or stop it and readjust. So.
Well, thank you for the plug for Ohio Sea Grant. So, but what Director Mertz is referring to, since 2015 to present day, there's been $2 million that's come through the Ohio Department of Higher Education to fund the amazing academic research institutions you have across the room. So the Bowling Green State Universities, the Toledos, the Kents, the Akrons, the University of Cincinnati, I can go on. Basically, the agencies identify research projects, and then those funds are used to support that. So thank you for that response. So there's a question here that says, are there considerations to taking agricultural lands out of production and using it to produce renewable energy?
So I think you heard a little bit about, you know, what our current plans are for year one, and that's not on the list. But, you know, we're certainly continuing the conversations about what's the most useful type of project, type of work as we move forward. You know, we certainly want to make sure that we're targeting projects that are pulling that phosphorus out as efficiently as possible. And I think we've heard a little bit about how some of the renewable energy plants can pull that phosphorus out pretty efficiently. So I think the conversation will continue, but as of yet, it's not part of year one, but certainly part of the conversation.
Good, and to put that in context, I know with some of our colleagues up at Michigan State University, you know, putting ag lands into wetlands, but then also putting solar panels over the top of those wetland facilities where, you know, the wetland serves a purpose in drawing down nutrients, but then also that land is out of production, and where's the revenue for that producer? And so I think that's kind of where this question might be getting at, is how do we compensate a farmer for taking land out of production to do something that's beneficial for the watershed? Another question that was submitted is, recently, September of this month, the Ohio Department of Agriculture issued a draft permit for a swine farm in the Auglaize, Maumee, Lake Erie watershed. The question is, what criteria is the Ohio Department of Agriculture using to make these decisions?
So the Ohio Department of Agriculture issues permits for large CAFOs. For example, if a swine operation has over 2,500 hogs at a site, they are required to have a permit through the Ohio Department of Agriculture. There's a list of criteria and rules, basically around siting, the infrastructure that needs to be in place, the management of the manure there. So there are a list of criteria that a large CAFO would need to meet in order to construct and hold and operate the manure at the site. And if the applicant meets the criteria, they're granted the permit. There is a public hearing that is involved with the permitting process also.
Great, thank you for that. We only have about 2 more minutes, so I'm looking at the question here. I guess this is a pretty general question, so I might just ask for as we go down the line, because each agency up here has a different tool and toolbox. So the question is being asked, what do you feel is the most important or impactful practice that can be put on the landscape to improve water quality? So maybe from each of your perspective, again, there are many tools in the toolbox, but given the conversations that you're having, could you maybe give us insight if what would be the most impactful practice for you and your agency? So, Director Stevenson?
We're starting on this.
Please.
Start down there. I'm going to let others comment on Lake Erie. I think infrastructure is a huge issue for us. And like I said, we all deserve access to clean water, regardless of where we are in the state. So I think again, there are areas of the state that have been overlooked for quite some time and need help in just getting basic services provided to them so they can be safe and healthy and live a good quality of life. So I do key in a little bit on infrastructure improvements because I think they are important, and sometimes that gets lost in the discussion.
Thank you. Dr. Marks?
I'm going to say, I mean, I don't think there is any single practice that's going to get us all the way there. So I've talked a lot about wetlands. Wetlands is not going to solve the 40% reduction problem, and I'm not going to pretend that it is, but I think it could be a good contributor. So, no silver bullet, nothing's going to do the whole thing. I think the advantage of what we're working on is a little quicker to make progress with, but it will always be a limited progress. But within the wetland sphere, I'll say some of the things I'm most excited about are the reconnecting diked wetlands to existing ditches and existing waterways and using those wetlands that are there in a way they haven't been connected before. I think for us, some of our quicker wins are going to be in that area, just because it'll take a while to construct, build, and grow the other ones. So that's
Fantastic. Matt?
I would echo that there are no silver bullets, but I think the most promising or the most exciting thing in agriculture is the fertilizer placement, being able to put fertilizer in contact with the soil. Typically, if you're not familiar now, the fertilizer is broadcast across the surface. It's a very quick operation that can be done, and large amounts of acres can be covered in a short amount of time. And fertilizer placement has its own challenges. It takes longer to put the fertilizer in contact with the soil, but doing that can help reduce the risk of loss from the site. So we see technology evolving around this, being able to do this through different technology in agricultural implements, and hopefully this could be one of the most exciting things to still be able to get the phosphorus in the field and grow the crops that we need to grow, but reduce the risk of loss while we're doing it.
Great, thank you. Dr. Mullen?
So again, no silver bullet. I look at this as sort of a complex puzzle in that you're looking at farms that all have different features, different slopes, different soils. So the effectiveness of a practice is not universal throughout the 4 million acres of the Maumee River watershed. And on top of that, for each farmer, there's a different incentive. I think sometimes it's economics, sometimes there are other factors involved. And so you also have to look at what is going to motivate the farmer to participate in a practice, and that changes depending on who you're dealing with. And so, you kind of have to look at this as a complete puzzle to figure out what's going to be effective. And, the models have shown that there are different practices available that we can turn to, and different rates of effectiveness. And so I think it's trying to figure out how we come up with a suite of practices and the right number of acres being enrolled in programs to figure out how to reach that reduction target.
Great, thank you. So I personally appreciate this is a complex problem, and to see that the diverse portfolio of things that are on the table. I know that was a tough question to answer there, but to see clearly that all of you recognize how complex this is, and how it's all hands on deck, and the collaboration that I've been able to witness under this current administration. But these agencies have impressed me for many years now, since coming to Sea Grant, to see the blooms show up in higher prevalence now than historically, and seeing that it's actually brought folks together. The academic institutions are talking to the agencies, and to see the crosstalk across the agencies has been phenomenal to see. And so I guess I'll pause there and just ask the audience in thanking our distinguished panel members. So Rick is the NCOS employee with the National Oceanic and Atmospheric Administration that is a key player in taking the loading data that primarily comes from Heidelberg University's National Center for Water Quality Research, takes that information in conjunction with other models and satellite data, does a phenomenal job of giving us a good prediction of what we might likely see in the lake in terms of blooms. Not only is Rick a well-accomplished scientist, but he's just one of those individuals in this room today that's really easy to work with, very collegial, and just a pleasure to engage with. So if you please join me in welcoming Dr. Rick Stumpf.
Thank you so much, Chris. It's a real pleasure to be up here. I think you can probably hear me okay in the back? Yeah, okay, good. Okay, forecasting the bloom in Lake Erie. If we understand something, we should be able to forecast it. And if we forecast, we can understand. And this becomes critical for everything you heard just from the directors. You can't, if we don't know what's driving the bloom or the timing or that sort of thing, we can't actually lay out an appropriate management strategy. So what I'm going to talk about, we just did the 8th year of a seasonal forecast for Lake Erie. I'm going to talk about what that is and what we've learned in the course of doing this. And the goal is to stop seeing what we're looking at in this slide. There was a problem in the 60s and 70s. And by the way, I think this is Jeff Reuter's hand. My understanding, he was a grad student. And of course, that's the job of grad students, is to do this sort of thing. But yes, it was a problem. That got cleaned up. The Clean Water Act, the International Joint Commission, Great Lakes Water Quality Agreement, phosphorus reduction from all the point sources, and Lake Erie was good. It showed up again. 2003, first strong bloom in years. This is the Landsat image showing the area. And assessment was made. This was perhaps the most severe bloom recently seen in Lake Erie, 2003. That's almost ancient history now for us, we think here. Well, yeah, it wasn't the most severe bloom in recent history. We had more blooms, 8, 9, and 10, and they were quite bad. Then there was 2011, and it rained in May, and rained, and rained. And that's what Lake Erie looked like in July. And in fact, in August, the whole Western Basin, except the Detroit River plume. In October, it was all of Ohio. The Ohio coast was covered. I'm sure some of anyone who does boating or fishing can recount over in the Cleveland area how bad that was. So this major issue. Something needed to be done. Ohio Lake Erie Phosphorus Task Force was set up. Questions about driving the blooms, nutrients, phosphorus, but when, how, what's driving it. General sense, there's phosphorus as a factor. But of course, we need to know how much bloom there is. That's a part of this. You can't say what's driving it if you don't know how much there is. And you also need the nutrients. Well, just to put us in context with phosphorus, excess phosphorus drives the blooms. This is its concentration and the risk of cyanobacteria. And pretty much when you get over about 100 micrograms per liter of phosphorus, you're pretty much assured to have cyanobacteria. Well, fortunately here, there's this phenomenal data set, most incredible monitoring program, probably in the country, Heidelberg runs. Dave Baker, I think, got that started, and he's in the room somewhere, and Laura Johnson's now running this. This is just amazing. And it actually shows with like the dissolved phosphorus, you can see I was high in the 70s and it dropped down, and it started coming back up in this century, which is coincident with the blooms. But they get data up to 3 times a day at a whole series of places. Laura's over there. I'm not sure where Dave is, but yeah, wave your hands. This is amazing. None of this could be, we can't do anything here without them. And 50th anniversary of it. So satellites, we all used to pretty pictures with the satellites. We can do a lot more than that. We take the spectrum. I'm not going to go into the physics and the biooptics of this. Take my word for it. But if you're really interested, I'll be happy to expound on it for hours, even over beer. But we can turn this in and come up with the concentration of bloom. So if we do that, we can then work out the data and come up with it each year, which we have here. And this was back, we did in 2011 or 12. And you can see there was pretty much nothing except Sandusky Bay. Sandusky Bay, I don't know, they had a bloom forever. George Bolerjon's been working on that, but it starts early and it keeps going. But the rest of it was nothing in 2002, very mild blooms in 5, 6, and 7, very mild, and then we see the strong blooms in 8, 9, and 10, covering much of the western basin. Well, the question, is it annual load? Is it spring load? What sort of load is this? Well, we worked through this, and this is the model we had in 2012, spring, March to June. The annual load doesn't drive the blooms, it's the spring load. And that's important, I'll say, because that 2005 and 2007, where there was no bloom, very wet winters. They had a wet water year. So that winter was high flow in 5 and 7. There was no bloom. The spring matters. That's what we concluded. Okay, so we got a model here. If we understand, we ought to be able to forecast. All right, so 2012, nature set up an excellent experiment for us. Thank you, Mother Nature. After this incredibly wet spring, this is total phosphorus and also discharge in 2011, really dry spring in 2012. So we based the model, we understand it, we can forecast it. This is where the rubber hits the road. And I might add, on the science side, scientists, we like to write the papers, we write the paper, then we go on and do something else. There's no better test than turn around and say, okay, can we actually do something with the data? July 5th, 2012, first forecast at Stone Lab. By the way, I flew out, I'm in Maryland, I flew out to Ohio on July 4th, and it was clear at night. It was awesome. I watched fireworks the whole way to Ohio. It was great. But our forecast, 2012 bloom would be mild. That was the forecast, literally. That's a direct quote, just mild. This was the graph we showed. Excellent test year. We had a wet winter, dry spring. And by the way, we did not have a severity metric. We got it right. Mild bloom. This is the model, the forecast, and what we came up with from satellite. Excellent. Let's do it again. 2013. So our forecast for 13 was going to be smallish bloom. 2003 at that, and back in 2005 was considered a big bloom. Well, not anymore. And so 1/5 of 2011 would be like a 2003 bloom. That's our forecast for 13. Okay. Famous proverb. Yeah. 2012 was the second most intense bloom we'd seen. Concentrated very much in the western basin. Yes, we were wrong in 2013. Nobody here remembers that, do you? Right. Yeah. So I'm exposing all the stuff here. We have 2 years of forecast. We got 2012 right. 2013 was very wrong. Okay. So can we learn anything? Let's step back. This is an important concept. All models are wrong. But 2013 was useful. It was not so wrong as not to be useful. So we looked at the data again. And what was different? Well, we're using loads from March to June, and we looked at July discharge, and July load. And 2013 had a really high July discharge. There was flooding in July. But interestingly, 2003 and 2008 also had high discharge. So why wasn't 2003 a huge bloom year? It's just a bad year, but not a huge year. Well, they like it hot. Microcystis aeruginosa, I marked it in red. These are various cyanobacteria. They all like it hot. But especially if it's below about 20 degrees centigrade, 68 Fahrenheit, it doesn't really grow. Above that, it grows really well. So what was different, if we compare those 2 years, in June, the 2003 was cold, 64 degrees Fahrenheit, 18 Celsius, but 2013 was quite warm. A temperature could grow. So the cyanobacteria could start growing. Microcystis could start growing in June in 2013, but it wouldn't have been growing in 2003. In fact, my colleagues, Gary Fonensteel and Pat Tester, were out in 2003. And the first week in August before the bloom took off, they were still seeing spring diatoms in western Lake Erie. So it was still cold, late July, early August. So the bloom took a while to get started. So quite possibly, it's not going, so it doesn't have a chance to tap those nutrients in July, whereas in 2013, it was already growing. So now here's another pulse of nutrients. We now have a bloom, okay? So warm Junes, probably are going to be routine into the future. There's this thing called climate change, so we may very well expect to see that. And so we very likely will always include July. So we now have July in the system, when June is warm. And normally July is a dry month, but as we'll go on here, we've seen some other stuff. So 2014, another thing we learned in 2013 is we need a numeric severity index. And I don't know if Melinda Huntley here, Ohio Tourism's here, but she came up to me after 13 and said, please give us a number. Like, they have the hurricanes, 1 to 5 or other things. And I was already struggling with adjectives. We say major, bad, good, severe, awful. What do we use? Okay. 5.5 out of 10. We set a scale, worked out a scale on this. 2011, the worst bloom we'd ever had would be 10. And then if we figure, because we'd never see anything as bad as 2011, this is foreshadowing, by the way, sign of quality film, where we'd ever see anything like that again. And so here's the forecast for 14. Well, there's also, so we do the biomass over the peak 10 days, so over 30 days. That's the severity metric. That's how we get there. In case you all wonder where the number, there's a little mathematical stuff also. So anyway, that's the forecast. Now, a little side thing, we had a problem in 2014. I don't need to tell you about what this problem was. There was a bloom. We could see it on the satellite. You can see July 31st. The water treatment issue started right after. Key parts in this is the bloom increased really rapidly at the end of July. We can't right now predict the timing of the bloom. That's a key thing we need to work on, is why did they start earlier? And this started a little earlier, and in fact, this is continuing into the future. So that's a key part to that. There's another part I'll say in the forecast is these blooms, the microcystis in Lake Erie always produces toxin, but it doesn't always produce the same amount of toxin. Those cells don't churn out the same amount of toxin each year. They don't produce the same amount over time. It's stronger, as you can see here, it's stronger early in the season than it is later. Those peaks, sorry, these are days of a number of samples, but that peak there starts right on August 1st in 2014. And you can see it's 4 times greater than it was at all in 2015. This is the amount of toxin per cell that's coming out. But you can also see it decreases over time. Now, Justin Chaffin, who's somewhere in the room here, Justin, if you raise your hand, he's leading, way in the back, he's leading a project to actually work at a method to forecast toxicity. This involves the toxin microcystins use a lot of nitrogen, so that may be a factor, but there's also some indication that the strains, not all strains produce toxin, there may be light availability, so we're trying to put all that together. I'm just on the technical advisory. We, as Justin and Tim Davis and a number of other people, to come up with that, because if we can do that, that will help a lot on these kind of efforts. Another thing, there's some other fascinating stuff going on here, and Morgan Steffen and Steve Wellham and company noted it was an odd bloom. Very interesting paper in Environmental Science and Technology on this whole bloom. But anyway, key thing is not toxicity. We can't do that. So that's a little diversion there. We get to 2015. We now decided, you may not realize, we do an early season projection. We start in early May. So we decided to start that in the beginning of May. And part of the reason for that was, first, Heather Raymond was saying, it's too late in July. The budget year starts July 1st. So we need more information. And then we also found there's some DIY forecasts starting. Every time it rained, someone would tweet something about, oh my God, we're all going to die. It's going to be a lake. So we figured we had to do something. So we're going to start with climatology. What's a good thing? Climatology is a good thing to use. We use the data, Laura's data, the Heidelberg data up to the date of there. So we start March 1st. We collect all the phosphorus data until whatever day, like June 1st. So we have a few months. And then we use the climatology to go the rest of the time into July. That's a good idea. Anything wrong with using climatology? Well, it's fine if you're in climatological normal, but it rained. And I talked about the rain before. It rained in June a whole lot more than it rained in whatever May that was, and it rained. And our forecast kept going up. This is the highest recorded discharge ever in June. Oh, and by the way, 2015 had the highest recorded discharge in July. Also, climatology, isn't it great? We just set an all-time record, first time we tried this. So in June, we were down at, it's going to only be a 3. Our forecast put it up somewhere in 7 to 8, so maybe the second or third largest. And I should just say again, it was bad. Wettest month in Fort Wayne, 4th wettest in June, top 20 months, record discharge. Bad, lots of nutrients, largest June loads record. And it got worse. This is 40 days of scum. Kind of fitting after a flood, you would have 40 days of something, isn't it? Okay. 300 square miles, that's of scum. That's not talking about the several thousand square miles of bloom over the lake. That's just 300 square miles of scum. And keep in mind, we're looking from Maumee down just about to the islands of scum. So, 2010, yeah, we'll never have a bloom that bad again. 10 and a half. Now, we started an ensemble that year with the forecast. You may have noticed going back here on, there's error bars, but there are multiple forecasts. We did an ensemble. And that included several. There's work, University of Michigan model, Limnotech, Ed Verhamy's here somewhere. They have the WLEB model. And so we put those together to do a forecast. But at least some of the models actually were forecasting up in the neighborhood of 10. I would say at the time, we didn't have enough confidence in the model, so we knew if we said it was bad, at least second worst, that got all the attention we need. There was no way after, keep in mind Toledo, we were going to say we could have the worst bloom ever because it's already bad enough to say it might be the second bad. It's bad enough that actually, I'm sorry to say, when we issued the forecast, I'll be serious on this, people went and bought bottled water. And that's bad. That is not what should be happening here. So we're trying to message. We changed the messaging a lot also to emphasize this is slow. We know where the bloom's going, and also the water treatment plants. They know what's going on. They now have better instrumentation that they're able to treat the water very effectively now. That sort of thing is not going to happen again. I'll speak confidently. I don't work for the city, but I will speak confidently. It won't happen again, because they know how to handle the water. But we do have different models. And a great thing is the WLEB model is a complex numerical model, and ours is a relatively simple statistical model. Well, one of the reasons for models is forecasts so we can understand. Well, if you understand, you can also come up with things like a target, a 40% reduction. Well, one of the key reasons for that is if you look at one line, that's our model, and the red point is the WLEB model, and they land right together. Two totally different ways of approaching this came up with the same answer. And we ended out with results working through this, the 40% reduction, by coming up with completely independent approaches, combined with a whole set of other stuff. Gail Hess and Jeff Reuter can tell you stories about getting through these targets because they were leading that agreement. But it's a key thing to have two different models coming up with this. And it's really important to use different models with different set of assumptions. Okay. So now we're in 2016, so we learned a few things. We know about July as being really bad. We have multiple models now. Here's our ensemble of models, and I would note that we're forecasting a bloom. We forecast a bloom that was much worse than what actually happened. One of those blooms, one of the models actually got it right. It's right in that green. All the rest were high. Okay, great. Well, we were right for a few years, 14, 15. So right now we got 3 right and 2 wrong, 60%. Good for baseball, yeah, good. But anyway, we're at 60% here. So can we learn something here? Well, nearly every model included an internal load of phosphorus, which you might call like a legacy in the lake, phosphorus from previous years. And so it's the idea versus the external load, which is the load that flows in. And we added an internal load because of some other characteristics. They were all large. And also, even though the growth started early, it does stall when you run out of phosphorus. But the key thing is they all included this. The one model that did not include an internal load was the one that ended out right where that bar crosses it. It actually got it right. Now, what's really good about what this makes is the message is that it appears to be the load from the tributary, from the Maumee River is what really matters, that drives this. So that's the indication we had in 2016. Suggestion. Okay, 2017, we're right, not terribly interesting, except it was a bad bloom, which is, unfortunately, should be interesting, but it's, unfortunately, it was. And you know there was the problem from downtown Toledo. We don't need to capture that. Well, 2018, we had the same problem again as 2016, an overestimate of the bloom. And the problem was repeated with the models that include this legacy, this internal loading in Lake Erie. The ones that included that also overestimated, so the 2018 bloom was also overestimated as well. So a key message out of that is we are this year we de-emphasize models that use internal loading because they have been twice severely overestimating the bloom. But this is a really important message from the potential ability to impact the lake, because when the flow dropped, when the load dropped from the Maumee River, the bloom got smaller. That means if all the stuff we've heard before, we do something, it will matter immediately. That's the key message we've gotten out of 2016 and 2018. Some other interesting things in 2018 is climate factor. The bloom started early. It's the earliest we've ever seen the bloom started. And that's because the lake warmed up very rapidly. It was already up to, it actually hit 20 C. This is actually in the middle of the open lake, but it actually hit 20 degrees centigrade in the Western Basin about Memorial Day weekend. Very unusual. And there was another spike in June. And so the cynos got started. And very unusually, 2018 last year, we actually had the bloom going when we did the forecast, second week in July. That's the first time that ever happened at all. So the other part is it ended early. In September, we had relatively high winds in September, and they didn't stop. And so then you get the cold water. And cyanobacteria, the reason the scum, it goes up and down in the water. This is 3 billion years of evolution, so it can take advantage of that. Well, it doesn't do well in turbulent water. That's not what it's designed for. So having a lot of turbulence when you have the temperature drop really drives that factor. Most years, the bloom tends to peak in late August and then in September. But yeah, here we can see the June 20th. So just as a little aside here, a divergent, there are other forecasts going on besides the seasonal. We do short term. The bulletin, I would hope everybody in this room gets the bulletin, the NOAA bulletin. And so we have a forecast there, example from 2011 on the right side. And then there's also, we've now added a 3D model that was developed at Glaryl, Mark Rowe up there. So we're actually looking at the movement of the bloom up and down in the water combined with this whole circulation to capture that. So we can see some of the patterns and movements of the bloom overall. So we do these short-term forecasts. And just to show the 3D model, this is the short term getting the mixing really important. This is over time, and where it's bright red up at the surface, that's where where cyanobacteria accumulated at the surface. And where it's a uniform bluish all the way through, it's homogeneous. So you can see there's certain days when the winds would have been calm, basically below about 5-6 knots, and then accumulates at the surface. And then when the winds are blowing 10-15 knots, it mixes all through the water. Why would this matter? How many people here like to boat? Okay, you'd really like to know a forecast to say there's not going to be any scum, right? That would be good. Anybody and people, I won't ask anyone who wants a water treatment plant to hold up their hand, but you'd really like to know if it's going to be down below because your intakes are down below. So one person's good point is another bad one. So it's very important to know that in order to plan accordingly and to avoid any of those issues. So forecasting, there may need to be a change in the treatment or also planning for the others. So that captures kind of a side thing. So, okay, so how are we on the forecast? As I say, the model this year is more emphasis on the external load models, the ensemble. Our forecast is somewhere about 7.5, and that would put it about or a little behind 2017. Now, I'll put in another. You already read the rest of the slides, so I don't need to capture that. We are behind 2017, which is good. An important thing this year is, as you know, it was wet again. Yeah, It rained and rained and rained. And then it rained for 40 days, I think. There was enough rain for this to be a 2011 or 2015 bloom. The thing is, the farmers, and Laura may be talking about this, they couldn't get their plants out, so they didn't fertilize. So we have about 25–30% less phosphorus going in this year than we would normally. So we're modeling off the phosphorus load. If we had modeled off the discharge, it would be looking at a 10 forecast. Where we are right now is consistent with the forecast, which this also says that if we change the phosphorus concentration, the phosphorus going into the river, we will have an impact, and it will be immediate. That's a key message. So our ability to forecast tells us this, and this is, by the way, bioavailable dissolved reactive phosphorus. So getting that under control, we won't have to wait 10 years if we can start getting the phosphorus to stay on the fields. We don't have to wait 10 years to start seeing an answer. We have examples from 2012, 2016, 2018, and 2019 that the changes will happen. And that's a key part of how those forecasts will go. We're continuing our monitoring evaluation. We have now the 17 years of bloom analysis. For those who don't know, on our site, we now put up daily imagery for Lake Erie, which you would see on the lower right side, and it's the last couple of weeks of imagery. Unfortunately, it's been cloudy really rather cloudy for the last couple of weeks. It's hard to get a good scene, but so we keep track of that. There's also a whole lot of other data. Our Great Lakes Lab collects water data that includes toxins and so forth, which you can go to their site, the Glero site, and get water quality information from this year and from past years as well to go on. So what have we learned so far? At least, and I should emphasize so far because we're going to learn more, because the model is still wrong, because there's going to be something we don't know about that has come up or we don't include in the models. But first is, numerical scores for severity are a whole lot better than adjectives. It's a whole lot better to tell you it's a 7 than it was pretty bad. But it also helps, we can quantify this. We are looking at ways to adjust those scores. For example, this year, it really piled up on the Ohio shoreline, and we probably need to try to take those into account. Bioavailable phosphorus really matters. I didn't touch much on that, but that is the driving factor. So that's the dissolved phosphorus, and some of the particulate on the sediments is also available, but the dissolved is a big part of that. And Laura will probably be talking a lot about that later. It's spring load that matters. It's not winter. It's not annual. It's what comes in the spring, March to July is what really makes a difference. And just to note that, we had several years where we had major winter big flow years in the winter, and those were mild bloom years. So it's not that other period of time. It really, you have to get it in the spring. July appears to matter. We have years with high July loads. And previous years seem to have small, if any, impact that at this point, that there's not a driver coming in from an internal load. So we have a low spring load, we have small blooms. And I'll just note, our models, sometimes we can be close enough to being right, most of the time to be useful. And what do we need to work on? Toxicity, that's a huge question everyone has. The recreational part, we really need to figure out where and how much. So that's a huge question we're going to solve. And I should note in September, if you don't have scum, the toxin levels are generally pretty low when there's not a scum condition. If there's scum, I can't emphasize enough, keep you, your children, and your dogs out of the water, please, if there's scum, because if you see foam, the foam there will be toxin in the foam because that's decaying. The toxin doesn't break down as fast as the cells do break down. Timing, the last several blooms increased rapidly in late July. That's earlier than the ones in 8, 9, and 10. We don't understand that. We need to look more closely at that timing issue. It may be, so that's the sort of thing like the WLEB model may actually help us with, because the numerical model can go at timing. So Ed, you've got the project there. You'll have the answer by next week. Okay. But there's also other factors. It could be the spring bloom, the change from diatoms. You know, you have a diatom bloom in the spring, then the zooplankton come in and eat it all. That may be a change as well. We may have a double bloom sometimes, August and September. We don't really understand that as well. And then the distribution, huge thing. If the winds are out of the south, it's Ontario's problem. If it's out of the north, it's Ohio's problem. And that's a huge concern. If it's out of the west, it becomes Cleveland's problem as well. That's a huge issue. The wind forecasts are not good after 4 or 5 days. Weather Service models, they'll concede that. But maybe we might be able to get up at least some climatological thing to at least get an idea of the high pressure systems and how they set up to get there. And the last thing I'll add in just for context, 2013 was pretty bad. This was the Lake Erie commemorative. There was a lot of boats out there, and that star is about where it is, and people had a great time. There was no scum. So we produce imagery, nowcast forecasts for the summer. I can't emphasize enough. Look at those. Please tell people, don't cancel your plans for Lake Erie and when we issue a forecast, because you can use the lake. There are lots of places, even in the Western Basin, that are usable. And even we can tell you where the bloom is and where it isn't. We maybe can't tell you where it will be 3 weeks from now, but we can at least let you know what's going on. That's really critical. So thank you very much.
The soothing voice of Rick Stumpf. I could listen to that guy all day. Thank you, Rick, for that. We'll pull Rick up at the end of the session for some questions. And so next we're going to bring another one of our local rock stars. So we get to welcome Dr. Laura Johnson, who is the director for the National Center for Water Quality Research out of Heidelberg University. So she is going to give us some look at the controls on agricultural watershed phosphorus exports, so some lessons from 2019. So if you could join me in welcoming Dr. Laura Johnson.
Everyone. Oh, this is like right in my eyesight. I'm just going to put it down a little. There we go. Hi. So yeah, I want to talk a little bit about what's happened over the last summer. And just as a little side note, I did get a sneak peek of Rick's slides because we had to upload them onto like a shared folder. And so I cut out a lot of my intro because I knew what he was going to talk about already, which is awesome when you can plan it out like that. So as we've heard, I'm up here because our lab measures, Dave Baker started the whole thing, measuring water quality in rivers, especially the ones that go into Lake Erie. And so what I'm going to show you is basically what we found over the past, over the past summer. The one thing to point out though, and we get this usually once every couple of years when springtime rolls around, the question of, well, you guys, have you guys started monitoring for water quality yet? Have you started monitoring for the bloom season? And I like to kindly remind people that we've been monitoring pretty much continuously since 1974, and we never really stopped. And so we have a whole lot of consistency and stability in the type of monitoring we do. Actually, Jake is here, and he's one of our technicians who keeps these stations up and running, so he can tell you about how fun it is to monitor during like those polar vortexes in the winter. Okay, so with that, as a brief review of all of the things that Rick said in one slide, right? And the first thing is that we know that Maumee River blooms are very closely linked to spring phosphorus loads. This is a very simplistic way of showing sort of some of the modeling that he does, but basically you can see that March through July loading really is highly correlated to how big the bloom size is. I put a couple of pictures from his images of how big those blooms can be to see the scale differences. The other thing that we know about phosphorus from the Maumee River is a large portion of it is coming from Nonpoint sources. So this is an effort from Ohio EPA. They were able to take our data and pair it with the point source data that they get from the NPDES permits, as well as all kinds of other data. They're fairly clever with that sort of thing, and found that 88% of the phosphorus from the Maumee River is non-point source. The permitted discharges includes combined sewer overflows. There was a question about that earlier. The septic is basically, all septic, estimated, and I feel fairly confident in those numbers. Non-point sources, for those of you who don't know, is basically land runoff. So it's anything that's not accounted for by that, but It's essentially land runoff. And when you go into these watersheds and you look at the land area, it's usually something like this, right? So most of the land area is agriculture, and so that's where we kind of get to that. There's a whole lot of other ways we can get there. This is the very simplistic way for telling a story of science. The other thing about the Maumee River is when we look back over time, over this long period of record that we have been collecting data, the thing that we have seen that's changed, we measure all kinds of stuff. This is the only figure you ever see because this is a thing that changes relative to the blooms, right? So this is dissolved reactive phosphorus. This is an annual concentration. You see it goes back to 1974. And what you see is in the early 70s, concentrations were high. There is that very, very famous hand. You always have to include it if you're talking about this stuff. So that's when blooms were here. You see that these concentrations dropped down in the mid-90s when blooms disappeared. They rose again when blooms returned in the 2000s with 2003. Rick did a great job of describing how we get to some of the goals, and I'm going to show you some of those targets in a little bit. But the main idea is that we want to be reducing phosphorus by about 40% to reach some of the target goals we have. Something like 2012, right? We already have agreed that was a mild bloom with our language, right? But I wanted to point out on this figure is that when you take those loads and you calculate them into a concentration, that is about the same as that low point on our U-shaped curve here. And so by using all of these models and only recent data, we have some confidence in this DRP number because it goes back to what we've historically observed. All right, so we went over this. 2019 had a very wet spring. This is a figure. It shows that March through July, dissolved phosphorus load in sort of the orangish brownish color. We've got discharge, flow, water volume, whatever you want to say, just the water in the blue color. And what you see in 2019 is that blue bar. I'm expecting to be able to actually point with something, but I can't. So imagine I'm pointing at that blue bar and I'm going across and you're seeing that, look, it's like the same size as 2011, almost as similar as 2015, so a lot of flow. And you can see that 2019, the dissolved phosphorus loads were not nearly as high. We actually can calculate that out. I'll show you in a minute, but this is where we would have expected. That little hash bar is where we would have expected loads to be based off the amount of flow we had. We didn't have that. So 30% lower dissolved phosphorus loads this year than expected. And then this is the forecasting that Rick just talked about. So what that led to was a forecast of something near 2017. And you know where we're sitting right now. So I'm just going to leave it at that. I move on to how I calculated what this expected actually is. So this is showing a plot showing dissolved phosphorus load versus discharge or flow or water volume, whatever you want, for that March through July period. And what you see in the black dots is 2000 through 2018, right? And you can see that basically what I'm saying is loading is very tightly predicted by discharge, right? However much water we have, if it's going across the ground, it picks up phosphorus, gets into the river, comes out to the lake. The two little gray lines, so for those of you who have been tracking this figure over time as I have edited it, then you'll note that I switched to a linear regression instead of nonlinear, and I added 95% confidence intervals, which is what the two little gray lines are. And so what you see is 2019 is low. It's lower than what we would expect based off of this relationship. The other thing this relationship tells us is that over the past 18 years, we haven't had a lot of deviation. Right? We can predict loading based off of discharge, meaning there hasn't been a whole lot of difference in anything that we've been doing over these 18 years relative to dissolved phosphorus loading. I can pop in our favorite targets. We have the static target, which is essentially that 40% reduction based off 2008, where if we're below that number, we should have a mild bloom. You can see the moving target, which is the flow-weighted mean concentration target, which basically the point where those two cross, for those of you who love math, the point where those two cross is 2008. So what we're saying is once we get to really wet years, we would never expect to be at that target. What you see here, oh, I think things pop in. There we go. Oh, wait, we're going to wait on that one. You didn't see it. So what we see for this year is we didn't quite make those targets. We're still above them, but we're definitely lower than we would expect off of the natural range of variability here. Okay. So why would we have a lower than expected loading this year, given how much rain we've had. And I'm sure there's plenty of people in agriculture here who are wanting to shout out the answer to me, but basically this has been like one of the very, very worst years for agriculture. It rained all the way starting last fall. I had friends who were harvesting in January, people who were coming out and the very only warm, dry time in April trying to get their soybeans out, right? And so there was a lack of phosphorus fertilizer application. It started all the way last fall, went through all the way through the spring. If you pull together the data of prevent plant acres, you know, people saying, oh, I couldn't plant, I need some assistance here. 40% of the acres, from what I found in Ohio's counties that are in the Maumee River watershed, you know, basically submitted the paperwork for this prevent plant. I think Greg Labarge here is going to have a whole lot of more interesting data and statistics, so you'd be the one to talk to about that. Okay, so I just told you all of the data, and now we're going into my thoughts. Right? This is more conjecture and speculation. This is what I've been thinking about, I don't know, since about sometime in May, when we started to see these concentrations are a little lower than expected. So what can we learn from this year? The very easiest, simplest thing I think you can say is that fertilizer, what we've learned is that fertilizer applied within the water year, so water year goes all the way back to October, and includes that fall period. So fertilizer applied within the water year has a large influence on the spring and summer dissolved phosphorus load, right? That's pretty simple. The real thing is like, why? It doesn't make sense to me. It might make sense to you, but why? And do you think 30% is a lot or not a lot? I'm gonna try and say that it's a lot, and why. So normally when you think of something having an immediate effect on a load, you think of you applied this fertilizer and it runs off immediately. And that would imply something like an acute runoff. So here's an example of that. This is Honey Creek. The little red areas are where fertilizer application was occurring. This is in the fall of 2011, super wet fall. You know those big blue blobs right there? Each peak is a storm event. Flow went up, came down, and you can see that it was wet enough that by the time the fields dried out and fertilizer application was occurring, it just happened to be before a storm event, which was really unfortunate because it led to these really, really big peaks in phosphorus. So the black dots are dissolved phosphorus concentrations. Now, I know you look at this and you just say, yeah, but dissolved phosphorus changes with flow. Laura, that's what you tell me all of the time. But these concentrations are at a milligram per liter. A milligram per liter is the limit for like sewage effluent. So I'm saying the entire creek had the same concentration as sewage effluent following this period of time, right? So that's a lot of dissolved phosphorus. However, first of all, this is not really allowed anymore. We know this. It wasn't very common before anyway because it's a waste of money. Nobody really wants to do this. But when we look at our data, we don't see those peaks in the Maumee River that often. If we look over time, most of the time what we see are increases and decreases with flow, but they're fairly muted, as you can see here. I included in red the spring of 2017 because you can see that we were missing some of those really peaky storm events through this spring, which is what led to these lower loads. The other thing you should see here is I only went back to 2016. Goodness, we collect a lot of data, right? Like, that is a lot of data points. I know that they said Chesapeake Bay has a lot of monitoring, but we're gonna give them a run for their money here, right? Yeah. So, so what I have here is that this is a chronic loss driven by hydrology. When we think of a chronic loss, we think it's phosphorus that's in the soil, somehow interacting with the soil. It's not freshly applied phosphorus. Okay, well that's great, but that doesn't make any sense for this year. Why would then we have such a big decrease in 1 year if we're talking about phosphorus that's in the soil? And so when we think about hydrologically driven phosphorus losses, we usually think of this figure that Jay Martin already showed. So clearly this is a famous literature. Runoff dissolved phosphorus is linked to soil test phosphorus. We know this is a thing. But I would argue that this is probably not a real explanation for this year because typically we don't expect soil test phosphorus to change from 1 year to the next that rapidly. And here's some figures showing that. So this is not at all my data. This is Steve Coleman's data, Ohio State soil fertility, some of the experimental farms, and it shows all of these years with the soil test data, whether you applied no fertilizer, some fertilizer, or 2 times too much fertilizer. And so what you can see is that, yeah, there's changes from 1 year to the next, depending, changes with county, of course, but from 1 year to the next, like, it takes many years to go from the top of that maintenance range, which was that top dotted line when you don't apply fertilizer, down to the bottom of that maintenance range. So from 1 year, we shouldn't see that much change in soil test phosphorus. And this makes sense because how we manage for phosphorus is that we maintain a bank of phosphorus in the soil. So if something like this year happens, we don't have a yield hit because of phosphorus, right? We apply multiple years of phosphorus, like in one go, usually, because phosphorus just doesn't move that quickly. And this is our understanding of how phosphorus moves. Okay, so if soil test phosphorus didn't change that much, maybe it did, and we have a gross misunderstanding of that, which means we need to be talking to lots of people about that. What I'm gonna say is that maybe it's associated with where phosphorus is. If you've known our lab, we've done a lot of work looking at soil phosphorus stratification. So here's a little cartoon showing that. So what we think is, what we've measured across 1,500 fields in the Western Lake Erie Basin is that soil test phosphorus tends to accumulate in the top 1 inch of soil. So I put little averages beside the soil core there so you can see, yeah, we usually get like 60, on average, 60 ppm at the top, but only 26 at the bottom of that soil core, even though it's an average of 35 ppm, which is exactly where you're supposed to be. So there's a vast difference there. So we feel that phosphorus accumulation on the soil surface is a mechanism for this dissolved phosphorus loss and export. But it's not that simple. It's mediated. The only reason that's a problem is because we have macropore flow. And so I'm going to be stealing from Kevin's talk coming up soon that he has these lovely pictures showing us how big and intense these cracks and fissures can be in farm fields. It's also root channels and earthworm holes as well. Okay, and so that is what we think is facilitating where we have phosphorus on the surface, rainwater interacts with that more strongly, hits a macropore, gets into a tile drain and out into a ditch. Okay, if this is the real thing that's happening, then what we've learned this year is that, well, maybe these fresh applications are what are sustaining this phosphorus stratification. It's making this phosphorus be re-enriched on the surface, something you wouldn't measure in a whole 0 to 8 inch core because it's just that top little bit, right? And that maybe this year, because we didn't see as much of it, we had less loss. So I'm going to say that all over again with words. Okay, so basically what I just said is fertilizer applied within the year has a large influence on phosphorus loss, right, phosphorus loads, but these losses are chronic. They are driven by hydrology. They're not big and spiky due to fresh fertilizer applications, but we know we manage soils to bank phosphorus. I'm just reading it, I should just do that. And we don't really expect a big drop in soil test phosphorus. So to me, a 30% reduction in phosphorus with 1 year, just 1 year, is huge. I know it sounds like, well, there's 70% that's still coming out, but still, I would have never guessed. I would have thought 5 or 10 maybe, not 30%. Okay, we've documented this phosphorus stratification or accumulation on the top 1 to 2 inches of soil. So I would say maybe what we're seeing is, because we tend to surface apply phosphorus, in the fall especially, that it's making this sort of loosely sorbed phosphorus only on the surface, that 1 or 2 inch maybe, that is really contributing this 30%. And I am putting out a plea here. I email them every once in a while, but I'm going to put out a plea. I'm going to be working with Kevin, OSU Extension, I'm going to be bothering Chad Penn for sure, to better make sure that we take this information, understand it, so we can have a management response. I'm totally out of time, but luckily I only have 1 slide left. Because basically, I would say at the very least, I think we can point to 2 very easy things. And so this is the 4 R's, right? The 4 rights of fertilizer management, fertilizer application. This is a very prevalent thing in this region. And basically what I'm pointing to here is that this year is telling us maybe it's right rate. So we really need to think hard about whether our given year's application is really needed or not. Maybe we can start pushing the envelope on that and get closer to critical limits rather than being on the upper end of our maintenance range. The other thing is placement. You know, if it is the top 1 to 2 inches that are being re-enriched each year, and that's contributing a whole 30%, then the importance of subsurface injecting, getting below 2 inches in the soil, is way more than we may have ever really realized. Matches some of the watershed modeling data, however. And with that, I want to thank all of our supporters, because I have a whole bunch. Can't have this monitoring network based off of any one support. And Oh, but there's another 2019 bloom picture, so. Yeah.
Thank you, Laura. And again, we'll call her up at the end of this session to field questions from the audience. So now it's my pleasure to introduce Dr. Jennifer Reed. Dr. Reed is the director of the Water Center within University of Michigan's Graham Sustainability Institute. She also plays a very impactful role on a lot of advisory boards that are critical to the Great Lakes. And so one of those is IUS, so the Integrated Ocean Observing System. So please join me in welcoming Dr. Reed to talk about what's going on with our Detroit River.
Oh, perfect. Thank you, Chris. Really appreciate it. And Jay and others putting together such a great day today. I've learned a whole lot. And I really appreciate the opportunity to talk a little bit about the project we did on the Detroit River. Basically, there are a lot of questions around what's the role of the Detroit River watershed. And I want to start off by noting that I'm speaking on behalf of a very large team of modelers and other scientists. And I also want to thank the Herb Family Foundation for supporting this effort, a 3-year project that took on a lot of activities, which I'll tell you a little bit about as I go through here. And in particular, I want to thank the 30 individuals who joined our advisory group for this project, people from all levels of government on both sides of the border, from industry and environmental NGOs. We also had academic advisors, Jay and some other folks serving there as sort of technical advisors to the project. And all of that really helped shape the project, brought great questions, brought great data to us that we didn't otherwise have access to. Also had a real intimate knowledge of the watershed that really informed our work and ground truthed our results and helped us really understand what we were seeing. So I don't need to tell anyone here about the significance of phosphorus inputs to Lake Erie, but the demystifying part of my title was have been a lot of questions about the Detroit River watershed's contributions. And so this effort was really thinking about what's coming into Lake Erie from the Detroit River, how much from what sources, and can we begin thinking about how we can manage those sources. So when we started out in 2016, we had a good handle on some things and there were some big questions. We had a good handle, I would say, on what was coming into Lake Erie from the Detroit River as far as total phosphorus and dissolved reactive phosphorus. But some of the details of attribution of source type and land use, how much was point source, how much was non-point, how much was coming from the Canadian side, how much from the US side. We didn't really have a good understanding of that. Also, some of the processes occurring in the watershed. Right in the middle of the watershed, we have Lake St. Clair, which is large, shallow, productive lake that is potentially having an impact. We knew there was a discrepancy in what we were measuring in the St. Clair River. In other words, we were measuring a lot more phosphorus at the bottom of the river as it emptied into Lake St. Clair than what you would get by adding up all the sources. So there was kind of like an unknown, unmeasured load in there somewhere. We didn't know what it was and didn't necessarily then know what that might mean to thinking about load reductions. So I'm going to share with you sort of some of the things we found to address that start to address at least some of those answers and will help us think as we move forward in adaptive management under the Water Quality Agreement about what we need to do. So first, a little bit of quick background contextually, because we've been sitting in the Maumee all day. The Detroit River watershed is a complicated watershed. It's about 19,000 square kilometers. I think the Maumee is somewhere on the order of 17,000 square kilometers, so comparable in size, but different land use types. About 49% cropland in the Detroit River watershed, whereas we're about 72% here in the Maumee. In the Detroit River, 21% urban, 13% forest, and 7 each of grassland and other water bodies. Also want to point out some important sort of Ontario-Michigan differences. Ontario side has roughly 60% of the watershed, but 80% of the agricultural land. So it's like larger, but more agricultural. The Michigan side has about 40% of the watershed, but about 83% of the urban land. So we've got those differences on both sides of the border to think about as well. So it is a pretty complicated watershed with a variety of land uses, got these inputs upstream from Lake Huron, something's going on maybe there. Right in the middle, we've got Lake St. Clair playing this role, which you don't really know really about its role in nutrient processing when we start. So the questions, the input, the guidance that the advisory group provided to us really shaped the project from the beginning and helped us basically take on an approach that was modeling 4 different types of models to help us start to estimate loads and assess opportunities for load reduction. So one thing we did was a mass balance, basically understanding, getting a handle on all the phosphorus inputs and outputs just to know what was going on. We also developed a watershed model simulating flow and dynamics of water, nutrients, and sediments, a soil and water assessment tool model, a SWAT model, which we've talked a bit about today as well. To look at Lake St. Clair, we developed a sort of a coupled hydrodynamics, so water flow at 3 dimensions through the column, with an ecological model to really start to understand what was happening as far as nutrient processing in Lake St. Clair. And finally, for Detroit, we developed a very high resolution sort of simulation of the sewer system to understand what was going on there. And when I say we, I actually don't mean me, not my role. We had a lot of very talented modelers, professors and postdocs who worked on this. And the role that myself and Lynn Baccaro, who's with me today, played was really to work with that advisory group and understand sort of what the big questions were and make sure that the researchers were addressing those questions. So first, as far as the mass balance went, basically combed the world, or at least this world, known world, for the data that we could use to do the mass balance. US and Canadian water quality monitoring programs and point sources, all those dots on the map, and estimated loads from tribs to the St. Clair River, Lake St. Clair, and the Detroit River. So what did we find? Total phosphorus contributions to the system. Lake Huron is contributing 58%, close to 60% of the system's total phosphorus load. Point sources, so combining sort of, they're broken into US and Canadian here, but if you combine them, that's about 18% in the rest of the watershed. And non-point sources, again, they're broken into US and Canadian here, but they total about 24%. So 18 and 24% point and non-point, if you compare that to the Maumee, where I think we just heard about 88% are non-point, you see there's a real difference in the sort of dynamics in this watershed. Our calculations show that the Detroit River phosphorus loads have declined about 37% since 1998, with almost 20% of that occurring since 2008, which, as Laura mentioned, is that baseline year for our reduction targets. Of that reduction, one of the biggest was the Detroit Water Resources Recovery Facility. It's reduced its phosphorus input by 51% since 2008. So it's the largest point source in the watershed. It's also, I think, the largest treatment plant, definitely in the US, but I think we were talking about worldwide. So it's a big contributor, but it's already reduced its phosphorus inputs by 50%. But I'm sure you're curious about sort of the rest of the urban story, so let's talk a moment about total phosphorus from the urban areas. So as I mentioned, 20% of the land roughly is urban. Thinking about Detroit, Michigan, and on the Ontario side, it's London, Ontario, and Windsor, Ontario primarily. Together, these 3 areas contribute about 24% of the phosphorus that's the Detroit River delivers to Lake Erie. From that, we found about 80% of those urban sources are point sources, primarily wastewater treatment plants, but also some industrial facilities, and the remaining 20% is carved up between stormwater runoff as well as treated and untreated CSOs, sort of that stormwater situation. So the Lake Huron story, this was another, I think, important contribution to this effort. So we found the phosphorus from Lake Huron makes up over half of the load to the Detroit River. I think it's almost twice what we thought it was when we started. So we're trying to figure out why, and we started looking at satellite imagery, and looking at that suggests that storms are causing resuspension of nearshore sediments in Lake Huron, perhaps some shoreline erosion, It's getting transported into the St. Clair River kind of episodically with storms, and it's not necessarily matching the monitoring programs. So in other words, gluts of nutrients are pretty much getting past the monitoring. And importantly, this seems to be correlated to an increase over time with a decrease in ice cover. So we've seen sort of more ice-free days, less ice cover, and increase in storms as well. And so that means that we're going to have more sediment resuspend more easily. The Lake St. Clair question. So what we discovered in our analysis, sort of two lines of evidence, the mass balance assessment as well as the model that I mentioned, this hydrodynamic ecological model, seems to show that on average over time, the Lake St. Clair is a total phosphorus sink of about 20%. Dissolved reactive phosphorus is a more complicated story, and you may have questions about that, and we'll talk about that after, because it's a bit more complicated. But it seems like zebra mussels and some sediment settling out in the lake and the deeper portions of the lake are reasons why we're seeing it be a bit of a sink, which is maybe good news for us. So with the time that I have remaining, I just want to talk a little bit about some of the work that we did, sort of thinking about what we can do about managing these sources of phosphorus. I'm going to focus on Nonpoint because I've already talked. The point sources are fewer in number, and there's been a lot of work done on those. And talk about what's being done here in Nonpoint, and particularly agricultural Nonpoint. So deploying the soil and water assessment tool to the full watershed to allow us to explore sort of management options. This was a pretty high resolution SWAP model. It was basically the basic modeling units were farm field size units that then allowed us to be pretty specific with the kinds of nutrient management practices we could apply and apply them on specific fields. We selected 7 practices to test. A number of those have already been mentioned. Jay mentioned them already this morning as far as them being the target for the work that they're doing, and Matt did a great job explaining what they are. What we did was basically applied them sequentially, so one at a time, to really test the response of the system on 100% of the available agricultural land. So really just to get a sense, not of what the management option might be, but just to see how the system responded and maybe which of the nutrient management practices might be more effective than others. And one thing we noted that even at 100% application, none of the practices applied by themselves achieved the 40% reduction load we would be looking for in any of the subwatersheds. So, and that means we're going to have to be thinking about how do we combine these nutrient management options. We call it bundling, putting multiple practices together and seeing how that works. So what we found that the biggest reductions in phosphorus loads were achieved by combining 3 of 4 potential practices, at least that we tested. Planting cover crops, we've heard about that. Filter and buffer strips, we've talked about those. Creating or restoring wetlands, those have been talked about a lot today as well, and the value of that, and it's been recognized in the H2 Ohio work. And the final one is fertilizer placement, so incorporating into the soil, as Laura was just talking about. And these combinations resulted in pretty good results. You see them sort of or watershed by watershed. Many of those are over the 40% target. I would say that's because, again, just to see how the system would respond, we apply them to 100% available, just to see what it would look like. But then what we did was we said, okay, can we focus on perhaps those parts of the watershed that are most susceptible to nutrient losses, a much smaller area of the watershed, and see if we can get anywhere close to that. And we found if we applied these bundles to roughly 55% of the sort of worst, that's a bad adjective to use, the most phosphorus productive parts of the watershed, we were getting results that were very similar to applying it across 100%. So this idea of focusing is, I think, one takeaway that has been talked about in other venues and with other projects, and I think we need to talk about really seriously. And I think the other thing that excited us was this idea that bundling from several different options allows the landowner to put on the land the practices that make the most sense for him or her in their particular situation and to match them to the particular needs of their farm. So, quick wrap up here. Over 50% of the Detroit River total phosphorus comes from Lake Huron. We're going to have to grapple with that. On average, Lake St. Clair is retaining 20% of the total phosphorus that enters the lake, so it's having an impact. Our model simulations, again, all models are wrong and some of them are useful. Hopefully this is useful, but it's suggesting that bundles of agricultural practices could be useful in reaching targets, but applying single practices alone is not. Focusing agricultural practices on the highest loss parts of the watershed is nearly effective as putting practices on at 100%. And reaching our 40% reduction for the Detroit River is going to require reducing an additional 23% from all sources. So we've had a decline since 2008. But if we look at what we need to do to get to that 40%, that's 23%. But if we say, okay, Lake Huron might be a challenge, what do we have to do in the rest of the watershed sources? That's 51%. If we say that the water resources recovery facility has done such an awesome job that maybe it's off the table for now, or maybe they've sort of maxed their current technology, that's 72%. So I think what the takeaway message is here, we need to understand what's going on in Lake Huron. I would put a plug in for that idea of a pilot watershed and to sort of try these tools that we've talked about today, and think about sort of what we might be able to do. So again, thanks to the Herb Family Foundation and to the team, and in particular the advisory group who helped make this possible. Thank you.
All right, great. We'll bring up the last speaker for this session. It's Dr. Aaron Wilson. Comes to us from the Bird Polar Climate Center. He also has a joint appointment with OSU's Land Grant Extension, and also plays a heavy role in Ohio's climate office in Ohio. And so I'll pass it over to Dr. Wilson.
Thank you, Chris, and thank Chris and Jay and the organizers for inviting me to speak today. We've sort of glanced a little bit of climate, a little bit of weather here. We keep hearing it's been spring. I want to talk about how wet have we been and kind of dive into that a little bit. As Chris mentioned, I wear really three hats, one with the Bird Center at OSU and also with Extension. And with the last 2.5 years with Extension has afforded me this great opportunity to engage the agricultural community throughout Ohio and really make the connections between water quality, climate change, best management practices and farm management there, farm and field management throughout the state. So it's been a spectacular opportunity. Kind of my punch statement, even with, in all of these engagements is that climate change directly impacts our economic and environmental sustainability. I think most in this room would agree with that. But there's a lot of faces to climate change. And it's very personal. And if you go to the East Coast, you might be thinking sea level rise. And if you go to the West Coast, you might be thinking wildfires and heat and drought. But the face of climate change in Ohio is our water and our changing water and hydrologic cycle. And so it's very, very important to make that connection and to make that point about the personal face of changing climate in Ohio. So you've probably seen images like this, figures, or you've read the National Climate Assessment Report that's looking at changes in temperature since the beginning part of the 20th century here. And of course, a large portion of the U.S. has warmed over that time, but it not warmed evenly. Our winters are warming about twice as fast as our summertime. During the summer, the interesting thing is you see a lot more blue colors there across much of the Midwest and the Southeast, where we get actually cooler summer temperatures, largely driven by cooler daytime highs, but warmer overnight lows. So those are our key distinct differences in terms of the seasonal changes. With precip, it was mentioned earlier, the very first talk this morning about seasonal changes. Now, the U.S. has increased precip about 4% since the first part of the 20th century. Here in Ohio, it's closer to 5 to 15%. What does that mean? That means 3 to 4 more inches of rain per year than what we saw in the early part of the 20th century. That's a lot of water. It's a lot more water, and it's not seasonally distributed, or evenly amongst all the seasons. Fall is really the season where the trends have been the strongest, really 10 to 15% across the state. But if you look at this, and it's kind of hard to see Ohio on this, but there are some regional changes within the state that are also a little bit different. So up here in Northwest Ohio, summer and even some of the spring precip, as I'm going to show in a minute, and fall are the largest changes that we're seeing. And it was mentioned earlier again, the increased intensity of the events, and I'm going to show you some stuff on that. So we have some good partners also working with the Great Lakes Integrated Sciences and Assessment crew. And if you look at a little bit of just the Great Lakes seasonal changes here, and I don't know why I flipped these, spring is on the left, winter is on the right. You can see the changes have been quite substantial, and the Great Lakes is one of the fastest warming areas in the entire country, all right? So very warm conditions, and if you look at, our 3 regions here, Northwest Ohio, Northeast Indiana, and Southeast Lower Michigan, temperatures have warmed in that 1.5 to 2.5 degrees since 1950, right? An average temperature warmth increase in the winter and the springtime. Then if you look at the precip, again, just driving that home and getting a little bit more local here, you look at the fall precipitation trends in the Maumee River Basin, in the western Great Lake Erie Basin in general. Again, we're talking anywhere from 7 to 20% increase in rainfall and some of the highest amounts across the country here. So we're warming, we're getting wetter, that's clear, okay? So as I mentioned, we sort of glanced on some of this. I want to get a little bit more specific because I don't want us to forget the last couple of years. I don't think a lot of us can or ever will, but I want us to remember this from a weather perspective. So if you look at the 2018 for the state of Ohio, the left-handed graph shows the distribution of total precipitation. And up here, it was between 30 and 40 inches of rainfall, okay? Many places getting close to 40. Along the Ohio River there, that's 60 to 80 inches of rainfall in 1 year. We had stations in Ohio eclipse 75 inches of rain in one season. And of course, that was well above average, 3rd wettest on record for 2018, and our records in Ohio go back to about 1895, okay? So since 1895, 2018 was the 3rd wettest. Now, if you look at the top 10 wettest years, 5 of them have all occurred since 2003. Okay, that's going back to 1895. 5 of the top 10 wettest years have occurred since 1895 here. What does that mean? It means that the climate of today is not the same as it was 30 or 40 years ago, right? It is changed. And so it does behoove us to think about these changes when we're thinking about our management strategies. Top 7 since 1990. Now, one of the other things we often talk about is extreme month-to-month variability. And I kind of want to toggle your brain a little bit. We're going to go all the way back to spring of 2018. We had the 9th coldest April on record, followed by the warmest May on record. So you take April plus May, you divide by 2, you get an average spring. Climatologically speaking, that's how it works, right? But it's not normal. We got into last summer. What did you have up here in Northwest Ohio? You had drought, right? You had drought. So how can it be so dry when it's been so wet? Then we got into our fall, and Laura nicely put about what we're seeing this year, really beginning in earnest last fall. 3rd wettest on record. September was the 2nd wettest, driven strongly by tropical activity, but also, again, this extreme month-to-month variability. You get into the first part of October, it's dry and it's warm. November switched. Crops are in the field until the ground can freeze, right? So very, very nicely put earlier. Now we were going into winter with an El Nino on deck. What does that mean for the Ohio Valley? Drier than average 90% of the time. What happened? 11th wettest winter on record for Ohio, okay? 11th wettest Ohio on record here. West Central and Northwest Ohio really targeted this spring. If you look at Northwest Ohio, for instance, it was the third wettest on record, again, back to 1895. Many locations, 15, 20, 25 inches of rain in 3 months, well over half the annual total that we usually expect. Not only that, and Laura showed about the peaks, and I've heard this routinely throughout the spring, we haven't seen a lot this year in terms of the extreme events, but we had 26 days of at least a trace of rainfall in May, okay? 7 days suitable for field work. So it was very, very challenging from a water perspective for farmers, and they want to understand also how to manage this as well. So as Laura and Rick both said, wet spring, this is what it looked like for the spring. And of course, meteorologically, I'm defining spring a little bit different here, March through May. I can deal with June. When we start calling July spring, I start to shake a little bit. But certainly our spring 2019 in the Western Basin, very, very wet, right? Some 175 to 200% of normal. It's a lot of rainfall, a lot of water. Laura showed at earlier this year about the cumulative amount of rainfall water coming down at Waterville there at the Maumee River Waterville site, right? So it got me thinking this spring about looking at some of the spring changes. And again, defined here is March. I did this March through June. It's okay. And just targeting these 3 basins in the area. And you can see since 1970, this big increase. It's about 15 to 20% increase in our spring rainfall for all 3 of these basins. And 2019 was really above that trend, really pushing that upward for all 3 of these regions here, okay? So there's a lot of rainfall. Our spring trends are changing. We're getting these wet springs more often and really more intense. So it's an understatement to say it's been a wet year, right? These are some astounding statistics. If you look at the June 2018 through May 2019, all of the dark green states here you see are the wettest 12-month June to May on record. That's astounding in itself, right? And then what did we do? Well, we got through our 5th wettest June on record, and now we had our wettest July through June period on record. So back-to-back 12-month consecutive rainfall years. Fairly drier, and it was a little bit drier in July, but despite that, we still had our wettest August through July 12-month period on record. Back to back to back, right? Quite incredible stuff that we've seen over the last 8 to 10 months here. To kind of drive home a little bit more about how differently it is, I mean, if you look at the annual departure from average for Ohio rainfall, that's the graph on the left, going back to 1895. You can see some years are up, some years are down, but certainly that black trend, which is kind of the running 10-year mean, the last decade to 2 decades have been the wettest on record for Ohio, right? We're in a wet regime. And not only that, but the intensity of the rainfall events. So these are our observed number of extreme precipitation events where we're seeing more than 2 inches at a time. Since the mid-1990s, almost a stepwise change, right? So if we're using climate data from the 60s, 70s, or 80s to drive our decisions, we're not up with the times, right? We're not up with what's happening today. There are 3 other peaks in this record, 13, 37, and 59, and what were those in Ohio? All major flood years. So the point of this graph is flooding means more than just precip. It's what we do with the water, how we store the water, how we develop, how does it move across the surface. But it's saying to me that we're under a persistent flood risk. So it makes our job as stewards of the water and water quality that much more difficult and something that we need to consider. So to look a little bit more closely at the intensity of the rainfall events, we can take about 20 stations across northern Ohio since 1950 and look at 5-year total number of events based on a certain threshold, right? So here we got 3-inch events, a fairly flat trend, but as soon as I start adding the heavier events here, greater than 2 inches, you start seeing the strong trends in those 2-inch rainfall events or more. And if you start getting up anything over an inch, we're talking 40 to 45 events of this caliber every 5 years, right? Heavier rainfall across this part of the country. Now, Rick stole my thunder a little bit because I wanted to look at this. I didn't listen to him, though. I just put significant and mild. I used those adjectives instead of the number. But yeah, 2011 spring, as defined here as March through May, very wet, right? And then 2012, this is spatially what it looks like. You can see the difference. And part of the reason, obviously there are a lot of reasons, part of the reason between significant and mild blooms Get into 2015, actually March through May was not that spectacular. It was a little bit below average. But again, it was that June and that July rainfall that was really doing it. And then 2018, again, fairly mild, but it was a fairly wet season. Okay, so some things that we still have to learn and kind of piece together. So where do we go from here? Well, again, we're expecting warmer and wetter. If you look at the best models, those things that are always wrong, but they are useful, they're trending warmer. 4 to 5 degrees warmer on average in this part of the world, okay? Most of that wintertime, most of that nighttime, but again, 4 to 5 degrees on average warmer by just the mid-21st century. We're not talking end of century, mid-21st century, with another 3 to 5 inches of rainfall per year. So 40 inches of rainfall in this area, which is pretty abnormal, is now kind of the new normal as we expected. We talk about temperature changes. One of the things that we know is that water vapor, the excess water vapor in the atmosphere, is what's driving some of these changes in summertime. Cooler daytime highs, but more warmer overnight lows. It's also driving the precipitation trends as fronts can wring that moisture out. It may not hit 100, but we're still going to double our 90-degree days. We're going to decrease our overnight lows that drop below 32 by 20 to 30 nights. Now, some people might like that, but if you need ice on the lake, or you need to harvest crops when the ground's frozen because it's too wet in the fall, because it's getting wetter in the fall, you can see how these problems start to build up. And if you ask a farmer what's the worst combination he can have or she can have, it's a wet spring, hot, dry summer, wet fall. And that's exactly what our trends are moving toward, where we've got a seasonal redistribution of rainfall. We expect that to happen in the future with wetter winter, spring, and then again in the fall, with water shortages during the summer. So how are we storing water? How are we maintaining our water systems in those seasons? So kind of just to put it all into summary, obviously wetter, mostly in the wintertime and springtime and overnight, warmer and then wetter during what we traditionally have referred to as the ag off-season. And there was a question before lunch about thinking about climate change and some of the implementations of the best management practices. You're looking, I see you behind the thing there, you're looking for what we call no regrets or win-win. And that's why this whole idea and concept about improving soil health and improving water quality is also building resilience to these heavy rainfall events. Cover crops, right? Keeping water on the field, storing it on. So this is a perfect marriage between the climate change science that we're seeing and then implementing these best management practices. I think that's very important. Obviously, it's been a very challenging period of late, but as I've gone around the state and talked to folks, I have a question mark here. If we think of 2019 as the new normal, okay, this is not a one-off. This is just a glimpse, really, of what we're going to see more often in the future. And one can argue that we've already had and dealt with these extreme rainfall events now for almost 2 decades. So obviously it's part of the question here and part of the solutions moving forward we really need to think about. Last slide. How many know we have a state climate office? Hey, it's more than I expected. We have a state climate office, okay? We want to help all of our stakeholders throughout the state, from ag, water, transportation, health. We have a lot of partners at the regional and federal levels as well. We have a website, climate.osu.edu. Please check it out. We can social media. We're working with farmers on nutrient applications as well. So any questions about weather and climate that you have, please direct them our way. We really appreciate it. Thank you.
So I'm going to call our 4 speakers up, so Rick and Jennifer and Laura, to field some questions. We're going to take as many as we can, but we want to try to stay as close as we can to target. So again, please, the microphone's in the middle. Step up for your questions while we're getting our speakers up here. That's great. So who, when they hear a climatologist say El Nino, thinks of Saturday Night Live and Chris Farley? Let's be honest. All right, good. It wasn't just me. All right, so please step up to the microphone. I'm actually just going to help facilitate discussion. So it looks like we've got one individual already. Please ask your question. Joe, try it now. You might have it turned on. Maybe come up to the front one.
Test.
Right.
Thanks, Chris. This question is for Aaron Wilson. There's a story in the Wall Street Journal today about carbon sequestration in soil. And there's co-benefits to that for soil health, for water retention. There's been some progress with allocating some forest credits in Michigan. And I'm just wondering from what crosses your desk, or if there are any projects in Ohio that could sequester carbon, provide some income to farmers through carbon credits, either in the California market or elsewhere.
Yeah, I don't know of any specific projects offhand. I do know that, I didn't mention the carbon sequestration, but that's obviously one of those things that can really help. And it gets to the mitigation side. If you know or have heard of Dr. Rattan Lal, he talks a lot about the potential of the soils across the world. And we're talking 10% of our current emissions being able to be sequestered in the soil if done properly with all of the, vast suite of different carbon sequestration techniques. So it's certainly an opportunity. Anything that we can do to draw down the CO2 means that while we're not switching it off, what we're doing is we're lessening the potential for even worse outcomes than what we're facing now. So yeah, that's definitely a potential and something that's on the radar, but I don't know of any specific projects. Yeah.
Go ahead, Will, please.
Thank you. Will Hemker, University of Akron Research Foundation. Questions for Dr. Johnson. On your data with this year's water discharge or loads, you're showing 30% reductions of dissolved reactive phosphorus. What did you find in your data for sediment load this year?
It was perfectly where we would expect. So it was same thing with total particulate phosphorus as well. So higher loads than like the past few years, but exactly where we would expect given the amount of flow we had. So erosion was still about the same, I would say. The other thing that was a bit lower, but I don't have a percent because I haven't calculated it all out. We get our data really fast, but it's a lot of it. Anyway, there's nitrate. We didn't get a big nitrate peak that we usually get in the middle of the summer, attributing to a lack of nitrogen side dressing at a time when we were actually getting rain events. So
let me see if I understand. You say your sediment loads were as expected with that volume of
so
water.
high, yeah.
Okay, still high. Cool. That's
Yep.
good. I have another question for Dr. Reed. On your potential options for non-point source pollution, the one you got the biggest bang when you started modeling it were 3 biological tools, basically. Buffers, cover crops, and wetlands. So what do you think is happening? Do you think we're managing the surface water better with those types of tools?
Yeah, I mean, I think that's, there we go. Yeah, I mean, I think that's clearly what's happening. So it's keeping the water where it needs to be rather than moving quickly across the surface. I think that those work well together. They're probably I'm just thinking about, they're sequestering carbon at the same time too, which isn't anything we measured, but yeah.
Very good, thank you.
Thank you.
Please, we have another question. Come on up.
Barry Fanning with the Andersons. Dr. Wilson, you, one of your slides was a long-term plot of temperature, and we've been clearly high for the last 15, 20 years. During the Dust Bowl area, though, we were clearly very, very dry, and that went on for decades. That looked, to me, from your plot, looked like it was 40 years long of below average rainfall and whatnot. So could you address that a little bit, please?
Yeah, I mean, in terms of the, so the plot that you're referring to in terms of the long-term annual mean. So that's compared, obviously, when you deal with differences from average, this is compared to the 1981 to 2010 average. There were places west of here in the Midwest and Great Plains that were dry for extended period of time. We had particular years like 34, 37 that were we had some wetter periods in there as well, and also the very kind of our summertime maximum temperatures are during that period as well. So as far as the precipitation goes, and I'm trying to just remember it off the top of my head instead of looking. I think one of the things to remember is that if you know, if you're having a drought every other year, or certainly during the 30s, we had these more persistent dry periods than we have today. It doesn't mean that every year is going to be dry. You can still have wet years within that period, right? So that's kind of what the difference between, if I'm answering your question correctly. So maybe you can expand a little bit, but.
So essentially the difference there, and I do not know, I know that the Dust Bowl happened.
Sure.
Right. I don't know how consistent it was. Are you saying that now we're just expecting to be very consistently wetter and hotter?
No,
compared to not as much variation, or have we just shifted averages essentially, or are we seeing more variation now than what you were?
We've shifted average and more variation. So we've shifted both the variability and the average. But I would also say the shift has become a lot more within a 1 year span or 2 year span versus, you know, 1 or 2 years of dry weather and then a wet year and then 2 or 3 years of dry weather. That's typically what we saw in the 30s. We also saw it in the 50s when we had a little bit more drought conditions. Now what we see is if we do have a drought, which we just declared drought for parts of Ohio this morning, in places like Clark County, Miami County, Madison County, that they tend to be short-lived, and they're kind of isolated to that July, August, September period before the rains come in September. So there's a little bit shift in the pattern and the variability. Yep.
Sandy, please.
Sandy Ben, Lake Erie Waterkeeper, and this is for Laura. We kind of had a conversation in the back here, and my question was, this year you said there was a 30% reduction in the amount of dissolved phosphorus, I believe, and my comment was, if this was 30% and we need 40%, this was a really awful year for where we're at, and that's not going to cut it. Can you kind of share your response and, you know, if we need more than 40% or how it affects this area in particular in the Toledo area?
Sure, absolutely. So, so first thing I wanted to clarify was that, you know, I say it's 30% lower than what we would have expected. So what we were expecting, as Rick had mentioned, was one of the largest loading years in our recent record, right? Or probably on record in total because the flows were so high, and we didn't see that. So, you know, we still got a very large load, and so we still expected a big bloom. 2017 is what we were been comparing it to, and that was a big bloom. It wasn't like a 2012 bloom. And so when it comes to the targets, what we have to remember is that the way the targets were set up, they were surrounded around 2008. And in 2008, we looked at the flow for that year, and it was the wettest 9 out of 10 years based off of the period of record that we had available. And so this year well exceeded 2008. And so based off of our targets, we would have never really expected to reach that. It'll be like a 2012 bloom with the concentration targets that we have because it was just so wet. I mean, there's so much water going across the ground. So if, as we move forward in time, if we're able to sustain a reduction like what we've had this year moving forward, or even reach that 40% target, but as we move into future climate scenarios, we are wetter more often, I totally agree with Sandy that we might have to reassess what that target reduction actually has to be. And it could be that what we have set is not going to be sufficient, and that probably the exact load number won't change that much. Maybe it will if it gets warmer. We don't really know, but that's a part of the adaptive management process. And so what I didn't tell Sandy, but now I have the option to talk about, is that moving forward with this Annex 4 effort, we have an adaptive management framework that is being developed as a way to make it so that we get to a point where we can reassess not only if we're reaching targets from the watershed, but if those targets are doing what we want them to do in the lake. Right, and that's the important part of that. It's not just one-sided, and that we don't have a scenario moving forward where we've been having high dissolved phosphorus for 15 years before we start to make some real efforts and changes. So, yeah. Yeah, right.
And there may be a perception that a 10% decrease in phosphorus means a 10% decrease in size of the bloom. That's not how it works. It's a bigger decrease. So that extra next 10% would be, we're gaining more reduction for each one. It's not a one-to-one decrease in the bloom.
We have time for one more, so Steve, please.
Yeah, this is for Laura, and it's a question and a comment. And I think Laura makes some good points. I would ask, though, as we look at what's going on the landscape, we have several million acres now that are managed under certified 4R crop consultants that weren't. NRCS has some new SEEP data we'll release soon, which will show a tremendous increase in subsurface placement, precision nutrient management. I think Robyn Wilson is seeing some of those things. I think we have some data that shows a tremendous increase in cover crops. Is it time to ask whether actually some of that difference that Laura is seeing is maybe due to the practices that we are putting out there on the landscape and the changes that the agriculture producers are doing? And I don't know how we would tease out how much is it due to what you're proposing and how much is it doing to the other. But I do think we need to acknowledge that producers have made a big change, and maybe that's part of what we saw this year. Maybe we have some hallelujah choruses needed.
So my comment would be, wouldn't that be great? I would really love for that to be the case. And I can't say whether it necessarily is or not, and which is why I'm going to reach out to all of the people that I know to tease these things out. We do know that circumstances were very different and exceptional this year, and it was the first time where I think that there's something, except for when we go back to the 80s when everyone switched to conservation, rotational tillage sort of ideas, right? That we've seen, something that was on an entire watershed scale of change, right? I would say, do we think that the things that have happened so fast that it would be from one year to the next, or would it be a slow change? That would be the real question there. But with that, and with the comments I made, like, well, we hadn't seen a whole lot of change over time, but, up until this year, I think that I want to emphasize, I entirely agree that there has been a lot of efforts on the ground. There's a lot of momentum. I'm very excited about all of the things that are happening. I would say if this year points out that subsurface injection really is the very most important, and we're going to go with that, then we maybe need to reconsider some incentives to get more of that equipment on the ground, and not just a nutrient management plan, but how do we get more of those toolbars out there for them to use, and not just try, but enough for like a lot of people to use, maybe in a pilot watershed that we monitor.
I didn't mean to creep over the edge of you there, Laura. So keeping us on time, and so thanks for that comment, question. That's great. I do think it leads credence to that we can't manage what we don't monitor. So coming back to, what we heard from Rich in the beginning, I mean, we need to be able to monitor these things, and so that's a great thing. I did want to mention two things. I definitely saw Jane Ruvalo walk in, so we have representation from Marcy Captor's office, and again, if you didn't hear earlier, Ann Longsworth-Orr is here for Senator Brown. So those are great things to recognize. And so I want to give you enough break because Kevin King's in the next session. And if you heard last year, he never stays within his time limit bounds. So we're in trouble here coming up. So please take a little bit of time to grab some drinks in the back. And then Dr. Kristen Fussell will call you together here fairly soon.
Hello again. We're going to get started here in the next minute or so. Please find your seats. Okay, everyone, in the interest of time, we are going to get started with our second afternoon session. So thanks everyone for sticking around this afternoon for the second session. I'm Dr. Kristen Fussell. I'm the Assistant Director of Administration and Research for Ohio Sea Grant and Stone Laboratory. This session I will be moderating is Best Management Practices, Results, Adoption, and Dollars. And as Chris mentioned, our plenary speaker for this session is Dr. Kevin King. And I do have to joke, he did kind of go over his time allotment last time. So many during this day-long session have talked about adaptive management. And the planning team really took that into consideration this year, and we have given him a full 30-minute time slot. So Kevin King, much of his data has been shown throughout the day, but he will now talk about results from the edge of field. He's with the U.S. Department of Agriculture, Agricultural Research Service. So, thanks.
Thanks, Kristen. Thank you all for the opportunity to share some of our research work that's been going on the edge of field now since 2011. See, you know, I don't know though. I'm glad you're here because if you know, as a scientist, I look at the correlations. So 4 years ago when we started this, I had the keynote in the morning. The next year I had the before lunch. The year after, right after lunch, and this year I'm at the end. Next year, not going to be here. So pretty sure that's the way it works. So. Anyway, no, thank you again for again allowing me to share with you a little bit about our research. So for today, I'm going to just, I don't have as much data as I know you're hoping probably to see, but I go over for those that are maybe not familiar or new to the conference a little bit about the network review that we have, the edge of field network that's in place. Then we'll go over some preliminary findings, and primarily we're going to look at 3 topics with the preliminary findings, that being cover crops, looking at tillage and pea loss. And I want to be very careful with there. We're not advocating tillage, but we have data on the impacts of tillage and phosphorus loss. And then also we've got some data on this idea of subsurface placement, or getting the nutrients below the ground or in contact with soil. And then I want to talk a little bit about what's coming soon, those things that we just haven't had enough time to analyze, but the data, we have the data in hand, and hopefully in the next 3 to 4 or 5 months, we'll be able to have some products on some of those topics. And then I want to talk about some collaborations, because, you know, I forgot who it was that said, you know, if you don't care who gets the credit or whatever, you can get a whole lot accomplished. And so we collaborate a lot. We share a lot of the data that we get with different groups to do different components that extend what we can do ourselves. So I want to talk a little bit about those collaborations as well. So this is not a new figure. Many of you have seen this. This is the network. As you can see, we've got 20 paired sites or 40 fields located in the northwest quadrant of Ohio. 14, I think, of those pairs are in the western Lake Erie Basin. And you can see the heavily tile drained area where those exist. We've got 100 plus automated samplers. And if you do the math, 80 and 40 times 2, both the surface and subsurface, that only equals 80. Well, we've got a little bit, as Jay, you heard Jay this morning talk, we're partnering with Jay. We've got some samplers on some pea filters. We've got some samplers on some wood chip bioreactors, some on some of these pea removal structures. We also have been partnering with Greg Labarge and others. We have 12 plots at the OARDC site in Hoytville. But to date, along this, we've got 400 plus site years of data. And so we do have a very, very rich data set. And believe it or not, we still need more data. As you can imagine, there's a lot of variability in that. We're starting to see some trends, but to really quantify and parse out what the impacts are, we're not quite there yet. So the typical setup, again, it's a paired site. We have both the surface and the subsurface at each one of these. And if you know anything about the state of Ohio, the importance of tile drainage in this part of the country, it's not an option, it's a necessity. And so as our historical data, as what we've seen, is when we look at these fields, anywhere from 40% upwards of 100% of the discharge that comes from that field and then associated nutrients come through the tile drainage. We need tile drainage to farm, but we have to understand that tile drainage is also a primary and major transport pathway for these nutrients. So, we're trying to look for methods and different technologies to keep those nutrients on the ground. So let's talk a little bit about the practices. So as we've gone out and Greg and I and a couple other people, we go out and we meet with the producers, we try to sit down and talk about the different practices that we want them to implement. And again, keep in mind, we don't have control of this. This is all on privately owned land. So we're really at the whim of the farmer. So it's great that they're willing to put these things in place for us. So we've looked at, or we have ongoing studies looking at the 4R practices. We've heard a lot about that. Primarily looking at that source, the organic versus the inorganic uses or forms of fertilizer. We've looked at rates, or we have studies going on looking at that zero phosphorus application, a half rate or a full rate. Looking at the timing, fall versus spring. The placement, again, the surface and subsurface placement. We've looked at things like gypsum that was getting a lot of attention here 3, 4, 5 years ago. Maybe not as much today, but we've looked at it as a surface amendment. Also looking at cover crops versus no cover crops on these fields. And what's the impact on the hydrology? What's the impact on nitrogen? What's the impact on phosphorus from that? Looked at tillage, whether that's a reduced tillage or no tillage, or maybe a severe tillage. And I've got some data on that. We've also looked at crop rotation, getting those small grains back in the rotation. And then we talk a little bit about the edge of field, which is where a lot of Jay's work is focusing on. But looking at things like drainage water management structures, looking at things like wood chip bioreactors or P filters. And then we've also done some in-stream work where we're looking at the ditch designs, looking at these idea of a two-stage ditch to create a more of a connection to the floodplain, if you will. So creating that artificial floodplain in the ditch bottom. So what I'm going to talk about today, again, are those three that are highlighted there in yellow, is where I'm going to focus most of my effort. So let's start talking a little bit about cover crops to begin with. And when we think about cover crops, we hear a lot of different things about cover crops, how difficult they are to manage. But we can talk about different ones. The top right is a mustard cover crop. There's sunflowers there in the bottom right. And then we also can talk about interseeding. We hear there's a lot of difficulty in getting cover crops established late in the season after harvest. So this idea of getting them planted during a growing crop. But regardless of those, the different types of cover crops, what I want to just talk about today is really the effect. We're going to talk about two cases, one being the mustard cover crop, the other being a cereal rye, and what our preliminary analysis looks like on those. So when we think about cover crops, if you look at the literature, when we think about that growing crop out there during the winter, we generally think about less discharge. We got more evapotranspiration from those. So generally a 1/2 inch to 2 inches less runoff. But we're creating an infiltration or increasing our infiltration capacity. So we then generally think about an increase in the amount of discharge coming from the tile drainage. Anywhere from about a 1/2 inch to 3 inches is generally if you look at the literature, what that will say. So this is busy. Don't try to parse everything out on this. The point is, we thought we could go into our data, and so we've got about 8 to 10 fields where we're using cover crops. And what we think we were going to be able to see was look at the fields with cover crops versus the fields with no cover crops. But what we see is a mess. This is the water year data. You try to say, well, this is with cover crops, this is without cover crops. What we learned very quickly is there's too much noise in the data. Every field is unique. in itself, every management is different. The way the farmer produces, whether they have tillage or what the historical practices have been on that field, make a difference in what we see. So when we start to see this, it doesn't make a lot of sense, and it's hard to try to determine what the impacts of cover crops are. So we go back, and this is work with Brittany Hanrahan, who is working with us now in a postdoc position. But she did her PhD working at cover crops over in Shadow Ditch in northeastern Indiana. And what they have found were early on in 2013, they started doing some grab sampling data. The watershed only had about 12% cover crops. By 2014 through 2016, that increased to about 67% cover crops. And lo and behold, what we find is there was a significant reduction in both the nitrate and the dissolved phosphorus, or the nitrate in the spring. There was a decrease in the dissolved. That is not a significant number, though. It looks like it should be, but statistically, it's not. But we can say that in general they were trending, at least for phosphorus, that they were less in the fields with cover crops as compared to the fields without cover crops. Nitrate, this is nothing new. We know there's benefits with cover crops with respect to nitrate. That's been well documented. So when we think about cover crops then, they're adopted over a large area. They may influence water and nutrient budgets with their possible water quality benefits. However, the comparison of the nutrient budget across multiple fields, again, didn't show anything. We've got too much noise in that due to the uniqueness of those fields. So what we feel like we need to do is look at this from a case-by-case standpoint. And so that's what I'm going to do now. So I showed this graph last year, and it was 3 months worth of data. We showed that there wasn't really a whole lot of difference with respect to phosphorus, but there was with respect to water, and there was with respect to nitrate. So Steve Davis said, well, Kevin, you got more data. Let's see what the year looks like. So this is what the water year looks like. So when we start to think about this, we do see a 70 millimeter difference or a 35% reduction in the amount of water that's coming out of the tile drains with respect to cover crops. We see an increase in the ET of that, so that's, again, about 4%. When we think about water balances, that evapotranspiration is our largest component. What we do see is a significant reduction in the amount of nitrate from this site, and we also see a reduction in the amount of phosphorus, and this is that mustard cover crop, and this is, again, for a water year. Now, that 33% is not statistically different, but it seems to be trending in the right direction. We do see a reduction in the amount lost there. So again, this is a cereal rye situation. So we have a producer that went in and decided to put cereal rye on one field for us, and he did his normal practice without cover crops on the other. Very similar situation in this case. What we see is a reduction in the amount of water that's being lost or being stored rather on the field, and then same with nitrate. We see a pretty big reduction in the amount of nitrate that is lost. In this case, it's the phosphorus, though it's not as great. And again, that's the reason we put the percentage or the predicted part on here. When we looked at these two fields, the baseline relationship, field 2 always had more phosphorus than field 1. So it's a little exaggerated if you just look at the raw number. So that's why we put the predicted on. But nevertheless, we see a little bit of an increase in the amount of phosphorus coming from this site with respect to cover crops. So when we start thinking about cover crops, we have to start thinking about the water side of things. So managing the hydrology to manage the phosphorus. Cover crops are great. They help address the nitrogen issue, and I think this is something that Chris reminds me of quite frequently, is when we start thinking about cover crops in the state, 2/3 of the state goes to the Gulf of Mexico. The Gulf of Mexico is impaired by it's a nitrogen issue. The Western Basin, as we've heard from others today already, phosphorus controls the size of that bloom, but nitrogen controls generally the toxicity of that bloom. So we need to start thinking about nitrogen, and so cover crops from that standpoint are great. Cover crops are great for phosphorus from a secondary standpoint, saying that the more water that we can control, more evapotranspiration, less water going down the stream, less nutrients going down the stream, less phosphorus going down the stream. So from that standpoint, cover crops are great and one of those things that we should be promoting. So I think I just used or said what was on this slide, but anyway, cover crop, they're more likely to reduce surface runoff and increase tile drainage. And that's affected, again, by what else is happening on the field, those tillage practices, the crop rotations. They're also impacted by the different types of cover crops, the different species that we have, whether it's a single species, multi-species. We have not begun to scratch the surface on understanding those types of systems. And I'm realizing I'm about out of time, aren't I? This is not good. I'm still good? All right. I think Chris has got a speed thing over here on me. So nutrient losses with respect to cover crops, though, again, we need a case-by-case basis to really start to look at that. We can't not just lump things together. So we know they have a big impact on nitrate. With respect to phosphorus, it's a little bit more variable. But secondarily, they should have and I think they do have an impact on phosphorus just from a water balance standpoint. So next I want to switch our gears a little bit and talk about tillage and P loss. So this was a site, again, a paired site, side by side, where we had a producer that wanted to do minimum disturbance or minimum tillage. This is a vertical till tool, so not a lot of disruption when we think about tillage implements versus no-till. And again, we use a side-by-side comparison. So we use the classic paired approach. So when we look at our graphs, basically what we're looking for is to see a shift. We develop a linear relationship, a baseline between those two plots, and then we implement a practice, and then we look for a shift up or down. And what we see in this, and the top graph there is the surface. So after we did the tillage, we see our total P increase. No surprises. We get generally more erosion with that than we do. Bottom graph, we see the subsurface drainage loss actually goes down with that. We get more, we enhance or increase the buffering capacity, if you will. We're mixing that soil up and getting that phosphorus attached to those sediment particles. So it's not leaching, it's not going down. And then the bottom left graph, there's just another way to look at the data. That's a cumulative discharge versus a cumulative loading graph there. And so you can start to see that switch in the drop, if you will, in the field where we did with the tillage. And again, this is for subsurface drainage. So when we start thinking about this, we've got to be very careful. What might be good for tile drainage in terms of reducing phosphorus may be bad for the surface. And so we've got to make sure we look at this holistically and don't get caught up looking at one parameter. Again, another similar study. I'm over time now? No. So P losses and tillage, this is severe disturbance. They were using a tillage implement, the tine, it went down to about 10 inches. So we were really tearing up the soil on this versus a vertical till tool, that just what we had in the last study. Again, if we look at, and this site, the surface flow, we hardly ever get surface flow from this site. So I've just got the subsurface graphs on here. And again, but it's exactly what you would expect. So when we look at the minimum tillage compared to a deep tillage, those losses, that deep tillage is below that. And this was a significant reduction, again, in the amount of phosphorus that's coming through the tile drainage following that severe disturbance. Again, I want to be very, very careful here that we're not advocating tillage because when we do that, again, if we look at this, generally what we think of in terms of tillage and pea loss, the risk of tile drainage losses are generally greater with no-till compared to a minimal disturbance compared to a deep tillage. But looking at the other side of that and thinking of this from a total phosphorus and a large portion of that being bioavailable, no-till, the risk of surface losses decreases dramatically with no-till compared to minimal till or minimal disturbance versus a severe disturbance. So that's our conundrum. We've got to talk about trade-offs and what we want. That water is going to go somewhere. I had rather that water go through the surface or go into the soil and come out the tile than have it going across the surface and bringing a lot of sediment with it. So those are things that we need to think about. So we need more research on more integrated systems that look at no-till, that look at cover crops, that look at the nutrient management. We've got to have more information on those. So next, I want to talk a little bit about a study where we looked at fertilizer placement. We've heard a lot of talk about subsurface placement today, and we feel that is where the bang for the buck is. If we can get those nutrients below the surface. Now, what I'm going to show you today is a study where a farmer put it on the surface, and he actually tilled it in. He got it tilled in to between 2 and 3 inches is where is what the incorporation was. So when we start hearing this idea of 2x2 placement or injection below the row, that's sort of what this is simulating, except this was done with a tillage tool rather than done with the planter or whether done with a strip till unit or something of that nature. But it was compared also to a broadcast application. And again, what we see in both the surface drainage and the surface drainage, when we incorporated it, we saw a lot less phosphorus coming out across the surface when we got it worked in than we did broadcasting. To the tune of bottom there on the bottom right, something like 140 grams per hectare coming out in the broadcast compared to just 12 grams when it was incorporated. So a big difference in what we see across the surface. With respect to the subsurface, that's the bottom left graph. Again, we see that shift downward. That red dashed line it's shifting downward. That's not statistically significant at this point, but it is moving in that direction. So again, and we've got some other studies ongoing looking at placement. I haven't had time to dive into the data, but this is helping us to identify what we think we should be doing, and that is getting those nutrients below the surface is a great start in helping us to reduce what we're seeing both come off the surface, but also what's coming out of the tile drainage. So now I want to switch a little bit to talk about what's coming. And I was hoping to have this study done, but it just didn't happen. This idea of drainage water management, we have two of our pair where we have drainage water management looking at with and without the drainage water management. So we're looking at the hydrology, the nitrate, and as well as the phosphorus on those as well. What we hope to be able to do with this, we've been working with ODA. They gave us the number of structures that they have cost shared on in the state. We've also worked with NRCS and gotten the same numbers. So with those, we should be able to project what the impact of those structures are having out there. We then hope to be able to look at, again, maybe through more of a modeling exercise, but what if we could apply this to all the land that's available or that's suitable for drainage water management, and what would that impact be? And so we can start to get an idea of how much of the 40% we can get by this type of a practice. Also, we heard a little bit about this idea of legacy versus incidental. This is some work that's being done in our shop, but we're really trying to partition the phosphorus transport between that legacy component and that incidental, or that's been recently applied. And so, again, given this year, I think we had 6 fields or 8 fields in our out of the 40 that did not get planted. So we should be able to have some idea of that will tell us a little bit more about the legacy associated with that. And then we've got, again, a lot of data looking at when we do apply, what's coming off of those. So this is some work that, again, I hope is going to be coming off or coming out of our shop here pretty soon. Again, this is some more work. This is some work done by one of my postdocs. I think I talked about Brittany Hanrahan earlier. We're doing a multiple linear regression analysis, taking all the data that we have out there and examining the controls on both the surface and the subsurface flows and nutrients. So you can see, don't expect you to be able to read the graphs, but those are just the top graphs, the relationship sort of with precipitation. You can see a lot of scatter. What's causing that? And then at the bottom, we start to throw in a lot of these parameters that we want to look at, whether they're landscape related in terms of field physiographic characteristics, the slope, the soil dominant series, the contributing area. We put then we put the practices in there too. What are the farmers doing? When are they planting? What are their tillage? How severe is that tillage? And we hope to be able to predict what is coming out of that. So now I'm going to switch to the collaborations that we have, and you've heard a little bit about this morning already from Jay. This idea of pea removal structures is some collaboration that we've had with Chad Penn at ARS in West Lafayette. We know the technology is effective. It's a new application of the technology to tile drain landscapes, and so that's what we're trying to understand. We've had some difficulty. We've put 2 or 3 of these in already, and they've already become saturated. And so we've had to reset the system. We've had to go in and pull that steel slag and other materials out, put new materials in. So these things we're looking at different hot spots for these. But because we have these flat landscapes, the hydraulic head is a very difficult situation. But we're working on that. We do think that they do have a place out here in the landscape, especially for these hot spots in places like Jay is trying to address. This is something I'm really excited about. We just submitted a paper on this. Matter of fact, we just got comments back from them. This is some work that I've been doing with Audrey Sawyer at Ohio State in the Earth and Atmospheric, or in the Earth Sciences Department. There are over 14,000 miles of ag ditches and streams in the Western Basin. And so Audrey went in to a couple of these right now with our, at the edge of field sites where we're operating. She's gone in and done some coring. We've looked at all the different pools of phosphorus in those sediments in the ditches. And bottom line is, we generally see the greater losses or the greater potential for it to be more soluble in the summer. But I think what's very interesting, if you look down at that last bullet, if you can read that, based on her analysis and what we've seen coming out just from those 2 sites, it can represent 8 to 27% of the loading that we get on an annual basis, and that's stream sediments. We've not talked a lot about stream sediments and what's out there in that network. So there's a lot of work and a lot of potential for us to do some work there. So I'm really excited about that. I've just approached Audrey to collaborate on another project where we can expand that. We're hoping to more do some nutrient spiraling within the ditches, and looking at some longer lengths of ditches, but also expand that work to more than just the 2 sites. We're hoping to get 6, 8, maybe 10 ditches involved in or part of that study as well. The other thing is, I've been working at the right-hand graph, or the right-hand picture there is, it says I have 2 minutes. I won't go over more than 5. So we've got this idea of sediment, and we all talk about erosion, and we know there's a lot of erosion that comes along the surface, and we cannot ignore that. What we don't nearly a lot of think about is what's coming through the tile drainage and through the macropores. And so this is some work. Bill Ford was a postdoc of mine. He's now faculty at the University of Kentucky. And so they've been actually coming up and going to some of our edge of field sites and actually looking at and measuring the amount of sediments coming through the tile drainage. And so looking at that high frequency data, and then trying to understand the macropore flow and what's coming through those macropores to help try to address the sediment coming through and the bioavailable P that's associated with those sediments coming through the tile drainage. So again, one of those things that's coming down the pike, but we've got, I think, a year's worth of data now, some high-frequency data from one site, and we're going to add another site into that as well. Talk a little bit about model development. A lot of this data modelers like. And so we've got a lot of work going on with SWAT, working with Margaret Kauchik and Jay and others at Ohio State, with Rem Confessor at Heidelberg, and with Limnotech as well. So there's been a lot of modeling that's being done with the data. Working with, again, Rem Confessor and Tian Gao, who are here from Heidelberg, looking at the Apex NTT work. We're also trying to work with Bill Ford and his group to build that macropore routine into SWAT. Looking at DrainMod, looking at sharing that data with North Carolina State University to look at that. Also looking at building drainage routines into WEP at West Lafayette, using the Mike Shee model to do some predictions on different practices. And then also more recently this runoff risk advisory forecast, working with NOAA. So they're using a lot of the data right now to help inform that model. And then finally, looking at this idea of stacked practices. I think somebody called them bundled practices earlier. I call them stacked practices. But this idea of putting practices, both upland practices and edge of field practices, into place to try to address the problem. Again, because we know there's no silver bullets, there's more silver buckshot, if you will. So we have to put a lot of different things together in order to address that. I'm done. Sorry. All right.
Well, thanks, Kevin. Yeah, he was within like the error bars, I guess, for a normal talk, but it's okay. It's why he keeps getting moved later. Yeah, it's fine. So now moving to more of our social and economics, I guess, side of the day today for two final presentations. Next up, we have Dr. Robyn Wilson with Ohio State University School of Environment and Natural Resources. She's a professor of risk analysis and decision science. Talking to us today about designing policies and programs to increase BMP adoption rates. Now you can make up for Kevin.
I'm going to take all the time I want after Kevin. Now, Jay said 12 minutes, so there's time for questions. I'm going to try really hard. I think I only have like 8 slides. So hi, everyone. Yeah, I'm a social scientist. I spoke here several years ago at the kind of beginning, I would say, of a research program where we've been working pretty closely with farmers over the last couple years on a variety of projects, often working on interdisciplinary teams, trying to better understand farmers' use of different conservation practices, and then trying to model when we see differences in that use or that adoption, why might that be? And then to start to reflect, once we have that input from them, on whether or not our current programs and policies are really addressing those key constraints and barriers and really leveraging the sorts of motivations that are out there. So when Jay asked if I would speak again, he said, do you have new things to present? And then I was laughing because I literally have 6 data collection efforts going on this year. So in a year or two, I'm going to have all kinds of new things. But what I'm going to do today is double down a little bit on some of the messages that I shared with everyone a couple years ago, but reporting on some newer data that we collected between 2016 and 2018 as part of a project that Kevin led, actually funded by the 4R Research Fund. And so I'll highlight a little bit of the kind of the state of adoption of practices, talk a little bit about the extent to which I think voluntary programs can work based on what we're seeing in our data. And then what I think Jay really wanted me to maybe double down more on was, what can we actually do about that? So when I talk about these things, a question I often get is, okay, well, if farmers don't believe practices work, how do we convince them that practices work? So I'm going to reflect a little bit and maybe take a line from Laura's presentation earlier and walk away from my data for a minute at the end and talk a little bit about what we might be able to do to address some of the challenges that we're finding. So that being said, I already kind of hinted that a lot of what I think about is
Voluntary adoption, this is our go-to mechanism for engaging farmers in conservation. It will probably continue to be our go-to mechanism, and when I talk about voluntary programs, I'm talking both about outreach and education and about incentive-based programs, right? So in both cases, we're not making anyone do anything. With outreach, we're out there trying to help people think differently about something, try to convince them maybe something works so that they go out and do it on their own. With incentives and subsidies and other kind of government programs, we're trying to offset those short-term costs. And the idea being they don't have to love the practice, but we're trying to make it easier for them to do it and often just less expensive. And then something that we know from social science and behavioral science in particular is the only people who are going to engage in those voluntary programs are the people who either think that they're a good idea, right? Or those people that are kind of indifferent, like haven't really made up their mind about it, right? So when we go out and we randomly sample farmers and collect their opinions on these things, we might assume there's some sort of normal distribution of kind of attitudes towards different conservation practices, even attitudes towards participating in government programs. And what we would hope is we'd see something like you see on the screen, which is a badly drawn, hand-drawn normal curve, but that we might see that the majority of our folks are kind of in the middle, right? Where maybe they haven't developed an opinion yet about a particular practice. If they have, it's a weakly held opinion or a weakly held attitude, we would say, meaning they could be swayed one way or the other, right? We would hope that we only have a minority that think it's a horrible idea, and we would expect that we might have a minority who think it's the best thing ever, right? That they would run out and do it. So one of the things we're doing with our data is kind of looking then at descriptively at what we're hearing from farmers, and do we have enough people in that kind of middle category with neutral attitudes towards the positive, right? Do we have enough people in that group to even be able to have any kind of influence on them through these voluntary programs? So what you see here is just an average. We did a panel study funded by the 4R Research Fund, collected data in 2016 and 2018, and at both those time points, and this is for the Western Lake Erie Basin, we asked farmers, self-reported, what were you doing last year and what are your plans for next year? So we've averaged that together, so we have kind of 2 time points represented in both of the shaded bars here. And what you see across the x-axis are just different conservation practices that we've asked them about. What you see on the Y is just the percent of farmers in each category of adoption. So the dark gray bar is that average reported adoption over time. So that self-reported, this is what I did last year. The light gray bar is that average intended adoption over time. So it's them saying next year, this is what I plan to do. So what you'll notice is the pattern is not the same across the practices. The 3 practices on the left are kind of standard for our kind of agronomically sensible things. And what we see is that farmers are pretty consistently saying they're doing it, intending to do it, and following through, right? And so we see pretty high adoption levels on those. When we get to the far right, this is where we're getting into things that have been talked about a lot today that are probably necessary, but they don't have quite the pattern we might like to see. And so we see lower adoption rates for things like cover crops and subsurface placement, but we see really high intentions, right? So we see this big gap between what they're actually doing and what they say they would like to do the next year. What that says to me is kind of 2 things. One, it says that we have a bunch of willing folks. We have those folks in the middle, right? The difference between those bars is basically the folks in the middle. I think I put that on there. There, I did. Magic animation. 30 to 40% of our folks are in the middle. And so we're seeing that they would like to do this, but they clearly haven't committed to it yet. So from the perspective of voluntary programs, I think there's plenty of evidence that they can work. Now, I'm sure there are people in the room saying, well, they haven't worked, because I hear this all the time from people, that we haven't reached these goals, we're not seeing the changes we want to see downstream. Well, then I would say maybe it's because our programs aren't designed right, or maybe it's because we haven't been thoughtful about the policies we're putting in place, because there's nothing about the motivation of our kind of target audience in this case that says to me that they wouldn't participate in these programs if we got them right. So that's kind of step 1. So then step 2 is, okay, so that's fine. We have, 60, 70% of our farmers who seem like they'd be willing to participate in these things if we can get things right. So what is really preventing, say, that 30 to 40% from doing what we might hope they would do to help with this problem? So when we go out and we do survey research, or we do experimental work, we measure a lot of different things. We look at characteristics of the individual. How old is the farmer? What's their education level? What generation of farmer are they? How long have they been farming? We'll look at characteristics of the farm. So how large is the farm? What sort of an operation is it? We'll look at a variety of other management practices that are in place. And then we look at the realm of things that I get more interested in as a behavioral scientist, the kind of beliefs that they have about maybe the problem in Lake Erie, issues with nutrient loss on their farm, beliefs about the practices that we're asking them to engage in. And then we can statistically model, right, what's the probability of somebody having a practice in place given all these sets of characteristics and factors that we measure. And so several years ago when I was here, I said what we keep seeing in our data is that farmers aren't convinced they can do these things effectively, and they're not really convinced that even if they did, that they would solve the problem. And so I'm going to double down and say that's still true. So across several studies now and several different types of practices, one of the factors that keeps coming out time and time again is this idea that if we can move farmers from having relatively low confidence in their ability to implement these things to high confidence, low belief that these practices work to high belief, we see a very large increase in the probability that they put the practice in place. In fact, it's about 10 to 15 times. So when we move someone on our standardized scale from low to high on this idea of kind of efficacy, we'll call it, we see that they're 10 to 15 times more likely to have the practice in place. So there's something going on with, well, one, the folks who aren't interested at all, they really don't believe in these things. But even those folks in the middle, they tend to be kind of mid-range on that scale. And if we can shift them up and convince them that this is doable and it's effective, we would expect that they would sign up for these programs. We would expect that they would try these things out. So here's another kind of take on the data from the same 4-hour panel study. But what we did here is we actually just took their responses over time and assigned them to different categories. So what you see on the far left are the rejectors, which sounds kind of harsh, but I feel like now I should have rethought that word. But these are people who consistently were not using subsurface placement or cover crops. Okay, so these are consistent folks who from 2016 to 2018, you can see it's 50 to 60%, depending on the practice, were not doing it. What you see next to them are the consistent adopters. So these are the folks who were consistently doing this thing across time. Again, that's 15 to 20% of our farmers. What's interesting is when you look at kind of their prior intentions and their belief in the practices and their confidence in their ability to do it, the rejectors have the lowest efficacy and the weakest intentions. So they're just doing what we would expect them to do. Behaviorally, this isn't a good idea. They don't intend to do it. They're not going to do it. What we see on the right is these are the folks with the really high intentions and the really strong beliefs. They're often very conservation-minded farmers, and so they're going to keep doing it regardless. Who we're really most interested in is probably these last two guys, right? So this is the 30 to 40%. Literally, if you add it up, it's the 30 to 40%. And what we're seeing here is they're swapping out. And so what we had hoped, and I actually think of Gail Hess every time I talk about this project, because I remember meeting with her, and she's like, I can't wait to see what you find and what the rate of change is. And I was like, well, Gail, it's 0. I'm sorry. But what's actually happening is we're kind of swapping folks out, right? So we have the new adopters and we have the discontinuers. And so we get some 10 to 15% of farmers who over that time frame say, yeah, I tried it, I'm not doing it anymore. We have a similar 10 to 15% who say, I wasn't doing it and now I'm trying it. And so that to me is one of the big challenges because we're seeing people trying these things out, but it's not sustainable. And we can, and so I'll give some ideas about why I think that is or things we could do different. But for cover crops, one example is that my 3-year incentive-based program ended, I wasn't seeing any returns, and so I stopped doing it. Or I was doing subsurface placement, but the weather didn't cooperate the next time you asked me, and so I didn't do it, right? And so there's all kinds of reasons why we can imagine this happening, but unless we address those reasons, we're gonna probably stay at a pretty low rate of change over time, because we might keep seeing this kind of swapping out. And interestingly, these people do have the most kind of moderate efficacy and intention, so it does kind of line up well with what we're seeing in our other analyses. So what I want to wrap up with is where I'm going to step away from the data a little bit and try not to act like I'm giving policy recommendations, because I'm not, but I'm putting on my hat as a behavioral scientist who knows something about theory of behavior change, who knows something about what tends to work in outreach and engagement, and who knows something about what farmers think about these things. And so reflecting on all of that, these seem to be some of the things we might want to consider moving forward. So we definitely know that our farmers have a desire to take action. We see high levels of concern and responsibility and willingness. But as I've said, they lack confidence in their ability to effectively implement practices that they aren't really convinced will work. So what do we need? We need programs and policies that do two things, right? That build confidence in one's ability to do cover crops, to implement subsurface placement. So this means more affordable. It means less time intensive. It means generally easier. Farmers are dealing with shorter and shorter windows. This is a classic kind of example this year of how challenging it can be to even do regular farming activities, let alone the extra things we want them to do. So unless we figure that out, it's not going to happen. We need to build confidence in the practices, so demonstrate and communicate when and under what conditions practices are effective. Kevin's work is critical to this, the SWOT modeling work is critical to this, but we need to do a better job of showing that you did X and Y happened, good for you. Because as humans, we want reinforcement, and positive reinforcement is the only reason we keep doing anything. And right now, we're not giving a lot of that positive reinforcement to our farming stakeholders. How do we actually kind of operationalize that? How do we do this? Well, if you're going to mandate anything, you mandate the easy practices, right? Soil testing, things that farmers have bought into, that make agronomic sense, that are economically feasible. Those are the things that we could require should someone want to do that. For the harder practices, right, which is a lot of the things that we really want them to do, cover crop, subsurface placement, other things, we need to design more thoughtful incentive programs. So I always find it kind of interesting that for cover crops, we have 3-year programs when we know it probably takes 5+, I don't know, someone help me, years to see any economic returns. 5, I'm getting a 5. That's a horrible mismatch in policy design. So it's not a surprise that farmers might enroll but then drop back out when they're not seeing a return. I know Iowa and Illinois have these really successful programs right now with reduced insurance premiums for cover crops, the logic being that insurance companies may end up footing that bill if they see more resilience and less claims on insurance. So I think there's a lot more creative things we could do with the way we even incentivize. We have to think creatively about how to deal with time constraints. So Kevin gave the example of interseeding with cover crops, but we have wet conditions, we have short windows. A lot of the things we ask them to do just become impossible in a given year. And so how are we going to help farmers overcome that? I haven't heard this come up a lot today, but we have to address the issue of rented acreage and landlord agreements. 50% of the land is rented, and when you look at the kind of, again, I'm going to call them easy, but the classic 4R practices, soil testing, things like that, adoption rates are similar on owned and rented land. When you look at cover crops, you look at drainage water management, you look at anything else more complicated, the adoption rates drop way down on rented land. So unless we start to think about that and address that issue and bring landlords into the conversation, I don't think we'll make the progress we need to make. And so those are kind of for some of the really hard things, but generally we need to remove those practice-specific barriers. So the solutions that we've heard the whole, it's not one size fits all, it's the same thing practice by practice. What's gonna help farmers use cover crops is gonna be different than what's gonna help them use subsurface placement. So we need better access to equipment. I know ODA, is anyone left from ODA? Has $30 million to spend next year, buy a bunch of implements and find a way to create cooperatives. Think creatively about how we deal with that problem. Longer programs for cover crops, already talked about that. This will get into the world of things Brian hopefully will talk about next, but better cost benefit studies, right? And so it's very hard, I've noticed, to find really good studies on what the actual return is on a given practice. Especially given maybe someone's baseline and kind of where they're starting from. And so until we can demonstrate that economic return, then even our decision support tools that talk about nitrogen and phosphorus reductions aren't going to be convincing to folks, right? Because that needs to be translated into a metric that's more meaningful. I'm all for field scale decision support tools. I know there's at least 2 that I know of out there. I don't know to what extent they're being used to help farmers think through scenarios. I don't know to what extent they're effective at helping farmers think through scenarios, but thinking more about those tools as a way of helping a farmer think through what might work for them, what might those returns be, but maybe integrating in economic data and other things would make them more effective. And then long term, and this is like, I know Doug was here, I don't know if he's still here, but this is the world of sociology, but we need a cultural shift. So we see pretty consistently, and a meta-analysis just came out of Purdue recently on this topic, but we see pretty consistently that conservation adoption rates are much higher among the farmers who identify as conservationists versus solely as productionists. And so until we get kind of a cultural shift where farmers say like what we do is conservation and what I do as a farmer is conservation, we'll probably still struggle a bit to get to those levels that we need. And what we've seen in some of our recent analyses is that it's not just that a conservation-minded farmer does more, but a conservation-minded farmer believes more in the practices, and that's why they do more. And so it begs the question of, can we convince production-minded farmers that the practices are effective? If we can't show those kind of economic pieces, then it might be hard to do that. I know I'm out of time, it's flashing at me. So thank you, and I think we'll have questions at the end.
Okay, The final speaker for today before we do a question session at the end and then some closing remarks. But lastly, we have Dr. Brian Rowe, also from The Ohio State University in the Department of Agricultural, Environmental, and Development Economics. His title is Triple Bottom Line.
Changed it a bit, but that's it.
Well, adapting all the time, remember? Okay, so time.
Great. Thanks so much. Today, I've been working on several projects with Robyn and Jay and others at Ohio State, and I'll share with you just a little bit of insight that we've pulled from a couple surveys about farmers' willingness to adopt nutrient management practices. The theme of voluntariness and most programs requiring voluntary buy-in has been critical. And obviously one of the great policy mechanisms that are out there are incentivized programs. And so the data collected here was an attempt to look at and calibrate possibly what is a per acre cost to incentivize farmers to adopt programs. Obviously there are costs to any item to buy, to purchase, to change the process, but change is hard, and inducing somebody to change is a costly endeavor. And so this data will provide a little insight into how farmers in these surveys viewed exactly how costly that might be in terms of the amount of money it would take them to induce them to actually undertake a particular program. We embed this in a kind of a bigger view of how we're viewing the whole process here, where we've got at the bottom here a cost-benefit analysis is the ideal that we could do here to understand what the cost of policies might be to induce farmers through voluntary programs to undertake the various nutrient management programs that we identify as being effective, and then feeding through the biophysical systems into changes in those ecosystem services that the citizens of Ohio and those near the Great Lakes value. And then obviously we'd love to be able to compare the values created from those improvements in ecosystem services to the cost undertaking to see if those balance out, or hopefully that we're generating more benefits than costs. This data will help us start to calibrate that process, but is by no means the end-all or be-all of that. Way back in 2012, it seems like so long ago, were some of the first studies that Robyn, myself, and others at Ohio State started to undertake. And we talked to farmers through mail surveys. Here's a little view of the sample that we looked at, where the farm sample that we got involved were a little bit larger than average, a little bit higher in terms of sales, a little bit higher in terms of off-farm income. A bit about how we targeted the survey, trying to connect with those farmers who had a good deal of land available to them to play with in terms of their farming practices. The question that we use is a type of question used in the marketing literature to try to understand how to design new products, to understand what the value of adding a new feature might be. It's known as a choice experiment, or in other fields, a conjoint analysis, where we describe a couple of different programs, talk about the features of that program, and then as part of the survey, have farmers choose whether they would prefer program A, program B, or would rather just sit this one out and don't think either of them is much to write home about. And here we changed randomly the paperwork burden, the width of the filter strip. In this case, it was a filter strip program that we were looking at back in 2012, and then the payment that they would receive if they undertook the program, and we had them rank those. And then through statistical analysis, we could then tease out exactly what each of these features might translate to in terms of the cost of a program. And so we could analyze this and figure out which features of the programs were more attractive to potential people who would adopt this. Not too surprisingly, higher payments are always attractive. Narrower filter strips taking up less of that valuable farmland were more attractive, and less paperwork. Time spent in paperwork was much more attractive as well. For some responding farmers, programs that were perceived to cause less runoff were also more attractive. And this goes to Robyn's point about perceived self-efficacy. If they believed in that, we could get them to adopt that program with a smaller payment. And it makes sense. In this case, wider filter strips generally seen as less likely to cause runoff and were seen as being more efficacious. Length of contract, there was some give and take there. Some like longer contracts, as many like the shorter contracts. When we decided to simulate out what it might cost to actually get participation in such a program, we conjured up a program that might be 5 years long that involved placement of 25-foot filter strips on an at-risk field, required about 10 hours of annual paperwork, and then we assumed that the farmer perceived a normal level of effectiveness with respect to the filter strip stopping runoff, and we actually dove a little deeper and had them assess how likely it would be that a 1-inch rain event in June would be stopped by the filter strip. Group 1, we had a couple of different groups here that kind of clustered, and that represents about 60% of our sample. Not necessarily 60% of all farmers in the Western Lake Erie Basin. Our sample may not be getting a perfectly representative sample. About 60% said that no additional rental fee would be needed, just purely the reimbursement for the cost of establishing the filter strip would be enough to have them adopt the practice. And again, this is the group that probably saw this as efficacious, that would work, and they didn't need a big push, just a little help with a cost coverage of that. The other group, perhaps those who did not see this as efficacious, about 40% of our sample would require a pretty hefty annual rental payment, in this case of about $380 an acre for that filter strip land dedicated, plus the cost reimbursement to be willing to adopt. So we do see that gradient of a group that would adopt with a fairly minimal incentive and those than others that would require a lot more push to get into that program. If we wanted to, for example, enroll 33,000 acres of edge of field grass filter strips over 3 years, we kind of put the numbers to the test here. We also used statistical techniques that allowed us to kind of tease out different willingness of participation from the farmers in the sample. Here we simulated a program that would cover about 3 years of rental payments, 100% cost share for establishing the filter strips, about 5 hours of paperwork on average, and then technical assistance costs to make sure those got installed appropriately. The estimated cost for that was about $21 to $24 million to get 33,000 acres into these filter strips. Again, this is 2012. Filter strips aren't as much in the conversation right now, but back then that was seen as a potential go-to approach for addressing phosphorus issues. We did this again a couple years later and looked at a broader set of things. Again, the 2014 survey, a little bit broader participation in this one. I think here we looked at farmers throughout Indiana, Michigan, all that might be in the Western Lake Erie Basin. And again, some little vision of how these farmers stacked up against other farmers in the area according to census. And again, we had a nice coverage of farmers who were primarily conventional conservation or no-till in this sample as well. Here we asked them about programs, again, a program A, program B, against your current situation. And again, we talked about, in this case, whether cover crops would be planted or not as part of a program that they would jump into. We talked about paperwork burden again. We talked about nutrient application restrictions to certain levels, either below 30 or below 15 ppm, whether they'd have to use grid sampling and variable rate nutrient applications or not, and then, of course, a rental payment that they would be provided to adopt this. Very similar thing, and so, again, we kind of looked at the payment per acre to induce adoption here. And again, the program here we looked at lasts about 3 years, about 10 hours of annual paperwork, requires winter cover crops, so we're bundling several of these things together, as Kevin and others have talked about, required grid field sampling and variable rate nutrient application, and then keeping phosphorus under that 30 ppm. And for that, the range, depending on how we modeled it, ranged between $260 and $360 an acre for participation in that, again, for an average farmer. If you had that same program, but made it even more stringent in terms of the phosphorus cap, that bumped up, again, by about $80 per acre in terms of that rental payment that would get them to jump into the program. Same as the first program, but you actually didn't require a particular limit on the phosphorus than the average payment required to induce adoption goes down to about $200 to $330 per acre. And then if you drop the paperwork requirement from 10 hours to 2 hours a year for paperwork, we actually get a huge drop in the people's willingness and the payment required to induce people into the program by a considerable amount. A couple things to note about these figures. These are the average for that sample. Again, we'll probably have a number of that would be willing to jump in with very little incentive, and then we probably have that tail as well that requires a substantial payment even above and beyond this average to even consider this. Our what do you call them? Well, we won't use the term, but the group that seemed to be very set and probably didn't view these as very efficacious. Perhaps another take-home point here, and this goes to the ease of doing this, is that paperwork is perceived among this sample of farmers as being a huge barrier to adoption. And if you can reduce the paperwork burden, there seems to be much more willingness to engage in these voluntary programs. And again, I think our data, and we don't show it here, but the perceived effectiveness of the program as farmers see each of these elements as being more efficacious, more able to actually reduce runoff, that willingness to adopt these at a lower and lower rental rate definitely does come to play. So I'll stop with that, and I have 4 minutes left in mine, so I win.
Can all thank Brian for getting us back on track. Okay, if I could have Kevin and Robyn up on stage. So same format as the previous two sessions. Anyone who has questions for the three speakers up here, please go to the microphones in the middle. I know. Okay, Felix is running on over. Take it away.
For the social scientists, could you distinguish between the farmers' perception of efficacy in terms of the practices, as whether it would help reduce loss of phosphorus in their field, or be effective at actually solving the problems down the field, like the HABs and hypoxia issues?
Yeah, so when we measure efficacy, we measure both those things. So we look at kind of the likelihood that the practice would reduce nutrient loss on their farm/field, and the likelihood that if enough people did it collectively, it would solve Lake Erie water quality problems. And we see that those seem to be highly correlated. And so we don't see it, because we were curious if it's more an issue of like it doesn't work on a field or it's just a lost cause collectively, but it seems to be that they kind of equally believe or don't believe those two things.
And for our data, it was just at the field level for on their own property. But efficacy is critical. And as we saw from Kevin's data, there's still a lot of scientific uncertainty about whether a practice is going to work on a particular field. And so I think that is a major hurdle as we think about this as being essential, that we have to be able to provide that advice and make farmers feel confident that this practice is working on their field before any of this can really take off.
Primarily for Kevin King. Is there any cross-checking of data as to the actual soil health condition of the areas where you're doing? You know, to put cover crops on for 1 or 2 years, the impact on the soil health is really not going to be there yet. But if there's some way to actually indicate whether the actual soil conditions as far as soil health are being evaluated with the actual outputs, I think that might be very, very helpful, because it takes 5 years for cover crops to really engage, and there are other practices involved. In talking with Jerry Hatfield and a few other people this last summer, it was indicated that any sort of vertical tillage may be the worst thing that you can do with the soils. So anyhow, in a lot of the conservation tillage is vertical tillage.
Yep, great question, and I'm sorry I didn't hit on it when I gave my presentation, but so when we talk about cover crops, that's a point I should have made, is that you're right. That's a long-term impact, and we are what I would call in more transition with the cover crops. So they've been in 1, 2, 3 years. We've not had that long-term component of that. With respect to the soil health and its relation, in 2015, we made our first, we started doing soil samples at all of these sites. In 2017, we took cores to answer the soil health question. So we've used different metrics. So I think we've got, if you look at the soil health definition, I think there's 60 different metrics that they use within the soil to come up with that score for soil health. We're measuring approximately 30 of those. It's just a cost issue. We can't do them all. So we do have, or we are, and again, we're scheduled to go out this fall to do that same soil sampling again. But we are trying now to relate or get a soil test or soil health score for each of those fields, and hopefully going to be correlating that with the water quality data. So yes, that is on that, and again, that's one of those things coming, but it's not, we're not quite there yet. So.
Well, I'd like to add to that about soil organic matter, you know, as it's related to soil health. Every time I see a yield trial, particularly nitrogen response in corn, I wish they'd add a column that had the organic matter on it, because there's a lot we can learn about whether we're sequestering carbon or not, and whether our absorption ability of the soil and water holding capacity is going up or going down. And I'd love to see Ohio State say every extension agent that's going to show a yield response has to have a column from the Ohio State organic matter calculator, you know, which exists.
Yeah, Vinayak Shedekar was here. He helped put some of that together with Rafiq Islam and for that organic matter calculator. Again, that's a great point. It's one of those things within the soils we are measuring, but I agree with you. I think we need that metric to go along with the other data.
Okay, I think that's it for the second afternoon session. Last but not least, we have some closing remarks from Jay Martin.
All right, I know y'all want to get out of here, so I'm going to make this quick. First of all, I want to give another round of thanks to some important people. First of all, thank you to everyone who came. We had an audience over 350 people here today, so that's great. Thank you so much for coming. Thanks to all the presenters, both oral and those of you who presented posters today. We couldn't have done this without you. We also couldn't have done this without our sponsors, so another thanks to them. And I want to give a special shout out to the Great Lakes Commission. They have a real cool blue accounting tool. They'd love for y'all to visit that website or visit their booth on the way out. They have some literature about that. It's a very neat tool, and I invite you to check it out. I also want to give another thanks to Jared Morrison, and Shalise Simmons. They were the event coordinators today. None of this could have happened without them. Jared, actually, special shout out to him because he's had bronchitis for the last 3 days. And we finally convinced him to leave. I think he left around 3 o'clock. We were trying to get him to leave all day, but he stuck it out for a while. So thank you very much to Jared. Thank you to Joe and the AV team, the great tunes they played earlier, the caterers, and the crew at the Stranahan. 2 things I want you to know before you leave. Please complete the post-conference survey. We try to have panels in response to your needs. We're talking about what kind of panel we'll have next year, what type of sessions we'll have next year. So if you have ideas about those, let us know. If you have any other ideas, let us know that as well. The presentations that you saw today, you will be able to access those later on the web. We do have a couple of requests regarding that. If you do use material from those, please properly attribute that material to the author that presented that. And we also ask that you represent that data accurately with regards to the tone and how they presented it today. So those 2 requests we hope that you will honor in the future. With that, hope to see you next year, and have a good evening. Thank you very much.